So, welcome everyone to the second day of the first IAHR Young Professionals Congress. My name is Eva Finrich and I am the chair of the Education and Professional Development Committee of IAHR. And we had a great first day. So I'm really looking forward to this second day. The first day was opened by IAHR President Joseph Lee, and then we had presentations by many of our young members and also non-members, and some wonderful mentoring that I could see in the sessions that I attended. And also we had a keynote lecture on the Sustainable Development Goals. So I think what we've already seen is a wonderful start. And let's go into the second day. So I'm going to tell you a little bit about Education and Professional Development Committee and what we're doing. And we'll give you an overview of what's going to happen today. So who are we and what are we doing? So the IAHR Technical Committee, so we're a technical committee. Our committee was formed 25 years ago based on the work of a task group. And this was started by Professor Helmut Kobus. And our committee is aimed at enhancing technology transfer in a variety of aspects. So education classically as transferring knowledge to the next generation, a dialogue between practicing engineers and researchers. So education and learning on all levels, and also continuing education for engineers. So I think this Congress also fits quite well into the scope of what we're doing. So this is our group of current members of the EPD committee. You've already met David Ferraz, who's vice chair, and you will meet a few of our other members later on today and hear from them. So what are we currently doing? You're all attending the first thing on the agenda here, the first IAHR Congress for Young Professionals. You've also heard from David that there's currently a task force for young professionals networks, and David is involved there and some others. There's also the webinar series. So the first webinar has already happened. And we're currently planning a next webinar for young professionals, how to find a good job. I think that's a pretty important topic for most young professionals and generally for members and non-members. As those of you who've already attended yesterday, you might know about the Young Professionals Hydro Environment Challenge. Registration is open, so please, if you're interested in that, go to the webpage and register. We've prepared special sessions for the IAHR Europe Congress and for IAHR World Congress. However, as you all know, in the current COVID situation, things are being postponed. So the special session for IAHR Europe is going to happen in the online format. We're also planning a special issue for the journal Geoscience Communication. And we're planning different activities around the congresses, just generally. So we hope that we can arrange for a job fair, some life, young professionals challenge, etc., etc. So there's lots and lots of activities going on, and most of them are very much linked to what's going on for young professionals. And just a quick reminder about the Young Professionals Hydro Environment Challenge. So this is an overview of what's happening there. So there is different topics: fluvial hydraulics, eco-hydraulics, hydropower, water supply. And we would highly encourage you to register for that. And yeah, this is about it for what EPD is currently doing. Well, not quite, because I'm going to hand over to Jose Carrillo to talk a little more about some of the details, what's also going on in terms of Latin America. And then we'll also hear from Maria Bermudez about some of the activities that are planned for the IAHR World Congress. So this is it from me. Here is an overview of what's gonna happen today. And as we have over 900 participants registered for this Congress, I think we will have some exciting discussions happening today. And I'm going to hand over to Jose Maria.
Okay, thank you, Eva. Thank you for the presentation. Welcome, everybody. I'm going to talk just a little bit about some activities that we currently are carried out in the committee. Wait a moment. I would like to share my screen. Okay, I'm, as Eva said, I'm member of the Committee of Education and Professional Development, and also I'm part of the Congress Organizing Committee of this one. I belong to the Universidad Politécnica de Cartagena in Spain, and I've been involved in the association for a lot of years. Firstly, I was president of one of the YPM groups in Spain, and right now I'm the student advisor of the current Spain YPM. Regarding the Latin American journal that we have since 2017, we launched this idea in a Latin American Congress held in Lima, in Peru, with the objective to find three different goals. The first one, we wanted to create a real communication between the different YPMs that we have in Latin America. We have many groups there. You will see in a moment in the following slides. We also wanted to increase the visibility of the young member. It's terrible that very good, very interesting studies, research studies on professional work are finishing and gathering dust in a drone. We want to create a media, a support for all those studies to gain visibility. And we also want to promote the participation of the young people in international conferences like this one and in different scientific publications. In many cases, we can find that the problem is the lack of economical resources. And with this support right now, with this journal, and with this Congress, online Congress, we can reduce the economical problems that many of our young members have. We wanted, okay, wait a moment. We wanted to find different opportunities, in this case, with the Latin American journal, and all the communication need to find several requirements. First of all the paper need to be original and unpublished contribution. The main author must be one of the need to be a YP in a YPN. And we wanted to maximize the contributions, so no more than one paper per main author. In order to have a first experience and receive the feedback for experts, we limit the articles to only 3 pages in a 2 columns template, and later with the support, with the feedback of the experts in the fields, you can promote your work, your studies to a full extended abstract in a congress, or in a journal. All the contributions undergo an anonymous peer review, and in this peer review process, we can see, or we validate if the paper is ready for publication or not. And of course, the author must follow the ethical code of the journal. This is the main structure right now. I'm the main editor of the journal, and we have different associate editors. Usually there is one associate editor per YPN in Latin America, and as you can see, we have up to 8 countries: Chile, Colombia, Ecuador, Spain, Panama, Peru, Portugal, and Venezuela. And the different members of our association are doing a very interesting job, a really good job, following the article, doing the different activities related to the associate editors. And we are obtaining very good papers in both languages, in Spanish and in Portuguese. As future actions, we have a new call open until the end of January. We want to increase the indexation of the journal and the presence in open science repositories. We also want to increase the edition characteristics. This is, for instance, the paper available in different formats. Increase the authorship identification via ORCID or other platform. And we also are going to explore the possibility to launch a new journal similar like this, but in English for all the YPNs. Regarding this Congress, the first Young Professional Congress, all the proceedings are going to be published online under Creative Commons license in the media of the association. And as Eva says, and also David says yesterday, a selection of the abstract will be invited to write an extended paper for for a special issue in the Journal of Applied Water Engineering and Research. For my part, this is all. Let's move. And I will invite right now Maria Bermudez to present the different activities that they are going to continue online during the Granada World Congress. Thank you.
Thank you very much, Jose Maria. Let me share my screen. So, well, as Jose Maria mentioned, my name is Maria Bermudez, and I'm a research fellow at the University of Granada in Spain as well. I'm here today as part of the organizing committee of the next World Congress of the IAHR that will be held in Granada, and which is, as you know, one of the most important activities of the IAHR. I'm actually one of the youngest members of the organizing committee. I wanted to highlight this because, well, we are in an IPN Congress, and I'm actually been recently selected as co-chair of the International Steering Committee of this conference. And I think this is a clear evidence, a very strong sign of the commitment of the IAHR really to support young scientists and young researchers and professionals. And I also can assure you, being in the organizing committee of the World Congress and in direct contact with the people at the IAHR, that this is really the case, and that we are all working really hard to make the next World Congress a great event for everyone, but particularly a great event for young researchers. Well, as many of you know, the Congress has been postponed due to the pandemic situation, and it will be celebrated instead of 2021 in 2022. This is, of course, very unfortunate, but I think the wait is going to be really worthwhile. First, because it's going to allow a face-to-face meeting, so we will really physically gather, like we are all very much looking forward to. And we will gather in the city of Granada, which is really a fantastic city. It's not my city, so it's not like I'm selling you my own city. It's not where I'm from. But I can assure you that it's a fascinating city that has something really for everybody. It has culture, it has history, it has nature, really all in one place. Another second aspect that I would like to highlight is that we will have a very strong IPN program in the World Conference. It will go beyond the sessions or the technical workshops. One of the key activities that Eva already mentioned will be the job fair. The Committee on Education and Professional Development is organizing this event, this job fair, and it will gather in one place all the main international conferences, all the main international companies working in the field of hydroenvironment engineering and research. So it will be really a unique opportunity to explore the job market and to progress in your careers. Well, I know that 2022 may sound a bit far, but before that, we also have plenty of activities where you can get involved, and I think that are really interesting for young professionals. One of them is the next World Congress Online Forum that will be held in the original dates of the World Congress, so it will be in July 2021. And here, the technical committees of the IAHR will organize several activities around the main themes of the World Congress. So again, there will be something for everybody working either in whichever topic really you work, you will find something interesting there. You have the possibility to engage with more senior renowned experts. You will have the possibility to interact with the technical committees. So I think it will also be a great event and really very interesting for young professionals. And I also want to highlight, as my colleagues did, the Young Professional Hydroenvironment Challenge. So Eva mentioned it a little bit. Also, David Ferris introduced it, presented it yesterday in the opening. There you can see the link to check on the details, but well, I can assume that more or less you know how it's going to work. What I would really want to highlight is that it is really a unique opportunity to work on certain skills that have become essential for career development, and that it's not really easy to find training on this. So you will work on team building, you will work on problem solving, on creative thinking. So these are really things that you cannot find everyday training for this, and you cannot find a proven activity where you have developed these skills. So I think this is a really interesting opportunity. And this is mostly it from my side. I invite you to stay tuned, to get involved and to participate in these activities. And well, also on behalf of the organizing committee of the World Congress, I invite you to send any suggestions you have on the IPM program, or in general, any ideas that you think could make this event more attractive to you or more useful for you. And we are really open. We have still some time, given this unfortunate postponement, we still have some time to define things. So really looking forward to receiving your input on this. So this is all from my side, and I give the floor or the screen back to Eva. Thank you.
Thank you, Maria. So it looks like we still have a little bit of time before we move into the first session for today. So what I would like to do is invite questions from the audience. Maybe if there's questions about what's going to happen in Granada, or if there's questions about the EPD, you're welcome to put them in the Q&A. If there's anything or any proposals you have, that would be wonderful. And also check out the link to the challenge that's already in the chat. And I'm just gonna share the program for today yet again, so you can have an overview. So in the next session, we're gonna go again into 2 different rooms. So in this room where we're here today, right now, there's going to be a session on coastal engineering and groundwater hydraulics. And in the other room, we'll have a session on sediment transport and experimental methods. And then yet again, just like yesterday, the coffee breaks with the mentors. So far, it looks like we don't have any questions so far. So I'm really looking forward to the whole day, and maybe everyone just needs to grab a drink before we move on to the next session, starting in about 5 minutes. Thank you.
Thank you.
Thank you.
Have a great day, everybody.
Yeah, have a wonderful day.
Okay, just to add, the next session on coastal engineering and groundwater hydraulics will happen in this room. So you don't need, if you want to stay in this session, you don't need to move out and log in again, okay? See you in a bit.
Hi, David.
Hello, good morning, Zigo.
Good morning.
Is it Zigo, the pronunciation?
Yes, this is Zigo.
Okay, great.
So it's evening or it's afternoon in Europe right now? It's in the afternoon, right?
We're almost going to turn to afternoon. It's still morning. 3 minutes to afternoon.
Cool. Hi, Martina.
Hi.
So yeah, we have the 3 chairs, right? Martina, Zico, and Xiaobing. Okay. So
hello,
let's.
David.
Hi.
Yeah, I just back from field work. Yeah.
Oh.
In a hotel. Yeah.
Okay. So that is evening, I believe.
Yes.
Yeah, right.
Okay, so yeah, let's wait 2 minutes and then we kick off with the session. Okay, we're still loading the speakers.
Very nice.
Great.
Okay, so it's 12 p.m. here in Europe. So I think we can kick off the session. Good morning, good afternoon to everybody, wherever you are. And so in this session, which is on coastal engineering and groundwater hydraulics, there will be chairing Martina Siena, Xiaobing Chen, and Jibo He. And as you may know, the session has 2 parts. First, presentations part, the poster presentations, and then the coffee break, which is supposed to be an open discussion where the chairs they can provide feedback concerning the presentations, and also the attendees can ask questions to the authors, but also to the chairs. Please do not wait until the end to ask your questions. There is a Q&A box at the bottom of the screen where you can click and type your question whenever you think of the question. You don't need to wait until the end. And then the chairs, they will go through the questions by the end of the session. So now let me leave the floor to Zigo, who will moderate the first part of this session. The floor is yours, Zigo.
Thank you, David. Hello, everybody. So welcome to afternoon session, which is coastal engineering and groundwater. So well, I will introduce a little bit about myself. I'm the current chair of committee on coastal and maritime hydraulics. So I'm very glad to chair this session with Martina and Xiaobo together. So as David already said, we will have 2 parts. The first section, we will have 9 speakers. They will present the study one by one, and then we will discuss and answer the questions during the second session, during the coffee break. So if you have any questions, you can tap in, and we will answer and discuss your questions at the end of this session. Each speaker will have 5 minutes, I think 6 minutes maxima. So please take your time when you present. I will introduce our speakers one by one. I think we can just start. Our first speaker is Roger Simons from University of Twente, and he will give a talk about developing an efficient modeling framework to evaluate nature-based solution to counteract estuarine soil intrusion. So Roger, it's your turn. Can you start? Share your screen.
Can you hear me and can you see my screen now?
Yes, it's perfect.
Yes, okay. Thank you, Chairs and David, for the introduction and for organizing. And hello, everyone. Thank you for attending. My name is Rutger Simons, and I'm a first-year PhD candidate at the University of Twente in the Netherlands. And my research is on the topic of modeling nature-based solutions for estuarine salt intrusion. And estuaries, they are the transitional water bodies between rivers and seas. And because of that, both freshwater and saltwater flow into estuaries. And this can cause problems during extreme conditions, for example, high sea levels or low river discharges. Namely, freshwater availability for drink water use, agriculture, and industry can be severely limited. Since saltwater has a higher density than freshwater, saltwater it intrudes inland below the freshwater over the bed of the estuary. And building with nature, they shows potential to reduce this problem, namely nature-based solutions such as sand waves, which are bed forms in the estuarine channel, or wetlands or oyster beds at the sides of an estuary. They impose a roughness on the motion of water, and this way they increase mixing of the salt and fresh water. This way, salt water intrudes less far into estuaries. As the title already mentions, within this research, we will be developing an efficient modeling framework to evaluate nature-based solutions to counteract estuarine salt intrusion. And this will be performed using process-based numerical modeling tools. For this framework, various relevant timescales are identified, and these timescales, they can be separated in 3 modeling approaches, which is also shown in figure 1 here. And in this presentation, I will mainly focus on explaining the 3 approaches, and less so on the entire framework, which is shown in figure 2 here. So on a timescale of days, as you can see in the top of figure 1, extreme events occur, and a 3D hydrodynamic model will be used to study the impact of these extreme events on salt intrusion. And hereby, droughts, storm surges, or a combination of both will be simulated and be studied how it affects salt intrusion. On a timescale of years to decades, we will look at estuarine development. And since we are looking at nature-based solutions, both ecological and morphological development are important. And hence we will apply an ecomorphological modeling. And this will be done in 2D-H instead of 3D to save computational efforts. On a timescale of decades to centuries, climate change affects an estuary. And this is incorporated in the framework using a snapshot approach. And hereby a model validated for the present day conditions is adjusted to represent a future scenario according to local climate change predictions. And subsequently, it is applied to model a snapshot, let's say, a snapshot simulation of the future scenario. And in this framework, I propose the snapshot approach is applied just that first for the present salt intrusion and estuarine development can be studied. Then the models are adjusted to represent, let's say, the year 2100, and the climate change scenario is implemented in the model to represent the year 2100. And then again, in a snapshot of 2100, which I just created, again salt intrusion and again estuarine development is studied. Now, afterwards, we can look at the difference between the present and the year 2100. Onto the expected results of my study. And with this framework, insights will be gained on the development of a whole estuary due to various nature-based solutions, so artificial sand waves, wetlands, or oyster beds under a changing climate, and understanding on how this development related to those nature-based solutions affects salt intrusion will be improved. And that was it for my poster presentation. If you have any questions, feel free to ask them after this session. Thank you.
Thank you, Ruger. It's very nice. And for those who have questions, you can type in and we will answer and discuss the question at the end. So we can move on to our next speaker. It's Josep Low from Seoul National University,
Yes.
South Korea. And you will give a talk about coastal area classification using total suspended matter concentration. So it's all yours.
Yes, can you hear me?
Yes.
Yes. Hello, my name is Hyosum No. Now I'd like to give you a presentation titled Coastal Area Classification Using Total Suspended Matter Concentration. It's important to analyze the total suspended matter, acronym TSM, in coastal areas. But the dominant factors in sediment transport mechanisms are different in each coastal areas. Therefore, we divide the South Korean coastal area using the newly suggested two-level clustering protocol, merging toroidal self-organizing map, SOM, and K-means clustering. The standard SOM has problems such as edge effects or kink on the map topology, like as shown in this figure 1. Therefore, we adapted the toroidal SOM, which is projections the map as cyclic 3D manifold as figure 2 to overcome the standard SOM's problems. And the algorithms consist of 2 steps. At first, SOM projections map as a SOM network, and the SOM network is additionally clustered by the K-means clustering in many iterations. Then these 2 stages are repeated in user-specified iteration number Tmax. And finally, it decides the best clustering case based on the minimum dBi, Davis-Baldwin index. Now look at the figure on the right side. It shows the results we applied to the protocol to the South Korean coastal areas. In the clustering analysis, the 6 variables were considered: longitude, latitude, and 4 concentrations, surface TSM and bottom TSM in February and August. The cluster regions, the optimal cluster number was 6 for the 425 TSM concentration sampling sites. The cluster regions were verified by overlapping this sediment distribution map, and ocean current map, and tidal current map, and form factor map. These 4 compared the physical properties clearly explain the division boundaries as like this. In the progressing paper, we detailed the physical inferences of 6 clustered regions. In this study, we showed that the clustering results showed good agreement with the physical mechanisms. The notable thing was the only concentration and location variables can represent complex spatial temporally varying sediment transport mechanisms. And the demonstrated regional classification results is expected to be useful in focusing study domain, for example, the CFD domain or hazard mitigation. And finally, we show the methodology for data-driven physical inferences for the for the TSM analysis. Yeah. Thank you for your attention. Feel free to question about this study at the coffee break. Thank you.
Thank you, Josep. It's very nice. Okay, let's move on. Our next speaker is Federico Hasper. He will from Institute of National del Agua, Argentina, and the talk is coastal erosion in beaches of the coast of Buenos Aires, Argentina. Please, Federico, can you start?
Yes.
Okay, I can hear you. Can you share the screen?
Yes. Yes. Wait, please. How I can share the screen? Share screen.
You should find. Okay. Okay, it's sharing. Yeah, we can see it.
You can see, okay?
Yeah.
Hi everyone. Hi everyone. My name is Federico Jaspar, and I work in the Instituto Nacional del Agua of Argentina. I am going to present to you very briefly this work called Coastal Erosion in Buenos Aires, Argentina. The idea of this work was to estimate the effect of the increase in mean sea level on the coastline of the province of Buenos Aires under different climate change scenarios. To achieve this goal, I used the Brune rule, which determines erosion due to changes in sea level and depth of closure. The input parameters for the Brune formula are length, dune height, and depth of closure. For depth of closure, I used the 1981. Sea level rise, I used the 2045 and 2100 horizons corresponding to the climate change RCP and RCP 8.5. RCP 4.5 is a scenario where greenhouse gas emissions peak in 2045 and then decline. RCP 8.5 is a scenario where greenhouse gas emissions throughout. While RCP 4.5 is an intermediate scenario of climate change, RCP 8.5 is the worst case climate change scenario. In figure 1, you can see the mean sea level rise for the 2045 and 2100 horizons under different climate change scenarios. For example, the rise in mean sea level RCP 4.5 scenario lies between 40 and 50 centimeters along the entire coast. In figure 1 says meters, but it's centimeters. In figure 2, you can see the results obtained in this work. The response variable in this case is coastline recession. By 2035, the calculated mean recession values of the coastline were 17.8 meters in RCP 4.5 and 19.6 meters in RCP 8.5. For the year 2100, mean recession values were 47.4 meters in RCP 4.5 and 69 polymers in RCP 8.5. The section with the highest values of coastal erosion is the one between the districts of Pinamar and General Pueyrredón. This section is located in the northern part of the coast of Buenos Aires. For me, there are two major conclusions. The first is that the Brew model was helpful to identify the areas of the coast being affected by the rise in sea level for horizons 2045 and 2100. Second, I think this future diagnosis of the problems provides useful information that allows to think about the development of a comprehensive management plan aimed at protecting coastal resources. Thank you very much.
Thank you, Federico. The internet is not very stable anyway, so for those who just step in, you can type your question. We will answer the question at the end of this session. So we will move to our next speaker, Ishita Srivastava from Massachusetts Institute of Technology, USA. And the talk will be dilution of plunging jet used for desalination brine disposal. Ishita, are you there?
Yes.
Please give you, yes, we can hear you.
Okay, I'll start sharing my screen. Okay, I hope you can all see that.
Yeah.
Hello, everyone. I'm Ishita Srivastava from MIT, and I'm going to talk about dilution of plunging jets for desalination brine disposal. So brine from desalination plants requires sufficient dilution to reduce its excess salinity. But even after dilution, brine can spread as a bottom layer because it's heavier than seawater and result in pockets of low DO, which is schematically shown in figure 1. So I'm investigating plunging liquid jets, which can dilute brine, but also introduce air into the water column to avoid this problem of low dissolved oxygen. So the plunging jets that I'm looking at are shown in this figure 2. On the left is what we call an unconfined plunging jet, where there is a jet suspended at some height above the surface of receiving water, and as the jet falls, it entrains air, which is then introduced as bubbles into the receiving water, which can get dissolved and increase the dissolved oxygen in the water. On the right is what we call a confined plunging jet, which is similar to the unconfined, but it also has a confining tube around the jet. So it's just a tube which can help penetrate the bubbles to even deeper depths and increase the amount of water that can be aerated, that can get dissolved oxygen. So for my experiments, I made measurements of dilution. So I added a fluorescent dye to brine and made measurements of its concentration at the bottom of the tank in which I did my experiments. So the measurements were made at a depth of 50 centimeters, which is the depth of water in the tank that I did experiments, but also at a radial distance of 50 centimeters from the nozzle. Okay, so moving on to the results. This first figure in the middle panel, figure 3, shows measurements of dilution for an unconfined jet, which was shown in the left on figure 2. Dilution is plotted as a function of the normalized jet length, which is the distance of the nozzle above the surface of the water. And what these results show is that for small jet lengths, we actually see a reduction in dilution. This is because as the jet impacts on the water surface, it loses some of its momentum. And so dilution is somewhat lower than a jet that's just submerged, which is this dot at 0 LJ. However, we see as the jet length is increased, dilution actually increases. This is because the jet is now falling through longer distance, and it gets accelerated due to gravity and has higher momentum. Moving on to the next panel, I show measurements of dilution for confined plunging jets. And the two variables that I'm looking at the effect of are the diameter and the depth of the confining tube. So this left panel shows dilution measurements as a function of the depth of the confining tube. And as expected, we see that if the depth is larger, we get dilutions that are increasingly lower. And the dilution of the confined jet is smaller than that of an unconfined jet, which is the same as from figure 3 for the particular value of LJ, which is 60. This makes sense because with the confining tube around the jet, there is not enough ambient water available to be entrained, which means less dilution. Now the figure on the right shows dilution as a function of the diameter of the confining tube. And for the values we have tested so far, dilution actually also reduces with the diameter. And this is because with increasing diameter, the jet is not strong enough as it exits from the bottom of the confining tube. And so it does not get enough mixing. However, we expect that if the diameter is increased further, the dilution will start increasing. And in the limit of a very wide confining tube, this should behave almost the same as an unconfined jet and get dilution which is higher, which is shown as this black dot on the right. So those were the results that I wanted to talk about in terms of dilution. I also want to show this figure, which shows the behavior of the bubbles inside the confining tube for the confined plunging jets. So in this figure, there are 3 different sizes, 3 different diameters of confining tube. The left is the widest and the right is the narrowest. And what we see here is with the narrow confining tube, bubbles actually go deeper in the water, which means more aeration. And the dilution also doesn't reduce too much. And those are the results that I wanted to show. The conclusions here are that there is a non-monotonic effect of the jet length on dilution. Also, usually a confined jet, which can help with aeration, leads to smaller dilutions than an unconfined jet. That's it for my poster. I would be happy to take questions in the coffee break. Thank you.
Thank you, Ishita. Very, very cool. Well, our next speaker is Francisco Cantero from Spain.
Hello.
And yeah, hi. You will give a talk about vertically average coastal flow modeling using momentum equations. Right? Can you
Yes.
share your screen? Francisco is from Spanish National Research Council and also University of Cordoba in Spain.
Can you see my screen?
Yes.
Okay. So yes, I'm Francisco Antero Chinchilla, and I'm going to deliver this presentation on behalf of my college from the University of Cordoba. So the aim of this work is evaluating how vertically average and moment equation models, which are also known as VAM model, can be applied or not to simulate complex one-dimensional coastal flows accurately. So first of all, let me introduce the topic. Depending on the environmental conditions, coastal flows involve non-hydrostatic and high non-linearity during wave propagation, and thus a suitable mathematical modeling is normally required. So to reduce the computational cost as compared to the computation of 3D models, vertically integrated non-average non-hydrostatic models, are used in practice. So in maritime hydraulics, this model can be sorted in 3 related families. One of them is the Busenek type models, which are highly in use. Second one is multi-layer extension of shallow water equations. And the third one is the VAM models. However, VAM models have been rarely explored to be applied in this field. The physics of the VAM model, however, are quite simple. in the mathematical development, a set of perturbation parameters has been introduced to gain more detail in velocity and pressure fields during the vertically averaging of the Rand's equations. So that leads to a higher number of variables in the system, leading to a system which is undetermined. So to provide a system which is determined, we need to provide more equations to solve these variables. And to that purpose, we use the weighted residual method to produce the moment equations for these extra degrees of freedom. So in the end, we are having a BAM model which is built by 6 time-dependent partial differential equations with 6 independent variables that accounts the flow depth, discharge, and a set of perturbation parameters for both velocity and pressure fields. The details of the numerical method to attack this system, which is quite complicated, can be consulted in this work. So for the result, we did an application and a comparison with the Businet type model for a complex coastal experimental test. As you can see from the figure, it's quite tiny, but I think that you can get an idea of what happens here is that the BAM model can tackle the wave breaking without any ad hoc complementary model to mimic the breaker. However, if the Businet model is run with any aid of this function for mimicking the breaker, you can see that the peak of the leading wave is over predicted. So the result of the BAM model is mainly due to the modeling of the velocity field, both in vertical direction and streamwise directions. And these results allowed us to conclude that the BAM model can be considered as a suitable alternative to Businet type models for maritime hydraulics and coastal engineering applications. For more application of the BAM model to other cases of coastal flows, you can see here, and you can consult and read this paper, which is full of cases. Last but not least, I would like to thank to the government of Spain for funding this investigation. That's all for my part.
Thank you, Francisco. We can move on. If you have any question, please type in. We will discuss at the end. And our next talk will be a numerical simulation of dissolved oxygen in coastal lagoons case study, Algola, Egypt, given by Onia Upside from Technology University of Berlin, Germany, and also Masura University in Egypt. Onia, it's your turn. Please share your screen.
Okay, can you hear me and see my poster?
Yes, very nice.
Yeah,
Please.
Okay, good. Hello, everyone. My name is Omnia Abulsad. I am a PhD student at the Technical University of Berlin. Today, I'll briefly talk about my poster entitled Numerical Simulation of Dissolved Oxygen in Laguna Lagoons. In this work, we investigated the water quality considering the dissolved oxygen and stressed artificial coastal lagoons in Laguna in Egypt using the Telemac 2D water module. Our domain is highly stressed by the sewage outflow of hotels, touristic and local wastes, boat leakage, and the nearby desalination outflow. Dissolved oxygen may be considered one of the most important water quality parameters, as we are aware that a complete insight of the water quality, not only the dissolved oxygen, is essential considering different chemical, physical, and biological properties So this abstract is considered a first step with regard to water quality in such stressed artificial lagoons. We will later simulate the eutrophication problem in our domain. Dissolved oxygen enters water bodies through the air or through the photosynthetic processes, and is consumed by animals' respiration or decomposition of the organic and ammonical load. Our domain, as shown in figure 1, consists of 2 connected lagoons with a perimeter of approximately 4,700 meters and an area of 23,000 square meters, and the water depth ranges from 2 to 3 meters. The lagoons exchange their water with the Red Sea through 3 water inlets, as shown in the figure here. Lagoons are subjected to a tide wave, sinusoidal wave with an amplitude of 0.6 meter and is repeated every 12 hours. The wind flow on the lagoon is calculated to be 5.84 meter per second from northwest direction. And barometric data were considered from a previous study made 2 years ago. The simulation focused firstly on sensitivity analysis of input parameters such as photosynthetic and basic demand reaeration coefficient. Also, the effect of the increasing water temperature on the quantity of dissolved oxygen was investigated, as lower levels of dissolved oxygen are expected in case of high temperatures. Afterwards, a complete insight of dissolved oxygen under different weather conditions will be investigated concerning the results. Here, as you can see in figure 2 and figure 3, a spatial insight of dissolved oxygen in the lagoons after 4 days of simulation under 2 water temperatures, 20 and 30 Celsius degrees. It was calculated that the average dissolved oxygen in the whole domain was 9.87 milligram O2 per liter in case of low water temperature, and decreased to 8.43 milligram O2 per liter in high temperatures. Also, we can see that the dissolved oxygen decreased at the upper right of the domain to reach values less than 6 milligram O2 per liter in case of low temperature, as we can see here. There is also a comparison of, here in figure 4, a comparison of a temporal variation of 3 control points are shown here in the lagoons, indicated for the whole simulation period of 4 days. We can see that all 3 points have the same attitude of dissolved oxygen with increased values in case of low temperatures. While comparing the 3 points, we can find that at every point, the dissolved oxygen depends on lots of parameters, which may be water depth, velocity, location of the point, inflow or outflow point, tide and wind data. Consequently, our next step is to investigate the effect of different weather conditions on the dissolved oxygen. I think the fluctuation here shown in dissolved oxygen may be related to the tide wave affecting the lagoon. Also, a sensitivity analysis of different input parameters was conducted. For an instance, the photosynthesis values of 0, 0.31 and 9 milligram O2 per liter were applied, neglecting the effect of organic load and ammonical load. As shown in table 1, the average dissolved oxygen show a high increase in case of high values of photosynthesis, as shown it reached the value of 27. And that's all. Thank you. And any questions, feel free to ask.
Thank you, Onia.
Thank you.
Well, okay, let's move on to our next talk. It's given by Camila Quimana from Peru. The talk will be initial findings.
Yes, can you hear me?
Yes, we can hear you.
Oh, thank you. Okay, I'm going to share my screen. Okay, can you confirm that you can see my screen, please?
Yes, Camila, we can see you and we can see also your screen. Thank you.
Thank you. Good morning, everybody. Today I'm going to present our paper, Initial Findings of Microplastics Concentration in 3 Coastal Environments, a case study in the Peruvian coast. First, we have to understand that microplastics refers to any plastic fragment which has 0.1 micrometers to 5 millimeters in length. This might appear to be insignificant due to its size. However, it can be really prejudicial for us and for nature because these microplastics can be found within the stomach of marine life and also floating at surface level water. For that, in 2019, we studied 3 beaches on the coast of Lima, in the capital of Peru. The first one was Chancay Beach, as we can see in the figure 1 in the map, which is located in the north of Lima. The second one was Los Yuyos, which is in Lima, in the center of Lima. And the third beach analyzed was Naplo Beach in the south of Lima. We took samples of sand and seawater. For sand, we use wooden frames, and for seawater, we use a nailstone net of 300 microns. And we process our samples by microscopes and microplastics and sediment separator based on density principles. What we found was really worrying. Of the 3 beaches analyzed, Naplo Beach in the south of Lima, as we can see here in the table 1 and in the figure 2 with the yellow circles. This was the most contaminated or affected by these micropollutants. We found pellets in the majority of the samples, which are microplastics that are manufactured in this small size. Near this beach in Naplo, there is a plastic bottling factory, which might appear to be the main source of contamination, we're assuming, mixed with a recirculation region made by this formation of rock and soil that we can see here, where microplastics are concentrated in this zone. The second beach in Los Yuyos, we didn't find too many microplastics. They were mainly fragments and fiber in seawater from 1 to 8 millimeters. And the third beach, Chancay, in the table you can see it, and is this map. Where in Chancay the fishing industry is very present. We found a significant amount of microplastics, mainly fragments, and that can indicate that these microplastics came from the degradation of nets, as well as the mismanagement of solid waste in this location. To sum up, in Peru there are only 2 works now, including our work, that talk about microplastics. And as we can see, is in this paper, this issue should concern us and should concern the authorities of this location and in general of the coast of Lima. For further results, we consider that we need more campaigns, of course, in order to complement the results. And also in the future, we would like to develop a numerical model in order to predict the spread of these micropollutants and maybe take action in some specific zones where we can protect marine life. Thank you for your attention. If you have any question, feel free to ask.
I'm afraid Sigo is having some network problems. Am I the only one who can hear him, or?
Martina, perhaps you can introduce the next.
Yeah, sure. Okay, and so I will introduce the next speaker in line, who is Daiwan Li from State Key Laboratory of Hydrology and Water Resources and Hydraulic Engineering in Nanjing in China, who is going to present us his work about simulation of seawater intrusion area using feed-forward neural network in Langfu. So we can already see your screen, Daiwan, and I leave you the stage, please.
Can you hear me?
Yeah,
Hello.
we can hear you. Thank you.
Yes, we can.
Yeah. Hello, everyone. Thank you very much. My name is Li Danyuan. I'm from Nanjing Hydraulic Research Institute in China. It's a great honor to be here to share my research about seawater intrusion simulation. And we all know the extensive and irregular groundwater exploitations from the coast aquifer may cause seawater intrusion. It seriously threatens the sustainability of groundwater utilizations and ecosystems. And in different areas of the world, it has been reported in many researchers and become a global issue. In China, it was found as early as the 1960s, and the area more than 2,000 square kilometers in 2003. Therefore, the seawater intrusion simulations is necessary for water management to optimize the groundwater utilizations and make effective strategies for recovery and prevention of seawater intrusion. This study tries to simulate the seawater intrusion changes and identify the controlling factors based on feed-forward neural network. And figure 1 shows the feed-forward neural network. Model 1 is built to simulate groundwater level changes. The input elements include precipitations, temperatures, water supply for agricultures, and the groundwater supply for non-agriculturals, such as domestic and industrial. The study area was divided into 3 subzones based on hydrogeology materials. The model 2 is developed to simulate the relationships between groundwater levels of 3 zones and seawater intrusion areas. Finally, the model 1 and model 2 are integrated, which means the results of the model 1 are viewed as the input data of the model 2. The figure 2 displayed a comparison between simulation and observations. The integrated models can handle excellent performance, which can be used accurately predicting seawater intrusion development. To gain a better understanding of impact factors for seawater intrusion, the stepwise method was used, and statistical indicators of model performance were compared. That means one input variable was deleted based on model 1, and the corresponding model was developed and table 1 shows the six scenarios for sensitivity and analysis were established, which was present in table 1, and the relative importance rank of each factors was obtained. The result proved that the precipitations and the groundwater pumping for agricultures mainly affect seawater intrusion areas. We can conclude feed-forward neural network is a great choice for estimating seawater intrusion changes. Meanwhile, the seawater intrusion areas can be considered as an alternative to estimate development. In addition, it is apparent the strengthening groundwater management for agriculture is significant for solving seawater intrusion problems in this area. That's all my report. If you have any questions, it will be welcome to contact with me. Thank you very much.
Thank you,
Thank
Dayuan.
you.
Can you hear me right now, Martina?
Yes, we can hear you. Thank you.
Okay, thank you. So I think we move to our final speaker from Postgraduate Institute of Medical Education and Research in India, Ruhadeep Singh. He will present groundwater depletion trends in Punjab, India, and the need for remediation 2000 to 2019. Rahuldeep?
Hello.
Yes, please share your screen.
Yes, sir. Is the screen on?
Yes.
Hello.
Yes, it's all yours.
Thank you.
We can see it. Yeah.
Greetings, everyone. I'm Dr. Rahuldeep Singh. I'm coming from Postgraduate Institute of Medical Education and Research in Chandigarh, here in North India. So I'll be presenting on groundwater depletion trends and the need for remediation in Punjab, India for the last 2 decades, which is from 2000 to 2019. There have been changes in the climate, which we have all agreed to see, and they have influenced the precipitation amounts, timings, and intensity rates, which directly affects the surface and the subsurface waters. And the recent developments in the state of Punjab has also affected the groundwater exploitation rates, as well as overall in India, even without climate change, 15% of India's groundwater resources are overexploited. The water demand here in India in 2000 was 634 billion cubic meters, which is expected to be increased nearly to 1100 billion cubic meters by the year of 2025. Unfortunately, due to rampant drawing of the subsurface water, the water table in many of the regions of Punjab has dropped significantly in the recent years, resulting in threat to groundwater sustainability. More than 80% of the total water used for crop irrigation is extracted from groundwater resources, but during the drier years, it is even more than the 90%. With the intensification of groundwater use, it has contributed to improved livelihoods of millions of rural people, but it has also resulted in long-term aquifer depletion and groundwater pollution of heavy metals. This study has examined the long-term changes in the precipitation and groundwater level trends in the last 2 decades. The data was obtained from the Water Source Information System India. Here, as you can see in the map, it shows various levels of groundwater below the ground level. And the regions here in the southern part are mostly affected by the higher depletion rates as compared to the north. The data also reveals that in the southern belt, the regions, the water levels are even deeper, up to 20 to 40 meters below the ground level. The trends also show that there has been a continuous decline from the 8.3 meter below ground level in the year of 2000 to 17.84 meters below ground level in the year of 2019. In the past 2 decades, there have been highest declines in the years of 2001 and 2016, respectively. there is need for the development of the livelihoods of millions of rural people. Hence, the current state of development and management of groundwater resources also has serious implications for the future groundwater availability in the state. There is need for collective efforts to conserve the water through protection of conventional water resources, which is needed. And hence, we recommend for the state to align water use patterns with the needs and demands of different users. Thank you.
Thank you. Thank you very much, Rahuldeep. Okay, great. I think we are right on schedule, and online speakers have presented the study and shared the results. And I believe I saw several questions raised up, and I think we can take a very short break, and we can move to our coffee break and go through those questions, and we can have a discussion. Let's thank all three online speakers. Thank you guys very much. Okay, so if can we? I didn't find. I found three questions right from the screen. So far, I found three questions. One question is from David Ferris.
Yeah. Maybe I can use my mic. I just did the question because I was testing a bit the Q&A.
Okay. Okay. Let's ignore that one. So there's one question to Dayuan. Dayuan, are you there?
Yeah, I can hear you.
Okay, so I'm gonna repeat those questions. It says, how many training examples do you use for the FNN method? Can you comment on the computational cost for your simulation?
Yeah. Training sample is about the groundwater level is 2000 to 2017, and mostly groundwater level, and the seawater intrusion area is from 2005 to 2017. Is the 6 mostly seawater intrusion areas. The computation cost is not is about 10 minutes per
CPU time, you mean?
Yeah. About 10 minutes. Every computed.
Okay, thank you, Dayuan. Thank you for your answer. So, any comments from our chairs, from Martina, Xiaobing? Do you guys have any comments?
I'd like to thank very much all the presenters for their very high quality presentation of the results. I'd like also to introduce myself. I work in Politecnico di Milano as assistant professor of hydraulic engineering in the Department of Civil and Environmental Engineering in Politecnico di Milano. My research topic is actually more focused on groundwater hydrology and flow and transport processes in porous media, but it was really a pleasure to join and participate to this to this session in particular, because we actually are facing common challenges with coastal engineering. All these presentations were focused on basically the protection of coastal environments and the importance in basically the availability of fresh water in coastal environment, which are of course threatened by seawater intrusion, by the, of course, environmental print of human activity in these kind of environments. And of course, climate change will get worse. So actually all the presentations show these common challenges and the different possible methodologies to face this problem and find solution, not just in early times, but also on longer time scales. So it was very interesting and very useful, I think, to compare all the different approaches that can be shared, of course, in this kind of meetings. So these, we can take the chance of this coffee break for an informal discussion, and I think it could be useful also to share our experiences and our work. In particular, we can go ahead. No, we already answered all the questions in the question and answer, I think. I have a few questions. One is not for a specific presentation, but more in general. Since we're many presentations dealt with, as I said, very long time scales. So because of course we need to predict how quantitatively as possible how freshwater resources will be affected by, for example, climate change consequences in coastal environment. But the longer, of course, the quality of our model can be tested on a smaller time scale, but actually we, of course, must include in our discussion of the result the uncertainty that affect our predictions. Because of course, it will be particularly relevant for a very long time scale. So are you going to include them, and have you already tried to include these aspects for the characterization of the different quantities related to coastal environment? Those of you who dealt with very long time prediction as Rutger, for example, if I'm not wrong, or also Federico Astert.
I think I can answer that because it's also still a Q&A question open on that. Well, I will apply a snapshot approach to include climate change, and that's basically, let's say you have an estuary, you have a model of an estuary in the present situation, where with which you can, for instance, simulate morphological development. You validate that for the present day situation. So let's say you can simulate 1 year, and that model simulation is good. You know that it's good. Then you implement local climate change scenarios. For instance, a 2 millimeter per year sea level rise, an altered river discharge. There are also some morphological processes such as basin infilling. And you make assumptions for that, and you implement that within your model for, let's say, the year 2100. And then you can again simulate in that scenario of the year 2100, you can again simulate 1 year of morphological development. And because of that, you don't have to simulate all the 80 years in between, but you can still say something about how the future is going to look like. And this way you can also implement various different climate change scenarios. So the one is only a small sea level rise, the other is a really extreme sea level rise. So you can still account for the uncertainty in climate change predictions as well. So that's how I will implement climate change within my research. If that's clear.
Yeah, thank you very much for your
Thank you.
Thank you. Any comments from Xiaobin? Dr.
Yes,
Xiaobin?
good afternoon. I'm just back from my field work in headwater of Xianjiang watershed. Yeah, so my interest is in groundwater surface water interaction. So I got a question to our speaker, Kamina, post number 80, about the microplastic in the coast area. So I have some question about if is there any microplastic study in a river network? I mean, in a river sediment or in a stream water. So do you have any suggestion for us to when we are doing the river modeling or ecological modeling in river stream water? So do you have any suggestion to aspect of the microplastic transport in those fresh water zones? Yeah.
Okay, thank you for the question. There are no studies well in Peru about microplastics in rivers or in these fresh in these stream waters. There are only ones about also coastal environments and the microplastics in just sediments. And we don't one about sediments and seawater. About your question, if in the future we can maybe make some studies there. In Lima, for example, there is a big river, the Rimac River, which I don't know if someone from Peru here, which is truly contaminated with garbage, with constructions, waste, for example. And this is a big issue here, the Rimac River. I consider that we could maybe study these sediments, but the Rimac River is quite big, and the flow is really quite dangerous. So yes, maybe we can research a little bit more about how we can do this, and if we are going to have results, because yes, it is contaminated, and it can be contaminated by microplastics for the garbage, for example, that can be found in the river, but it can be found in the water, I think. I don't know if it can be found too many microplastics in the sediments, because well, Rimac River is that doesn't have too many sediments. It's like there are many rocks there. It's quite difficult, I think. But maybe in other rivers in Peru, not only in Lima, we can think about it.
Okay, thank you. So my other question is, will those microplastic will be accumulated in organism? I mean, in a human body, or those. I know a little about there are some microplastic in our drinking water, bottle water. Even we're using the tea bag in will release microplastic. So will those microplastic be accumulated in our body?
Yes. Well, there are not specific studies about microplastic and human body because, of course, we cannot consume microplastics in order to see their effects. But there are studies about microplastics found in the excrement of people, for example. And yes, we can assume that it is entering our body. For example, there are also many other studies which talk about microplastic found into marine life, into fish that we can consume. So we can consume these microplastics. And about the drinking water, there are two main ways for microplastics to become in this small size. The first one is like the primary microplastics that are manufactured in this small size that are called pellets that can be found, for example, in toothpaste or in cosmetical care products or creams, maybe exfoliants and this kind of products for beauty. So this is of course dangerous, and some treatment plants doesn't have any kind of filtration for these microplastics. And the second one is when this plastic degrades from bigger plastics or for example, as you said, in a bottle of water, it can be, I can say yes because I haven't read anything about that, but I think that we can consider that because we need, for example, mechanical, chemical, or biological way to degrade this plastic into microplastics. So in this bottle of drinking water, if it's exposure to maybe high temperatures or UV, it can be possible. Yes, it's a dangerous topic.
Thank you.
Thank you.
Thank you, Xiaobo, and thank you, Camila, for your very nice discussion. Well, I also have a couple of questions to our speakers. The first one is about I'm going to discuss with Ishita. Ishita, are you there?
Yes, I'm here.
Okay, so I'm quite interested, in your experiments. I just wonder, if because as we can see that from your experimental study, that bubbles, get penetrate into the jet. So from your experiment, can you measure the instrument ratio? Because instrument ratio will be very important if you want to dilute those high density salt water. So I wonder if you are going to use some some experimental techniques like PIV system to measure the velocity field, and also like you can use like PIV to measure the change of concentration during this process. So what's your thoughts about those?
Right. Yeah, thank you. That's a great question. So far, I have not made any measurements of velocity profiles or air entrainment. Some of my collaborators who are based in Kuwait are actually trying to make measurements of air entrained into the bubble column. And the way they're doing is by enclosing the whole confining tube so that there is no other entry point for air. And then they use basically a very simple design, but I think it works. It is that they use a soap bubble and try to measure its speed as it rises, which and it's connected to that entry point. So that's the only way where air is entering from. And it's been tested before for plunging jets. So at least that's one way we can make measurements of air entrainment. I also have somewhat theoretical, but also it has I input one of the experimental parameters, so it's semi-empirical, a model to predict what the air entrainment would be for these confined plunging jets. So far, the model is only for narrow confining tubes, but I'm trying to expand it to other regimes as well when it's wider. And going to your other question about PIV or PLIF, I haven't thought about it, but I think that can be done. I guess I'll have to think about where exactly we are interested in making measurements of velocity and concentration. But I think that's a great suggestion. Thank you.
Thank you. Thank you very much. Okay, so I think that's the question for you. And I would like to ask another question to Federico Hasper from Argentina, because I'm quite interested, in your estimation about coastal erosion along the along the coast of Buenos Aires. So, Federico, are you there?
Yes, I'm here.
Yeah, okay, can you hear me? Okay, great. So, because in your estimation, you basically consider the dune height, right? So
yes,
and also basically you consider the impact of sea level rise. So I just wonder, in Argentina, is there any human activities going on along the coast to protect the wave erosion, storm surge, or even sea level rise, somehow like that? So in the reality, what kind of factors can impact your results? Do you have any thoughts or any comments about about your results? For example, any other impact factor can impact can influence your results?
Well, I say during my presentation, I say that the highest values of coastline recession were found in the northern part of the coast of Buenos Aires. That's because the north part of Buenos Aires is the most populated area of the entire coast. I think we know that in that area, previously to doing this work, I know we know previously to do the work that this area in particular, the northern part of the coast, was the most affected by the mean sea level rise. That's because the human activities that people who live there realize every day.
Mm-hmm.
I don't know if I answered the question.
Yeah, I think you answered the part of my question anyway. So thank you. Thank you for your research. Okay, so I have one more question. One more question to Onia, because you simulate a oxygen, dissolved oxygen in Aguna lagoons. Thank you. Onia, can you hear me?
Yes, I can hear you.
Okay, so because you set up a numerical model using a TeleMac, right? So it's a 2D model, 2 depth average numerical model, and from your post, I can see that the water depth in this lagoon is quite quite shallow, right? It's around like 2 to 3 meters, right? So I just wonder, you know, in your simulation or in your area in this lagoon system, how about the mixing induced by wind? I don't know if the wind is strong in this area or not, and because for this shallow system, normally the the upwelling mixing generated by wind supposed to be important, you know, to change the situation of oxygen. So can you give us some more details about this?
Yeah, thank you for your question. Concerning wind in this lagoon, it's about 5 meters per second in the northwest direction. We firstly began to make hydrodynamic modeling of the lagoon and see its effect on the water depth and the flow velocity and direction. But we found that the tide has more effect on both water depth and flow direction and the flow velocity and direction. And the wind had a smaller effect on the lagoon. But in simulating the water quality concerning dissolved oxygen, we take the effect of both tide and mean wind. And after that, we began to take the effect of tide wave only and wind only on the dissolved oxygen and compare the results between them. But also we found that the tide has the most effect on this lagoon. Thank you.
Thank you.
Thank you.
Yeah, it's quite clear. Thank you. Okay, so is there any other question from audience, also from our chairs, also from our presenters? Do you guys have a question, you know, to other speakers?
There was a question from David still, and also from Graciela, if I pronounce it correctly.
Okay.
About
can you see the question, Martina? I could.
This about to Rutger about the snapshot approach, right?
Yes.
Yes.
Is it okay if I share my poster again, because I have a...
Sure.
Yes.
Sure.
Okay. Can you see the? Yeah.
Yes.
So this is the framework I apply, and there's quite a lot on there, but I don't want to explain it both. But basically, I will look at I will have an ecomorphological model and a salt intrusion model, but these are basically the same model, but with different modules. And the snapshot approach is basically, first I have an ecomorphological model and a salt intrusion model of the present. And I will also simulate both. And then I apply the snapshot approach. So I implement a climate change scenario in both of these models. Let's say sea level rise, altered river discharges, based on local climate change scenarios. And then in the future, so I have a model which starts in the year 2100, let's say. I again simulate ecomorphology, and I again simulate salt intrusion. So then I have both the results of the present day in a validated model and in a future day. And all what's in between I don't have, but that's not a problem because I have a snapshot of the future. Then I can compare the two results to have an idea about how the future is going to look like. And Graciela had this answer, which I answered in text also, but how I will link the snapshot approach with other time scales that you pretend to study, say the level of years and days. So that's how I want to also look at the time scales of years and days. So the snapshot approach I apply to bridge the gap between 2020, where we are now, and 2100. So I don't have to look at all the time in between. The snapshot approach is only a tool, and I will actually model simulations on a timescale of days to look at salt intrusion, and I will actually model estuarine development for years to decades, or 1 to 10 years. And I hope that satisfies the answer. Of satisfies the question.
Yeah, thank you, Ruger. Thank you very much.
Okay, thank you.
Another question? Another question?
Just a curiosity to Rutger again.
Yeah.
About the oyster beds as a natural base solution. How does it work exactly, basically?
I'm still going to look into it, but
Okay.
basically the nature-based solutions that we're going to look into, they impose a roughness on the flow. So you have salt water at the bottom and fresh water on the top, and it's separated. And when there's more roughness, there's more turbulence, and more turbulence means there's more mixing. When there's more mixing, the salt water goes less far into the estuary. That's, yeah.
That's the principle is the same for all these schemes.
Yes, that's true. Yeah, one will be more successful than the other, but I still have to look into that.
Sure. Thank you.
Thank you for the question.
Okay, so I see Josep Loeb raised a question. Do you have any question?
Thank you. I have one question to Ishita. I think your experiment was the positive buoyancy jet case. So I think the shooting the jet toward the upward in the underwater will be more effective than shooting downward at the outside of the water. So how do you think about it? So
sorry, are you finished with the question?
Yes. Yes.
Okay.
And I think sorry, excuse me.
Ahead.
And I think it is shooting the jet toward upward will be more effective even in the stratification is stronger. Yes. This end of my question.
That's a good question. So first of all, we are injecting brine that's negatively buoyant. And yes, conventionally, it's always been thought that, since it's going to settle at the bottom, you want to maximize mixing, you would start by start with a submerged jet that's at the bottom, but not shoot it completely vertically upwards, but at an angle. So it sort of forms, goes up, gets to a terminal height, and then falls down. So that's been the traditional approach. And I also looked at those jets during my PhD. And yes, they definitely I think they would get better mixing than the plunging jets, but we are considering plunging jets because they can also introduce air into the water column and help us with the problem of aeration, which is something that the submerged jets cannot do. So we are still not sure whether in terms of dilution only plunging jets are so useful, but they cater to both the requirements that they would help with at least some dilution, but also increase aeration. So that's why I'm considering plunging jets, but you're right that submerged jets are probably better because they make better use of the momentum and buoyancy of the effluent. And then going to stratification, most of my work, I haven't really considered it because we are more focused on shallow water locations where we don't really expect to see too much ambient stratification. But I think there have been studies to look at the effect of stratification on submerged jets as well. But thank you for your question.
Thank you.
Very nice discussion. Any other question? Any other question from audience or from our speakers, from our chairs? Well, I guess not. And also it's about time. So as we can see that, all 9 speakers have done a great job in in this study, and also give a very nice presentation. you know, and also, so I would like to, you know, thank all nine speakers for your nice presentation, and also I would like to thank Martina and Xiaobing, and also David, you know, to host this session. So, okay, I found another comment from Rahuldeep. Rahuldeep, do you want to say something? Okay, I think it's just the comments from Rahuldeep Singh. I'm going to repeat it. Okay, he says how to measure different water usage patterns in different sectors to identify which sector is contributing to high depletion, and then inform for policy reforms accordingly. Most of the sectors are not generating data regarding the same. So is there any comments from our chairs? This is a question related to groundwater using. So
if I understand correctly, the question is about how to identify the I don't exactly understand what is meant by sector, but probably you mean industrial sector or agricultural sector in this kind of sense. So anthropological activities in general, probably. Well, yes, it would be definitely relevant information, useful for policy reform. Of course, when you are dealing with public sector, it is generally easier to get data and information compared to private sector. And you're right that the information are not generated and diffused the same. It would be a success to have a thorough understanding of the impact on groundwater resources of the different activities, which in particular in coastal environments, because of course there is an intense activity there, and the enhanced seawater intrusion that may come from this activity is strictly related to the groundwater uses, of course.
Okay, thank you, Martina. Thank you very much. Well, I think it's about time, and we have to close our session. So thank you all, and thank you for your attention. Especially thank David, you know, for your hosting. So I think this is the end. This is a close, right?
Okay. Yes. Thank you very much, Zico, for chairing this session, also together with your co-chairs. It was a very nice session with a very interesting discussion. And now it's the moment to move on to the next session, which topic is on transient flows and hydraulic machinery. This session will be chaired by Silvia Meniconi, Moes Loati, and Victor Hugo. Welcome. And as you know, this session will have two parts. First, the presentations part, and then the discussion part. The presentation part will be chaired by Moes and Silvia, the discussion by Victor Hugo. And from my side, I would like to give a couple of updates concerning this session. There will be an additional paper number 93 by Nicole Newman, presented by the end of this presentations part. And also Caterina Caponi will be presenting poster number 67 instead of Andrea Rubik. Okay, so Moes and Silvia, you can go ahead. The floor is yours.
Okay, so thank you, David. I think you already set the lines for how the speaker will speak, and the question will be at the end of the coffee break. So let me start with the first paper. It's a paper by Lu Xin, and she is going to present for us TSNet, the transient simulation in water network. It's one of, I think, the fascinating software that she is trying to work on it, and it's on Python. And I think I actually started to learn Python so I can start to play with this code. It's open, open access. So please, Lu Xin, please go ahead and give your presentation.
Cool, thank you. Should I share my own screen or you're going to
Yes.
share? Oh, okay. One moment, please. Can you see my screen?
Yes.
Okay, cool. So, hello everyone. My name is Lu. I'm a PhD candidate from University of Texas at Austin. Today, I'm going to present our work on transient simulation for water network, TSNet, a Python package. And so first of all, I want to say that hydraulic modeling of pressure transient in water distribution system has shown promising in various applications, such as water distribution network design, especially pump station design, fault detection, and also risk assessment. However, the lack of open source software implement the development of transient-based methods. So this is evidenced by the fact that most of the current work are limited to a pipe reservoir network, reservoir pipe valve network, or some very simple toy network. And this paper contributes a Python software for transient simulation using method of characteristics. This package, the TSNet, is fully open. It's on GitHub, and we have a fully documented documentation online. And so the capacity of this network is, first of all, it can read an EPNet input file, which is a very commonly used format in water network. And based on that EPNet input file, TSNet will create, and then users can define any kind loss of candle transient events, such as valve closure, a valve opening, pump shut off, pump opening, and then other disturbance events such as burst and the demand passes. And after that, user can also define whether they want to include the protection device in their network, such as open or closed search tanks. And after that, TSNet will call another simulator vector, which is another Python package to calculate the initial condition, essentially doing the steady state calculation. And then after that, user can define the friction model. The options are steady model, quasi-steady model, and unsteady model. And then TSNet will run the transient simulation using the MOC method, the method characteristics. And after that, we can get results such as head, pressure, velocity, and discharge using TSNet using very simple code. And also, TSNet has included some simple post-processing in the package. And then I'm going to show the results of an example using TSNet to demonstrate its capability on simulating different events. So here I generated 4 different events in this network. The scenario 1 is a pipe burst, and then scenario 2 is a linear closure of valve, and then there's another scenario about pump shut off, and also a scenario about background leak. So here in this figure, we can see that essentially by simulating this event, we can see the pressure transient in all the nodes throughout the network. So, and also this simulation can be performed within probably 10 lines of code. So it's very easy to to learn TSNet, especially if you already know Winter or EPNet. So basically we want to design TSNet so its structure and the way to perform it looks very similar to EPNet and Winter. So water researchers don't need to spend a lot of time learning the code, just take a look at the documentation and it should be very clear. And so for the conclusion, TSNet provides an open source and freely available Python code for simulating transient in water distribution system. And as far as I know, TSNet is the first open package for this purpose. And by far, we have released TSNet for a little bit more than a year, and it has been downloaded by 6,000. It has already 6,000 downloads, and I'm not gonna say downloaded by 6,000 people. I don't think there are that many people in our community, but anyway. So TSNet, in terms of capability, TSNet is a Python package with the following capacities. First of all, read the EPNet input file and establish initial condition, and also perform transient simulation under various conditions, such as valve and pump operation, leaks, burst. And it can also have the capacity of include surge protection devices. And after the simulation, we can obtain visualize the post-processor results using TSNet. And the one more thing I want to mention, I want to emphasize is TSNet not only provide the transparency needed by our research community, but also it presents a platform where users and developers can further develop and improve the extent the existing transient model, because we are not claiming that TSNet has all the capacity that commercial software have, but we think it's a good start for us to collaborate and push it to that end. Thank you, everyone.
Okay, thank you, Luxing. That was a very good presentation. Everything was good. So let's pass to the next presenter. And so next we have, let me pronounce this correctly, Filomena Maietta. And she's a PhD student in Perugia University in Italy. So today she will be talking about laboratory tests conducted to examine the effect of functioning conditions on the transient behavior in water supply departments. So Filomena Maietta, please, anytime you can start.
Good evening. I share my poster. The operational water distribution system are usually characterized by pressure transient. Such transient can be caused the space-time variability of users' water demand and by the operational of pressure regulating devices. I would like to show you some preliminary transient tests executed in a network installed at Water Engineering Laboratory of the University of Perugia. In particular, I will show you the effect of the change in functioning condition. The experimental setup is a network, a pipe network with 2 loops, simulating a district meter area. Area connected to a pressure tank with a DN110 supply pipe. The first loop has 4 pipes with DN75, and the second loop has 4 pipes, one in common with the first loop, and the other DN50 pipes. 5 solenoid valves are installed at valve 4, 5, 6, 7, and 8 to simulate the users. And 8 measurement sections are installed along the pipes. The acquired signal are in this figure. For open network and closed network. The transient is generated by the fast and total closure of valve 5 in 2 different conditions for open network and closed network. In open network, the terminals are open, and in closed network, the terminals are closed. You can see in this figure that the transient in open network is smaller than the transient generated in closed network. To go into more detail, we have this figure. In this figure, we note we have the pressure variation with respect to the steady state pressure. In open network, we note that the pressure wave generated at section 5.8 is about 11. In closed network, is about 18, and it is emphasized by the topology of the network and by the boundary condition. In fact, the pressure wave at section 4.7 and 8.7 are bigger than the pressure wave in the section 5.8. In fact, in the section 4.7 is about 28 meters, and in the section 8.7 is about 30 meters. So it is concluded that for a given maneuver, the decay of a pressure oscillation is faster in an open network. And we note that it is important to monitor the whole network, since the effect of the transient is emphasized by the topology of the system. Thank you.
Well, thank you very much. Well, I think that was quite clear. And if you have any question, please write it in the chat or the Q&A, and we'll discuss them later. So let's pass to our next presenter. So next is Mohammed Wakar. He's a PhD student at the University of Hong Kong University of Science and Technology. Today, Wakar will present to us time reversal of waves in pressurized pipelines. Is a subject was a bit intriguing because usually we are familiar that things are not reversible, but Wakar will discuss with us that waves can be reversed and can be quite useful. Wakar, please, you have the floor.
Hello, can you hear me clearly?
Yes, we do.
Okay, thanks, Moise. Hello, everyone. My name is Mohammed Wakar, and I'm a PhD candidate at Hong Kong University of Science and Technology with Professor Moise Loati and Professor Gidawi. The topic of my presentation is time reversal of waves in pressurized pipelines. So in a non-dissipative medium, let's say a pipe with no damping, time reversal property of waves dictates that waves can travel back in time and refocus at their source in a manner analogous to a movie that is played backward. This property has been used in many fields such as acoustics, geophysics, medical imaging, and structural health monitoring. Recently, in pipeline hydraulics, this property is used to develop computationally efficient What is surprising and intriguing is that time reversal.
You were a bit cut, so maybe you speak a bit slow because the Wi-Fi was a bit, I think, stopped.
Okay, so in pipeline hydraulics, this property of time reversal is recently used to develop computationally efficient and noise-tolerant methods for defect detection using transient waves, such as match field processing or area reconstruction method. What is special and intriguing is that time reversal, in a strict sense,
is not valid for damped waveguides. So, and here's why. Consider equation 1, which is the 1D Water-Hammer wave equation. without the last term, which represents the damping part, this equation is time invariant, which means that if I replace t with minus t, the overall equation does not change. However, consider a realistic case where the damping is included. In this case, replacing t with minus t gives us the equation 2. And you may notice that in equation 2, you have a positive sign with the last term implying that time reversal does not hold. So there is a confusion that time reversal in a damped system is invalid, while time reversal based methods are working exceptionally fine in the same damped systems. My objective is to investigate and understand how does damping affects the time reversibility of wave. To do so, consider a pipe system as shown in figure 1, where we have a pump pipe valve system with the valve open at the downstream end and the flow rate is 0.4 liters per second. The overall pressure in the system is 20 meters and the pipe is made of high density polyethylene pipe. Now, following the time reversal procedure, the first step is to introduce a transient source, which is a side discharge valve in our case. So what I did is I manually open and close the valve to generate a transient wave, which propagate in the system, and we record the response of the system at two boundaries. That is where near the upstream boundary, which is a valve, which is a pump, and the downstream boundary, which is a valve. The next step is to take these two measurements from the boundaries and flip them such that the first value goes to the last and the last value goes to the first. So this is the meaning of time reversal. So we have reversed the response that we recorded at the boundaries. Now, the next step is to use these time reverse signals as a boundary conditions in a transient model, which replicate the system and incorporate viscoelastic damping and also steady and unsteady friction. And when we use these boundary conditions as a new sources, we calculate the response of the system given to these time reversed signals. And the results are presented in figure 2. You can see that in figure 2a, the re-emitted waves refocus accurately back at the source location and at the time of the source, which is 0.1 second, as I close the valve in 0.1 second. In fact, the localization error is about 1 meter, which is quite good. However, figure 2b shows that the refocused signal has a pressure time history, which is very similar to the original one, which is measured near the source when I operated the valve, but the amplitude of the recovered signal is not the same as the experimental signal, which actually implies that when the wave travels back, it accurately refocuses its past step in the sense that it refocused at the exact source location, but its amplitude is further damped. So it is concluded that various damping effects only affect the amplitude of the wave and do not alter the refocusing property of wave, which is the key to localized defects. Thank you.
Thank you, Waqar. So again, if you have any question, please write it down or wait for the coffee break. Now, let's move to our next presenter. So next paper is by Caterina Caponi. She's a postdoc at the University of Perugia in Italy. Most of the time we're trying to avoid transient, but Caterina decided to chase them in the water transmission line in Italy, Milan. So Caterina, please, you can start.
Thank you very much, Moise. And it's a pleasure to be here and present some data that our research group of the Water Engineering Laboratory of the University of Perugia acquired in Milan, in the northern part of Italy, a bit less than 1 year ago. We were there because the local water company, Gruppo Cap of Milan, called us and asked us to perform transient test-based techniques for the diagnosis of a quite long transmission main, more or less 20 kilometers. And when we were there, we decided to exploit the time there also to monitor the system during its normal, let's say, ordinary functioning conditions during the night. So we decided to measure pressure during the night at the well field on the one hand, and at the rising main at a bit less than 16 kilometers from the well field. We acquired pressure signal with a sampling rate of 2048 Hertz. And we acquired these two pressure signals. These are the pressure signals shown for 1 hour of acquisition just after midnight. And these are the normal functioning conditions of the systems. What we can see is firstly that there are several transients in there. So we can already conclude that transients are constant presence in our networks. But secondly, we can distinguish two types of transients, and it is interesting. One type of transient is that at the well field that is characterized by quite large pressure variations. We can see that, for example, 23 minutes after midnight, we have a pressure variation till to about 42 meters. That's quite large. And this type of transient is also characterized by the fact that these pressure variations are few, not so numerous, and also quite slow, we can say. On the other hand, at the rising main, we can see that the pressure variations are smaller. So we have about 5 meters of oscillations, but they are quite faster with respect to the well field, and they are very numerous. There are many pressure oscillations there. And so we can distinguish these two types of transients that can lead both to damages, but maybe different kind of damages. So we can conclude that this high frequency monitoring of the system is quite useful to detect transients, to understand the dynamic of the system, so to detect different types of transients. And we can also say that further steps in this analysis could be firstly to acquire more pressure signals, maybe also stresses and strains, for example, especially at the rising main, where these pressure oscillations that are characterized by a sort of periodicity, let's say, are due to the fact that at the rising main there are installed some variable speed pumps. So this is quite interesting, actually, that variable speed pumps can produce such type of transient. And so we will carry out more measurements, and we will use different methods for the analysis of these two types of transients. And I thank you, and if there are any questions, it will be a pleasure to answer later. Thank you.
Thanks, Katerina. Very nice presentation. So you hold on there because you still have to go for one more.
Yes.
Now, presentation, well, used to be by Ruben, I think, so Katerina will present it instead. The paper is about, so basically, Tallinn Water Supply Department to please start measuring at high frequency and stop measuring at low frequency, because it could help to diagnose the system better. Okay, so Katerina, please go ahead.
Yes, thank you again. And yes, now I would like to show you our study within another collaboration that we have with Acega Sappia Samga company, that is the local water company of Padua in Italy. And one of the aims of this collaboration is to measure the magnitude of pressure transients that occur in the Padua water distribution system, and to understand the dynamic of the system. To do this, we need to install high-frequency mobile data loggers to detect transients. But firstly, we have to decide where to put these high-frequency mobile data loggers. Let me say that the Padua water distribution system is quite large, wide. They have almost 300,000 consumers. So we decided to exploit some measurements that the local water company has within its remote control system. They have some low frequency measurements because the remote control system is characterized by measurements with a time step of about 15 minutes. So they are not adequate to catch transients, but they can be used and exploited to do like a preliminary screening of the system to understand where it is more proper to put high-frequency data loggers. So we decided to exploit some of their measurements, and in figure 1A are reported some pressure signals in 15 permanent measurement sections that they have, and they are shown for 24 hours of acquisition during a normal midweek day without any uncommon maneuvers, let's say. And we performed an histogram analysis of the pressure variations to understand in which locations there are the most severe pressure variations. And you can see this histogram analysis in figure 1B. And from this analysis, we understood that there were some pressure measurement sections that were more stressed by sort of transients. Some of these sections are immediately downstream of some pumping stations, and this can be quite expected, but it is also interesting to see that the measurement section P036, the blue signal here, it is quite stressed by these pressure fluctuations, but it is not very close to any pumping station, and it is specifically located in a residential area, and it is on an HDPE pipe and with not so large diameter. Actually, it is at the end 160. So it is interesting to see that such a measurement section is quite stressed by pressure fluctuations. So we used this analysis to choose some sections where to put our high-frequency mobile data loggers. And this preliminary analysis can be quite useful to do a sort of pre-screening of a network so wide, so large. And these pressure signals confirm the need that we have to monitor with high-frequency data loggers to monitor networks towards better management of networks. And so I thank you again. And
okay, thanks, Katerina.
Thank you.
Okay, good presentation. Now I think I'm gonna give the mic to Sylvia. Sylvia, probably you should start with the next presenter. Thank you.
Yeah. Thanks a lot, Moitz. You can hear me?
Yes.
Okay. So it's my pleasure to introduce the sixth speaker, since I was the external examiner of his master's degree dissertation. Is Omar Abdeldayem. I don't know if the pronunciation is correct.
Yeah, it's good.
Yeah, okay. Thanks. From IAG Delft for Institute for Water Education in Netherlands. Please, Omar.
Okay. Hello, everybody. Good afternoon. It's my pleasure to present today a part of my master's thesis, which is entitled as Unsteady Friction Computation in Hydraulic Commercial Software. This thesis was conducted at IHE Delft and also Deltares Consultancy. It was mentored and supervised by Dr. David Ferraz and Dr. Maria Kennedy from IHE Delft. So up-to-date transient analysis methods are mainly theoretical, and their implementation to real engineering problems is constrained due to several physical phenomena like unsteady friction. So even though unsteady friction is...
Sorry, Omar, please you can share your
screen, yes.
I thought, I don't know, somehow I see it. Okay, I will try to do it again. I'm sorry.
Thank you.
Okay. Okay, I think I have a problem in my Zoom. It doesn't...
Doesn't work.
Yeah, okay, I'll try again. I don't know, can you see it now?
Try again.
Yeah.
Okay, perfect.
Okay, perfect. Okay, so up-to-date transient analysis methods are mainly theoretical, and their implementation in real engineering problems is constrained due to several phenomena like unsteady friction. Even though unsteady friction is well implemented in research and academia, it's not yet well implemented in the commercial software. Therefore, there is a need to implement it in more commercial software. And for our case, we took Wanda as the base product that we would like to implement unsteady friction model in it. So regarding the methodology that we adapted, we started, like our methodology was based on two environments, Python and also Fortran or /Wanda environment. First of all, we started by the implementation of the basic water hammer code in Python environment. This is followed by the implementation of several friction models. We implemented steady friction, quasi-steady friction, and also 3 different categories of unsteady friction. After that, we used the simulation that we have already developed and compared it with hydraulic experimental data based on a developed criteria that we developed together with Deltares Consultancy. After that, we chose the best model and implemented the best model in Wanda using Fortran. And finally, we tested the newly implemented model on a simple synthetic network. This was the simple synthetic network that we used for the testing of our Wanda newly version. It is composed of 5 different pipes, 2 reservoirs, and also a control valve. Regarding the criteria that we raised together with Deltares, it was based on 4 criterions: the user input requirement for the model, the stability of the model, the computational efficiency, and also the model accuracy. So regarding the comparison of the different friction models that we had, here we can see the experimental data, which are shown in blue. And regarding the implemented friction models, we have here the quasi-steady friction, which provided the least accuracy, followed by Heine's model, Daly's model, and also we had Brunoni's model and Witkowski's model, which provided almost more or less the same results. However, Witkowski's model is slightly more accurate. That's why we chose Witkowski's model to be implemented in Wanda. So here, upon testing the simulation using the previously used quasi-steady friction model and the Witkowski's friction model on the simple network that I've already described, we can see here that using the quasi-friction that the damping is really, really low, which is unrealistic in water hydraulic networks. However, regarding the first peak rise, it's okay. It's well simulated, and the first pressure rise can be used for the normal application that just needed. On the other hand, when we go to Witkowski's friction model simulation, we can see that the damping is way stronger, and this is already more realistic than the conventional use quasi-steady friction model. So to conclude, the unsteady friction model is significantly important for different application and tasks used by standard engineer. The Witkowski's friction model was found to be the best suited unsteady friction model which should be implemented in Wanda, and this was already illustrated by the developed criteria that we had. And finally, the Witkowski's model provided also an affordable computational efforts and highly moderate accuracy. So over here, I have like some of the references that I've used in the poster, and thank you. And it would be my pleasure to answer some of the questions during the coffee break.
Thank you, Omar. Thanks. Very, very nice presentation. Now let's move on the next one. Isabel Echeverribar from University of Zaragoza in Spain. We speak on a well-balanced non-hydrostatic pressure model for steady and steady shallow flows.
Yes, you can hear me and see me? Okay, so I'll share my, my screen.
Thank you.
Okay, you can share it, no,
okay.
You can see it now? Yes? Wait for a moment. Okay, so you see my screen, right? My screen. And you hear me?
Exactly,
okay,
yes.
Yeah, okay. So yeah, hello everyone, and thank you so much for attending to this presentation. My name is Isabel, and I come from the University of Zaragoza in Spain. And with this poster, I would like to show you the last work that I've been researching on. And I have to say that it's a work in progress, so any advice or idea, it's more than welcome. So where I'm showing here, okay, is a computational model for the simulation of free surface flows, in particular a model to solve one-dimensional depth averaged non-hydrostatic system that is written like this. Well, we call it one-dimensional because it's depth averaged, but in this context, we are solving the x direction and the z direction, the vertical direction. In this system of equations, we have the classical mass and momentum equations in x and z. And therefore, our variables are the water depth, h, and velocities in x and y directions, u and w, okay? Here is u and here is w. Well, but we have an additional unknown that is the non-hydrostatic pressure, is this P and H here. And thus we need an additional equation to solve the complete system. That equation is this condition here, and it comes from the continuity equation for incompressible flows. So to solve this system, there is a very well-known strategy. It is called the fractional step procedure, or also called the pressure correction method. And it's a very simple procedure. First of all, we assume null non-hydrostatic pressure. So basically, we solve the shallow water system of equations, and we get an intermediate values for H, U, and W. And these intermediate states are solved as it was a pure shallow water system. And in this case, we use a finite volume numerical scheme. After that, since the hydrostatic pressure has been assumed to be zero, the continuity equation will not be fulfilled. So if all the variables are written as a function of this unknown pressure, and we force them to fulfill this condition, the unknown pressure can be get. So this step is solved by means of an implicit scheme. And finally, with this pressure, the intermediate variables can be updated up to the corrected state. So this is important because we are correcting the intermediate states, and therefore we are modifying those intermediate states continuously. So if we go to the results, wait a moment. Yep, over here. If we go to the results, yeah, here. This model is commonly applied to unsteady coastal flows and wave propagation problems. So in this kind of problems, it presents a very well behavior. So in this case here, we have a real experiment of a channel with a bottom bar and a wave generator that was located here at the left, and some waves propagated along the channel, and water depth variations were registered at these gauging points here. So in the figure, we see that, we see the time variation of water depth at one of these probes, in particular the probe 5. We can see in brown the measurements, in blue the results, the computational results with the model. So we can see that the wave frequency was very well captured. And in orange, we are seeing the results with a pure shallow water model. So I remind you that it's assuming that the pressure was purely hydrostatic. So we can see that, first of all, we really need non-hydrostatic systems to solve this kind of wave propagation problems. But additionally, we see that, well, the shallow water system is not very well suiting this behavior. But what happened when we go to steady states with irregular topography? Well, in this case, a steady state was simulated with a constant discharge over an irregular topography that can be seen here in this black line. It's the topography. And in this case, well, this case has a quasi-analytical solution that can be read in this article here. And what we did was simulate this, and we found that this method, this pressure correction method for these steady states with irregular topography, reaches a state that do not change in time, but cannot be called steady, since the discharge is not really well conserved along the space, because we are seeing here velocities and discharge, and it's not being conserved along the space, although this state does not change in time. So the conclusions were that the application of this methodology is very robust to its main application, the wave propagation. However, it does not preserve steady states as it should be. So at this point, we are researching on energy balance schemes to overcome this problem, but it's still a work in progress. So that's everything. Thank you.
Thanks, Isabel, for your clear presentation. Now I'd like to welcome our eighth speaker, is Zoran Lee from York University, Toronto, Canada. And here we speak on study of turbulent structures across surge waves.
Yep. Hello, everyone.
Hello.
Let me play this. Okay. Okay, so hello, everyone. My name is Zoran Lee from York University, Toronto, Canada. So our research topic is the study of turbulent structures across the surge waves. So surge waves are usually observed in a tidal bore, dam breaking event, or tsunami, where you see a sudden change of flow happens, and also a high turbulence air entrainment and the discontinuity in the velocity and pressure are involved. So our research topic is to study how the surge wave flow number can impact the turbulent structures as well as the air entrainment patterns in the surge waves. So the research to date, we were using OpenFOAM, which is an open source CFD tool, to simulate the dam break wave. So the exactly solver we are using is called InterFOAM, which is designed to simulate the nature of two-phase flow. It can be combined with different turbulent models, including the two equation Reynolds average Navier-Stokes using KL epsilon, either without and with additional air entrainment source term. So this source term is added to the equation here, which is a water phase equation, alpha L. The source term is the term on the right-hand side of this equation. So we also tested large eddy simulation models with the small grain scale viscosity. It's also known as LES. So figure 1 shows the initial condition of our simulation. The D naught is the upstream reservoir depth of 10 meters, and D1 is the downstream water depth of 2 meters. So according to the method of characteristics, this height will gives you a surge flow number of 2.12, basically belongs to a breaking wave. So there are also four probes at downstreams here to capture the velocity, pressure, and phase values. So figure 2 here shows some results. From left to right are K epsilon without the source term, K epsilon with the source term, and LES. So for the K epsilon with the source term, we saw many finer air pockets near the interface, but those larger air pockets in the case A disappeared in the case B here. And for the LES, which can model a lot of fluctuations which are larger than the grid scale. Here, the case C, the LES capture most of the air treatment behind the surge wavefront. So we also plot the longitudinal velocity UX and the vertical velocity UY with time for these 4 probe locations. Some preliminary observations are here first, that for the probe 0 UX, for the probe 0, we only saw 1 peak here, but for the probe 1, 2, 3, there is a secondary peak in the plot, except for the case A, for the probe 1 case A. For the large eddy simulation, it did simulate lots of fluctuations here, but the overall trend is similar to the K epsilon models. So since we saw different flow patterns for 3 models, so our next steps will be determine which one might be more suitable for our research and see how we can validate that with the available lab data in the literature. Okay, thank you all for your listening. That's all for my presentation.
Very, very impressive work. Thanks, Zoran.
Thank you. Okay.
Now let's move on our second last speaker is Rafael Roig from Universitat Politècnica de Catalunya in Barcelona, Spain.
Yes. Hello, can you hear me?
Hello. Hello. Yes. We speak on numerical model analysis of a Kaplan turbine runner.
Yeah. Let me
Let
me share the screen.
Okay, perfect. Please.
So hello everyone. I am Rafael Roig from UPC, and I'm going to present to you a numerical model analysis of a Kaplan turbine runner. In the field of hydraulic machinery, it is important to know the natural frequencies and mode shapes of the runner during the design phase in order to avoid resonances during operation. Because of the fact that the runner is in water, it is interesting to quantify the impact of this water on mode shapes and natural frequencies. We have used the finite element method to discretize the acoustic wave equation coupled to the structural one, and to calculate the natural frequencies and the mode shapes of the runner in water. Then we have calculated the differences in percentage between the natural frequencies of the runner in vacuum and in water with what we call the frequency reduction ratio. This is the equation. And finally, the comparison between mode shapes has been done using the modal assurance criterion, which takes values larger than 0.9 for consistent correspondence and small values for low resemblance between mode shapes. As I told you before, it is interesting to know the natural frequencies and mode shapes of the runner to avoid resonances during operation. Here we can see as the water surrounding the structure makes the natural frequencies decrease down to 30 to 40% of the value of these natural frequencies in vacuum. These two pictures are the first and the fifth mode shape of the runner, in which the red color indicates the regions with the highest deformation, whereas the blue color indicates the region with the lowest deformation. At table 2, we can see the mode shapes of the runner in vacuum and in air. And here we can see that as the correlation is perfect, there are ones at the diagonal, but when we submerge this structure or this runner in a heavier fluid, such as water, this correlation is lost, especially for the highest mode shapes, like this one. We think that this study is interesting because of the lack of data about added mass, which is the main contributor to the frequency reduction ratio for cap and turbine runners. In addition, historically, it has been assumed that the mode shapes in vacuum and in water are invariant, but in this study, we have found that this correlation can be lost for some mode shape. Finally, I would like to acknowledge the European Union Horizon 2020 Research and Innovation Program to fund this study, as well as Vattenfall for the support. Thank you very much for your attention.
Thanks to you. Thanks, Rafael. Now I'm delighted to introduce the last speaker, Nicole Friedrich-Newman from IAG Delft Institute for Water Education in Delft, Netherlands. Nicole will speak on the analysis of the performance of a commercial software for pipe burst detection. Nicole, are you ready?
Silvia, I don't see Nicole connected, not in the list of attendees, nor in the panelist. So maybe we can just skip this presentation. Eventually, we'll ask her to record a video and we'll post it anyway in the web. So okay. Yeah, you can go ahead with the next part of the session.
Okay. So I would like to thank the participants and our speakers for their interesting presentation. Okay, so now let's move to the coffee break, the so-called coffee break, questions and answer time. So please, Victor, the screen is yours.
Thank you, Silvia. Okay, my name is Victor Hugo Hidalgo. I am from Ecuador. I am associate professor in Escuela Politécnica Nacional, and I'm very kind to be here. So we start the discussion. One moment, please. I need to see the question is all of the question is answered in this part, but I have so many questions for you, for all of the panels. The first is, I use OpenFOAM and Python for many years, so many years in my PhD, in my master studies, and for my studies. So, Liu Xin, what is the reason that you use Python or not C++? Because, for example, I told you, use Python is an interpreted language. For example, I want to say to Silvia, hello, she understands me because we speak in the same language. These are the compiled software, also compiled language like C++. But if I say, Silvia, ni hao, ni qingtian ni semaya, this is in Chinese. Of course, we use an interpreted language to speak with Silvia. Perhaps Liu Xin understands me because perhaps she speaks Chinese. But a lot of people don't understand us. So if you use interpreted language, you need an interpreted for the commands that you wrote in Python, the interpret for the machine. So you lost time, and perhaps you should lose a little information. What is your opinion? And what is the reason that you use Python instead of C++?
Yeah, thank you for your question. Yeah, I recognize that Python can be slower than C++, especially in like scientific computation. And to be honest, my first computer language that I learned is Fortran. So I could have do it in Python, but I could have do it in Fortran, but I feel Python is now like a more open community, and there are lots of Python package where the code is just open. You could just look at it and without any like and I mean, just very open. I really like that kind of like open source community. In the Python, I mean, I know I can write it in C++ and wrap it in Python in that way, but I still want the language to be fully in Python. So it's easier for users to like add, for example, add another components. For example, we don't have cavitation at this point. If you want to add cavitation, and I feel that will be easier if everything's in Python and it's more readable, I guess.
Just one thing to add, Victor. I just want to, because I don't know Python very well, but what I know is that Python has the ability to connect with other languages. Means if somebody has a MATLAB code where he's written his boundary condition, then probably Python can do that. You can call that function or boundary for MATLAB and use it, but C++ cannot do that. So it helps other people who uses different languages to add to Python. Would that be correct, or am I wrong?
Of course, Moyes, because you can use Python because there are a lot of people to work together, and you can use, for example, Numba library. Numba library they can use to apply that C++ code inside. But the problem of Python is the parallel simulation. For example, we would like to use a very big red or net for simulation. It's a very big net. Python is slower, and perhaps you lost data. So if you would like to do and improve this part, you need to parallel simulation on GPU simulation. So we need to use some more powerful language. So the C++ is the option, and Python is for the stars or for small examples. But if you work a very big net, you should be strong in very nice C++ or Python. You can program to parallel simulation. This is the advices.
Yeah, so we didn't implement parallelization in TSNet, but actually I have a lab mate who is now working on the parallelization of like TSNet-like package. So, and I think he already finished all the coding, and the paper is under review at this point. So stay tuned.
Okay, thank you, Lucy.
Yeah, you have another question. Do you have the possibility to compare the results you obtain by TSNet to acquire pressure signals measured in the field? I mean, if I understand well, your simulations are numerical, but you have the possibility to compare to real pressure signals.
Yeah. Thank you for your question. So first of all, in our lab, we don't really have we don't really have a lab to do experiments to this kind of hydraulic transient simulation, hydraulic experiments. But we do have like sensors in Austin, Texas, but the network is huge and we don't really have a well-calibrated network. So that was a problem. But we did compare results with Bentley Hammer, which is a well-known commercial software for hydraulic transients. And so we carry out the validations throughout the development process, and we show the comparison in our paper and also on the online documentation. So if you're interested, you can take a look.
So but what do you mean with well calibrated? You mean that you don't know, as in Italy, the path of the pipes, the diameter, and so on? Not only.
Yeah. So for example, in transient simulation, apart from the friction factor and those kind of stuff, we will also need wave speed, which is a very difficult parameter to measure in the field. So yeah, so.
I know.
Okay.
Thank you.
Okay, I have another question for Omar Abeidayen. Omar is here. Omar.
Yes.
What is the reason to use commercial software? That is one main issue. What is the reason that you use commercial software for your simulation and mix with Python?
No,
it's finished only the technical simulation.
Yeah, actually, like the first part, like regarding the Python, it's not like related to the commercial software as well. It was just like for like an easy way to compare between the different unsteady friction models. And then like the model itself, we implemented it in the commercial software, which is Fortran based. So it's implemented with Fortran language.
Yes, I know it. I saw this part. And the second one is, what is the reason that the viscosity friction you changed is better than the quasi model? What is your opinion?
Like
explain it that one.
Yeah, okay. So yeah, like usually like in the commercial software, they are more interested in the pipe burst application, which depends on the first pressure rise. However, like when it comes to the whole pressure history, it's very poorly simulated. So like for applications like leakage detection, you need like a proper simulation of the whole pressure history. And yeah, this like using Vygotsky's model will give you this advantage for such kind of applications, which is not like commonly used in commercial software.
Okay, did you know the main equations for these studies? What is the problem of the main equations or the main parameter that they produce this error in the quasi model?
For the quasi model, like I think first, like in the current model in Wanda, like there are several phenomena that not simulated, like the unsteady friction, like it's more related to the turbulent, like the floats, also float structure interaction, the viscoelasticity. So yeah, there are like different sources of errors, but like for the main difference between unsteady friction and the quasi steady friction, I think it takes more consideration to the turbulence and other factors as well.
Yes, of course. This is one of the main problems because if you don't have the consideration of the turbulence model, this is the main issue because the turbulence model is like you think in something and it's not sometimes the true part because you give it some options. So the turbulence model sometimes is the main problem in that one. That is good answer.
Yeah, but
okay.
we have the additional costs in terms of computational time.
Like comparing to generally comparing it to the conventional quasi-steady friction is not really huge. Like, however, like it's way better when we compare it with the convolutional based models. Like for example, for convolutional based model, it can take like up to 30 or 40 minutes. However, using Vygotsky's model would take like 3 or 4 seconds. So, and steady friction will maybe like take like 1 second. Like that's like using the normal computers that we usually use.
Thank you.
Thank you. Thanks a lot.
Okay, I have another question because we need to meet all of the participants. Katerina, and this is for Katerina and sorry, I have in my papers, this one is for Katerina and Filomena. This is good, yeah? When you have your experiments, you have some signals for the transient part. These signals, perhaps you can do that decomposition method or use a decomposition model that you know this one. For example, you can apply Fourier transformation, or you can use another model. What is your opinion about to get these signals and after to analyze or to do a signal analysis for that one?
Yes.
This is for Katerina and after for Filomena.
Yes, thank you. Surely, frequency domain methods for the analysis of transient signal is a very useful tool, and we are performing this kind of analysis of transients that we acquired. One thing I think is important to say is that when we acquire pressure signals from a real complex system, and if you perform the fast Fourier transform, for example, and anyway, you do frequency domain analysis, you will have a lot of phenomena within this network. So we will need to do correct decomposition of the phenomena, because otherwise we will have many frequencies, for example, stressed, okay? And we will have a superposition of the effects from different types of transients that maybe comes from a pumping station, maybe comes from consumer demand. And so we will have to do a decomposition, as you said, but this is not so easy. So we will have to study how to decompose the various phenomena to understand which frequencies are more stressed by one types of transient, or other maybe are produced by another source of transient. So if we perform the fast Fourier transform of a whole pressure signal maybe acquired for 24 hours, we will see not so much actually. And so we will have to take shorter ranges of time, and we will have to try to isolate each phenomenon to each other. I don't know if the answer is exhaustive for you, if I answered to your question.
Okay, yes, we continue to the question for Filomena, and after that we can give some advice. Filomena, what is your opinion about this signal that you get it in your experiment, and it's possible to use Fourier transformation?
I think that the transient is different in a closed network and in an open network. Since the effect of the transient is emphasized by the topology of the network. In fact, we want understand the transient behavior of a water distribution system with a different boundary condition. That is a different user, that is PRV, and a different topology of the network.
Okay, that is something very interesting because several parameters induce some noise in the signal. Of course, you have some noise, so it's complicated, like Catherine said, to use the Fourier transform from time to frequency, because you have a lot of noise and it's complicated to define what is this noise. So I remember 3 years ago with one PhD student, we proposed an empirical mode to discomposing signal. What is the empirical mode? The empirical mode is like, you don't know how many noise or what is the problem inside the pipe. You have several signals. So you need to divide or discomposing every signal with empirical modes. And this is with empirical equations. So my advice for both of you is for in the experimental part, you need to know some empirical modes to discomposing the signal and to understand very well where is the signal for the water hammer. Because sometimes if you have the signal, you suppose this is the water hammer, but this water hammer you have a lot of noise that changes the signal. So this is some of my advice or my experience, because we study some signals processing in my. I am not so younger. I look younger, but I am very old. So that is the reason that is my advice. Thank you.
Thank you very much.
No, it's okay. It's nice because they put me in the breakfast. I suppose in the coffee break, because I don't know. I am the funny. I'm one of the funny guys in the IHR. I have another question. Continue with this discussion. Very interesting discussion. Sorry for the open forum, guys. Sorry, I forgot the name. For Mr. Lee Churan.
Yes.
Mr. Lee, you are here?
Yeah.
Okay, Mr. Lee. I work with OpenFOAM from the OpenFOAM version 1.2. So many years in OpenFOAM.
Okay.
So my experience in InterFOAM is very interesting. What is the reason that you use? Please tell me something, your opinion. What is opinion related to the RANS model, the RANS turbulence models using key epsilon and the LES? What is the main difference between these two turbulence models?
So I think the biggest difference, the RANS is averaged. So everything like velocity are averaged. So those fluctuation in the turbulence are averaged out. But for the LES, it's still like saw those fluctuations in the, for example, in this plot for the velocities. So that's just my opinion. Yeah.
Okay. I brought some papers related to this turbulence model because this is my first studies 10 years ago. Okay. So, no, 12 years ago. So the main issue between the difference part of it, the RANS models, you use key epsilon and less, is behind to the wall. Because in the RANS is for the developing of the flow, And for the behind to the walls, you need to educate the boundary layers or the boundary problems that the walls induce for the turbulence. Okay. If you use less, you calculate these big eddies, and the small eddies you give a behavior based in one mathematical model.
Yes.
In runs, this behavior is reproduced by one mathematical model. It's not calculated. It's only to give some behaviors. To say this is your behavior and is based in this mathematical model. So sometimes when you use runs models, perhaps it's not a real turbulence problem. It's only an average.
Yeah.
So that is the main issue with different part. But one of the problems between less and runs, for example, the people said you use less because you calculated the big eddies, and the small eddies is not problem. No, sometimes if you don't care very well the mesh in less, the small eddies induce some errors and induce more turbulence than in the real life. So you should to take care between these two models. So sometimes the reason that the people say when you use CFD, the results are not true because they don't know very well the turbulence problems. For example, last year I brought a new turbulence. I based it in a new turbulence model. The name is scale adaptive simulation. In the scale adaptive simulation, for your case, I suppose you can use it because the scale adaptive simulation is a hybrid model between runs and less. Runs for the part is not behavior to behind to the walls. They use runs, and behind to the walls they change to the less. So you perhaps you can try.
I see.
And you can get a very interesting results because in OpenFun you can also brought in C++ your code and you put it inside the OpenFun. Very nice presentation. I like the people to use OpenFun because very fun to OpenFun. Thank you.
Okay. Yeah. Thank you.
Ron.
Okay.
And you are from China?
Yes, exactly.
OK， 谢谢你，我很开心认识你。
哎，不客气。
没事，我在清华大学毕业了，所以我会说中文。
Wow, that's amazing.
Yes.
Very good.
I live in China more than 6 years, and I graduated in Tsinghua University, so that is the reason that I speak a little Chinese. Okay, Moes, I suppose the last question is for, because the conducting this one. Sorry, Moes, I make a lot of jokes because I suppose in science we need to find a little.
No problem. I just said we need Python to translate for you. That's what I said.
Okay. Yeah, because in Python sometimes I use it in my PhD thesis. I use Python for some processing analysis, but I prefer some strong language. Okay, I don't know. Rafael Roy is here. Rafael Roy. Rafael.
Yeah. I'm here.
Rafael. Hi, Rafael. I work so many with Javier Escaler. I have a lot of papers with Javier Escaler. He's a nice guy.
Yeah.
What is your opinion about to use your model analysis? Please, can you tell us what is the difference if you use your method from Francis turbine and Kaplan turbine? Should it be the same, or we need to adapt something?
No, the method is exactly the same. Of course, the natural frequencies and the residues will be different because the structure is different, and then the natural way of moving of this structure will be different, but the method is exactly the same. Here, we are just considering a small displacement and a small variation of density, and that the flow is irrotational and without mean velocity. So once you accept this assumption, then you can apply the acoustic wave equation to describe the fluid domain.
This is so, every time I told Javier, but every time I avoid this question for me, but you are your student, so I have the time to ask this question. What is the reason that you didn't think to use dimensionless numbers or dimensionless studies? Because if you use dimensionless studies, perhaps you can change a little bit for any type of turbines. What is the reason that you think that?
Yeah, it is. Actually, it is an open question. One of my goals is to find dimensionless numbers to be able to relate the natural frequencies and other dynamic parameters between different structures or structures with different positions into the domain. I mean, when you build a turbine, you have a direct tube. So then the boundary condition, the gap between the structure of the direct tube and the turbine or the runner has a high impact. So one of my objectives is to be able to find some dimensionless number to be able to correlate this. So if I am doing a bigger gap, how will which is the impact of this increase in the gap on the natural frequency? So here, of course, we need to dimensionless something. We need to analyze which parameters are responsible for this change.
Okay, yes, this is true, because every time I tell Javier that he finds with the research, this is very important, because if we get it a dimensionless analysis, we can apply for the industry, the applications.
Yeah,
so
of course.
Thank you very much.
And then for do transformation between different scales, it is very important. Yes.
Of course. Thank you very much, and regards my my friend Javier Escaler.
Okay, I'm going to give them.
Isabel is here. Isabel.
Yes, I'm here. You hear me?
Isabel. Of course, that is the same question, because we start talking about the dimensionless analysis. What is your opinion if you can apply your dimensional analysis for the wave propagation?
Actually, it's something really common in this kind of analysis, because when we do some wave propagation problems, it's so common in the free surface flow world to use the shallow water equations. And when you go to this kind of wave propagation problems, you have to be careful with the relation or the ratio between the wavelength and the water depth of the problem that you are using or you are simulating. And it depends on these dimensionless numbers that you have the information to know if you have to use a non-hydrostatic model instead of a shallow water model, because of the information that these dimensionless numbers give to you. So I didn't do a detailed analysis, because the test cases that I choose are very well known to be problems for non-hydrostatic pressure systems. But when you get a new problem in general, you have to do a dimensionless analysis to know if you have to use the shallow water equations or a non-hydrostatic system. So it's so common and so necessary, actually.
Of course.
Yes.
Thank you. Yes, it's because this is something. In the simulation, we did a lot of questions, but the problem is more of the PhD students or the students, they don't care the dimensionless problem. And sometimes they put it the results and only get apps with dimensions. But sometimes for the industry or for the adaptation, we need this dimensionless analysis. And we need to this dimensionless mathematics.
Yeah,
so
yeah,
that is only the.
Yeah.
Of course. Thank you. Thank you.
You're welcome.
I suppose Mohamed Wakar from Hong Kong University is here. He's going to finish this discussion. You studied that reversal of waves in pressure, yes, of course.
Yeah.
Sorry, of course, yeah. What is your opinion about to do a parameter analysis? What is about? Did you do a parameter analysis for your studies, Mohamed Wakar?
What kind of? Yeah. What kind of parameter analysis? I don't understand. For what purpose you're asking?
Because in the parameter analysis, what is the main issues for the parameter analysis that you think for one PhD student, for one student? What is the main issues to do a parameter analysis for all of your phenomena?
I think if the interest is to do parameter analysis, I think the objective would be to propose a model or propose a method and see its sensitivity with the various parameters. For example, if someone proposes a leak detection method, then he probably want to analyze the sensitivity. You want to do some sensitivity analysis with respect to the wave speed to see if the detected leak result, the detected results for the defects are accurate or not. But for my presentation for today, I did not perform any parameter analysis actually. But yeah, in general, one has to do.
Yes, that is something that I suppose I brought. I didn't see in your presentation because that you say sensitivity analysis is very important in the parameter studies because we need to understand where is the problem inside our phenomena. So this is a very good question. So your answer is very kind. So I suppose you get it well, the idea. Yes, the sensitivity analysis. So I suppose it's not no more for you. No, thank you very much. I suppose if I didn't lose. Caterina Omar Behave, Isabel Iborno. I suppose I make the question for all of you. I don't know, Sylvia, if you would like to ask any other questions for the panelists.
Yeah, I have just a question for Isabel. Just let me check the number of your poster, 91.
Yes.
Just a curiosity, which is the frequency acquisition of the water depth during the experiments you
showed? Whoa, it's written on the paper, but I don't know because the experiment, it's not my experiment. It's a well published experiment that everyone that simulate this kind of wave propagation problems uses. It's actually from 1993, so I don't remember. To be honest. But it's written on the references and it's written on the paper.
It could be useful to understand the behavior of
Yes, actually it's a complete experimental paper, so they analyze very well the behavior of the wave propagation, but in terms of energy, not in terms of numerical issues that it's what we are researching on. But yeah.
And for Vacara, do you have the possibility to apply your method in the field?
Actually, we tested this time reversibility for our Gauto-Coke system. It's one of the field. It's a DMA in Hong Kong. So we tried this burst simulation and we recorded at the two ends, and then we used these measured signals to see if the waves go back to the burst location or not. And the results were very surprising and very nice. I didn't show here.
Does it work?
Yeah, it does. It does.
Very good. Thank you.
Is there any question from the panelists? They can ask each other if somebody would like to ask a question. So it's an open floor. We still have about, I think, 5 minutes. Anyone has any question?
Yeah, I do have a question for Katerina.
Okay.
Yeah, so I'm wondering, I mean, I really like the idea of like using high frequency model, especially for transient. I think it's very necessary. But I'm wondering how high is high? Why do you go to 2048 Hertz? Do you think lower but still high frequency would be enough?
Yes. Well, from literature, actually, we know that we need at least 20 Hertz to catch transients in networks, but surely if we acquire pressure signals at a higher frequency, we can be sure to capture the phenomena. If we consider, as I said before, that the remote control systems work at with time steps of 15 minutes, sometimes 5 minutes, this is not enough, obviously, to chase transients. We usually, for our measurement campaigns, we use 2048 Hertz. We saw from frequency domain analysis that the main frequencies of these phenomena are not so high, but we know also that if we acquire at higher frequency, we have a better idea and we can be sure to catch what we want to catch. Okay, so yes, we use this kind of frequency, but even a bit less can be okay anyway. Okay, so we have now some mobile data loggers. They are mobile because we can put them and move them from, let's say, one set of measurement sections to another set of measurement sections, so on and so on. They have a high frequency because, as I said, it is needed to catch transients, and we know also that commercial data loggers cannot acquire at so high frequencies, okay? Also because of batteries limits, okay? So we now have these data loggers that are very interesting because they can acquire at high frequency for till to 48 hours, and they are quite compact, so easy to move, okay? And I would like to say also that they have a GPS antenna, so we can have a good synchronization of the pressure signals acquired at even I don't know, 10, 20, 40, as you want, kilometers of distance, and the GPS ensured a good synchronization between the data, so you can have a good correlation between pressure signals at high distances. So I hope I answered to your question.
I think it's Katerina. Just maybe to mention one thing for Lou, because to know what frequency you need to measure, you basically look at your dynamic devices first that may cause a transient, and you see how fast they behave, and the time of the behavior, if you take 1 over that time, will give you roughly what kind of frequency you want to look at. But other than that, you basically just have to go and measure and just see the background noise what it shows.
Yes, I would like to add a thing. When you are called by a local water company and you go there, you don't have so many chances to acquire a lot of signals, analyze them, and then decide what frequency is better to acquire those phenomena. So when you go to real water supply system, you use a quite high frequency to be sure that
just one chance, and that's it.
One shot.
One shot.
Yeah, thank you for your response. I mean, the reason why I asked is because in our testbed we use 64 Hertz pressure data, and we still see like very high pressure transients. And I think it would be interesting if like we can reduce the frequency and see like what's the adequate frequency that we need, because using high frequency in the data process and data mining process is very time consuming and memory consuming. So maybe that's something to consider.
Yes, anyway, in the paper, you can find also some references of this thing in literature. We can say we know that 20 Hertz is the minimum for chasing transients in networks. So
yeah.
Thanks, Katerina. I think our time is up, and I think David, if you are around, maybe you say something, or you guys can close the session. I think others will start.
Yes, of course. Thank you very much to the idea for the young people from HR. Thank you very much, Moes. It was very nice to share time with you and with Silvia and for all of the panels. Yes, I never see Silvia before, so but this is my first time. Moes, I suppose I met with him in one HR meeting, I suppose, when we are younger. When we are younger.
So thanks. Thanks again for all the attendees and for all the panelists, and I wish you all the best. So I assume David should have been here, otherwise the next host can take it.
Yeah, Moes, thank you very much for chairing this session. Also to you, Victor and Sylvia. It was a very nice session, very dynamic, and well, it's a pity, but of course we need to move forward. And the next session is also promising because the topic is on hydraulic structures, and the chairs will be Arturo Marcano, José Adriasola, Stefan Felder, Ahmed Sandakar, and again, as you know, these sessions, they have two parts, the presentations part and the discussion part. In this case, the presentation part will be led by the chairman, José Adriasola, and the discussion by Ahmed, Stefan, and Arturo. But of course, everybody can contribute to this part, and especially attendees asking questions to authors asking questions to the chairs, etc. And you can already write questions in the Q&A whenever you have the question pops up into your mind. So, José Adriasola, the floor, or better said, the session is yours. You can go ahead.
Okay, thank you, David. Hello, everyone. Welcome to this session on hydraulic structures. I am José Adriasola. I'm a principal engineer, hydraulic engineer working for Bechtel, and lead of the geotechnical and hydraulic engineering services for the mining and metals business line in Bechtel. So we'll start with the presentations with Alberto Marconi, who will present the influence of berms and roughness on wave overtopping at rock-armored dikes. So, yes. Alberto, please.
I'm here. Okay. Do you hear me?
Yes.
Okay. So now,
please just you should stay within 5 minutes average.
Yeah, of course. So I'm going to share my my screen. Okay, sure. Do you see my poster?
Yes.
Okay, so I can begin. Good evening to you all. My name is Alberto Marconi, and I'm a civil maritime engineer, and I'm one of the authors of the work you see displayed on the screen. This is about wave overtopping at coastal dikes, and we focused in particular on the reductive influence that the application of a berm and of a rock revetment may have on average wave overtopping discharge. Well, why is it important to get as precise as possible predictions of average wave overtopping discharge? Well, it is mainly because it helps the cost-effective design and the safety assessment of those kind of coastal structures. What we did in particular was continuing the work Chen et al. Developed at the beginning of 2020, investigating how overtopping varies in front of slope revetment made of concrete blocks. As already said, we focused more about improving the predictions of average wave overtopping discharge made by existing empirical methods, such as the ones developed by TAW in the Netherlands and the Eurotop, exclusively for the case of rock-armored dikes. Those existing formulae take the reductive influence of a berm and roughness into account by using two different influence factors, gamma B and gamma F. But many researchers demonstrated the lack of accuracy of this method, since those coefficients seem to vary with wave conditions and with the structure configuration. We took the newly developed expressions for gamma B and gamma F proposed by Chen et al. For the case of slope revetment made of concrete blocks, and we tried to recalibrate them for our case of rock armor. What we focused on in particular was the numerical value of the empirical coefficients B0 and C0 you can see on the poster that needed a recalibration to make them suitable for rocks. There is another aspect that we investigated, since TAW and Eurotop fail in providing a method to evaluate the overall roughness influence factor where roughness is applied only on part of the slope in combination with smooth parts. To do that, Chen et al. Introduced location weighting coefficients alpha 1, alpha 2, and alpha 3, as shown in the poster, and calibrated them for the type of slope revetment I mentioned before, concrete blocks. In our work, we checked if those values are also suitable for other type of armors, such as rock ones. To do all that, we needed a large enough amount of experimental data, and so we collected that, performing in total 139 physical model tests in the Pacific Basin, located into the Deltares hydro hole in Delft. We applied a berm 20 centimeters wide for the first 5 dye configurations, characterized alternatively by rocks on the upper slope in combination with a smooth downslope and the berm, by rocks on the upper slope and on the berm with a smooth downslope, by rocks placed all along the structure, and by rocks only on the berm. The last configuration tested, that was entirely covered by rocks, was characterized by a significantly larger berm of 50 centimeters, and that was made to investigate how such a significantly different structure geometry would behave. Irregular waves were applied to all physical model tests based on Jones-Webb spectrum. Test results confirmed that the application of a berm and rock armor significantly reduces the average overtopping discharge compared to that at smooth straight slopes. Empirical coefficients B0 and C0 was then recalibrated respectively to values 0.19 and 0.70, applying least squares method to the most of the empirical data available. We also tried to validate those results using the remaining part of the experimental data obtained with wider ranges of wave parameters. Apart from the case of significantly wider berm, the accuracy of the predictions for average wave overtopping discharge generally increased within the tested ranges. To say that, we calculated the NCE index for each dataset and compared that with the one obtained by using existing formulae. Overall, our recalibrated equations show a pretty accurate NCE index of 0.8. For sure, those equations require further research for smaller relative freeboards in combination with very wide berms. It was also found that the values of location weighting coefficients as proposed by Chen et al. For structures with other slope protections appear to be valid for rock armored slopes as well. Thank you for your attention.
Thank you very much, Alberto. Good presentation, good timing.
Thank you.
Please, all the attendees, make your questions through the Q&A section in Zoom. And let's go to the next one, which is Mr. Gabor Fleet will present level set-based modeling of local scarring in the vicinity of a submerged arc bridge. So, Gabor, please. Is Gabor here? Yes, he's there.
Okay, so everyone can hear me and see the presentation on the poster?
Yes, we can.
Perfect.
Yes, we can.
So, welcome everyone. This research was basically about testing the capabilities of the numerical model RE3D for estimating local scarring in pressurized conditions. This is a special case of scarring, and most of the time when numerical models are testing for such tasks, it's done by regular free surface flows like...
Gabor?
Yes?
Excuse me, I don't know if it's only me, but I see just a white screen. I don't see yours. Yeah, I can see now the poster.
Okay, my bad.
Go ahead, sorry.
So yes, in regular conditions, this is basically done by an abutment scars or scarring around bridge periods investigated. It's done with the assumption of a regular free surface, but both the hydrodynamics and morphodynamic conditions are getting more complicated when pressurized flow conditions occur. And to test the model, a laboratory experiment was found in the literature performed Martin Vida in 2005. And well, the goal of this research was basically to investigate the backwater effect of arc bridges, and they also investigated the morphodynamic change as well. So that was a good validation data for us. The numerical model used was REEF3D, which is developed at the Norwegian University of Science and Technology. It is a level set method based model. The level set method is quite similar to the volume of fluids when calculating the free surface, but instead of calculating the ratio of air and water in the cells, the level set method explicitly gives the closest distance to the free surface. And this method is implemented not only for the free surface treatment, but also for solid structure representation, which in this case is the bridge pier, and also for the representation of the sediment bed. In case of pressurized flow conditions, it is to be noted that most of the regular three-dimensional models using a sigma grid, for example, are usually not applicable. And so we need a multi-phase model where both the water and air is represented. So this surface and the pressurized part can be represented as well. So basically, the results are rather clear. What on the middle figure what we can see is that the main initiator of the scarring below the bridge is this submerged pressurized jet, which results in very high velocities compared to the regular flow. And the numerical model performs rather solidly. The numerical simulation was stable, and on the bottom figure you can see the comparison of modeled and measured scar profile. What is observed is that, of course, there are slight differences, which could be explained by many things. For example, like there's no explicit or well-established bed load transport formulas available right now. So if it's a matter of the sediment transport model we use, but the general depth and shape of the scar is rather well represented. However, the deposition after the bridge structure is slightly underestimated. So the conclusion of this research would be that the REEF3D and the level set method is suitable for treating such complex solid water and sediment bed interactions rather coherently with the level set method. And it also shows that the relevance of numerical models is getting more emphasized nowadays. So even such complex hydrodynamic and morphodynamic conditions can be investigated by up-to-date numerical tools, which might slowly replace experimental methods as well. However, for now, their combined use is recommended due to financial financial reasons and the time required for laboratory experiments. Thank you very much for your attention.
Thank you very much, Gabor. Just a reminder that ask your questions and put your comments in the Q&A section. And let's go to the next one, who is Carolina del Pilar Icho, who will talk about the estimated effluent flows from landfill dam break. So please,
yes, good morning. Can you hear me?
Yes, we can.
Okay, I will talk about, first I have to share my presentation, yeah? I usually don't use Zoom. Where I can share my presentation, sorry.
Carolina, you can go on the bottom of your screen. There is a button, an icon called share your screen. Can you see that?
No, I can't see
the
it.
bottom of the screen.
Share screen, yeah. Sorry.
You may also
Okay.
activate your video. There is a video icon also at the bottom of the screen. You need to activate.
Okay. Now we can see your poster.
Okay.
Go
Here is
ahead,
my
please.
presentation. So we will put here like this. Can you see my presentation? So
Yes, we can.
okay, so I start. Well, good morning, everyone. I am Carolina Icho, and I will talk about the formula to estimate peak effluent flows from Brazilian dams break in 21st century. My counselors were Rodolfo Scarati and Jose Bernardino. Well, the abstract of the research is to predict the flood after a dam failure. Many computational and empirical approaches have been developed throughout history, and all includes a certain number of parameters and are intended to help engineers in quick estimates and planning more detailed studies. We aim to evaluate the different empirical formulas proposed by researchers to estimate the outflow peak dam break situations and compare the results in two different cases studies. The overtopping and piping failure of Jumeirah and Chavanches dams, well, in this study, Heki software was implemented and used as reference to calculate the discharge peaks. Considering the large amount of variables formulas, a statistical analysis were employed to evaluate and classify the results. Where first, we have compiled the following formulas here that were classified according to the quantity of variables of which depends. Formulas have been found to estimate the peak flow effluent rupture, what they were classified according to the quantity of variables. We can see here the variables of depend on. And these formulas were replenished in plans for Jumeirah and Chavanches dam. Well, in the other hand, the precision of each formula will be organized with respect to the results calculated by Recurrent software. Here we have also the plans, you can see. Then in this table, here we have two tables. The degree of uncertainty is compared between the results obtained by implementing the software in Chavanches and Jumeirah dams. They were organized by type of rupture. Here is the type of rupture and the case. Before we organize a classification of these cases, were made comparative table with the formulas and the result for the Heki hive. Well, as a conclusion, summarize the most important contributions to predict dam break flow. More than 50 formulations were found in the literature. There were limitations in some formulas and their software. We can select 3 to 5 formulas that are really closer to the results of the IAHR software simulated in rupture by piping and overtopping. The amount of parameters consisted what led us to postulate that correct selection of information is to use with the formulas is more important than detailed parameterization. I organized the more precise formula in this order, in the case of Jumeirah dam and in the case of Chavanches dam. Well, I tried to be very concise, very precise. Thank you.
Thank you, Carolina. Questions by the end of this session. So put them in the Q&A section of Zoom, and we'll go with the next presentation, which will be given by Ali Sharik. It's called the energy dissipation for flow over the Gavian Weir. Ali, are you there?
Yes, I'm here. I'm here. Can you hear me?
Yes.
Okay, sir. Welcome everyone. Myself Ali Sharik. I'm PhD student from Ali Muslim University, and today's my presentation topic is energy dissipation for flow over the Gabin weir. Gabin weir is a broadcasted weir made up of boulder filled in a wire mesh box. The word gabion is evolved from the Italian word gabione, which means big cage. Gabion is a simple form of rectangular broadcasted weir that usually span the full width of the river. The flow passes through the boulders and rocks of the Gavin weir, enhancing the dissolved oxygen due to the turbulence and make it ecologically environmental friendly structure. Physical and chemical materials such as sediment and suspended organic matter can pass through the porous body of the Gavin weir. Bacterial services and pores of the Gavin weir facilitate the degradation of particulates organic material. Many experimental and numerical studies have been carried out related to the energy dissipation on gabion, step weir, and solid step weir. They are conducted by Perez et al. And Palermo and Buttrich and Jensen. Only few studies have been conducted related to the relative energy dissipation through the gabion. Only it was done by Fatim Gautam et al. Numerically. My today's objective is to investigate the relative energy dissipation on rectangular broadcasted gabion weir. The relative energy dissipation can be calculated using the equation 1, in which E1 is the upstream energy, E2 is the downstream energy. E1 can be calculated using equation 2 and equation 3. Downstream energy can be calculated using equation 3. And relative energy dissipation is a function of upstream energy, downstream energy, head over the weir, crest height, diameter of boulders, upstream depth, upstream fluid number, downstream fluid number, and crest length of the gabion weir. A series of laboratory experiments have been conducted for the rectangular broadcasted gabion weir having 0.3 meter length, 0.225 meter crest height, and 0.25 meter width. All the experiments have been conducted at IIT in the Hydros laboratory in the Indian Institute of Technology, Roorkee, and the length of the setup of the rectangular setup is 9.6 meter, and width of the setup is 0.5 meter, and height of the setup is 0.6 meter. Gabion weir is provided at a distance of 4 meter from the upstream end of the channel, and flow straightener and flow stabilizer were also provided to stabilize the flow. Experiments were performed for the gabion of crest length of 0.3 meter and width of 0.5 meter and crest height of 0.2 to 0.5 meter. And 3 types of material were used in the present study, which were ranges from 38 mm to 45 mm and 45 mm to 50 mm and 50 mm to 65 mm. The approach also has been calculated, determined using volumetric displacement method. Using Pythagorean theorem, we can conclude that relative energy dissipation is a function of ratio of head over the weir to crest length and the mean diameter of stone to crest height and downstream ratio downstream to upstream depth. Finally, the equation for relative energy dissipation have been developed using experimental data relating to the dimensional analysis. The following equation has been produced, that is 0.624 minus 1.185 h by L plus 0.662 dm by P plus 0.068. We also observed that head over the relative energy distribution decreases with the ratio of head over the weir to crest length, and relative energy distribution increases with increase of the size of diameter of stone, and it also increases with the ratio of downstream depth to upstream depth. The derivation has been done using 20% data were used for validation, 80% data were collected for training. The following equation has been produced using correlation coefficient of 0.958 and standard deviation of -1.49 and scattering index equals to 0.105. The details of all the performance parameter can be found in the paper of Sharik et al. 2018 and Ansari et al. 2019. It was observed the equation estimate relative energy distribution within maximum plus minus 10% error for almost data. There are many. The cabin weir are the extremely successful hydraulic structures with the ability to resist erosive forces. Conclusion is the experimental and analytical study related to gabion weir related to the energy dissipation have been carried out and reported in this paper. And the following question has been presented in this paper. Thank you.
Thank you very much, Ali. We are a couple of minutes late, so we'll go to the next presentation right away, and will be given by Christine Cannon, and it's called Experimental and Numerical Methods in Investigations of Sustainable Deep Scours as Fish Habitat. So Christine, are you there?
Yeah, I'm here.
Hello, go ahead, please.
Share my screen. Can you see my presentation?
Yes, we can.
Okay, perfect. Thank you for participating in my short presentation. My name is Christine Cannon, and I'm working at the Institute of Water and River Basin Management at the Karlsruhe Institute of Technology in Germany. And my current research focuses on investigating the hydraulic and morphodynamic interaction in the vicinity of hydraulic engineering structures. In terms of suitability and dimensioning for permanent creation of deep scores. And these deep scores shall provide a habitat for adult fish, for example, barbels, and in summer and winter conditions. Local scoring occurs due to higher flow velocities, higher turbulence and secondary currents, and is mainly divided into clear water score and low lift bed score. The score depth is dependent on various factors. It's grouped into parameters of fluid, parameters of flow, and parameters that depend on the bed material. What we will focus on in our research is the geometry of the structure. The hydraulic and morphodynamic boundary conditions are based on the local aspects of the state of Baden-Württemberg, and we will look at mainly two discharges, a 2-year flood and low flow. The morphodynamic behavior was chosen as clear water conditions, as we have predominantly a disturbed bed load balance here in Baden-Württemberg. We will use different methods and you try to take advantage of the different hydraulic models that we have. You can see an overview in the table 1. So first, we did a literature review to identify possible hydraulic structures that can provide the scores. And the most promising variants will be investigated in a numerical model with a flat and a rigid bed. Currently, we are designing a flume experiment with an approximate scale of 1 to 25. And a bed material with a mean diameter of 3 millimeters with a uniform sediment grading curve. The velocity measurements will be done by an LDA system and the bed topography measurements by a structure from motion technique. The best 5 variants we will investigate here in this physical model. And then we will capture the score depth in the physical model and perform simulation with a scored and rigid bed in a 3D numerical model. And here we can identify the changes in the flow patterns due to the scoring. The last step will be simulations with a movable bed. And here we can use the results of the physical model as calibration values for the 3D numerical study. And both of the models, the numerical and the physical model, will be verified in various field studies. This is the current status of the project, and I hope you enjoyed the little insight into our project, and thank you for your attention.
Thank you very much, Christine. Very interesting. presentation. And we'll go ahead with the next one, who is, we'll skip one of the presentation because the presenter is not there, it's not here. So we'll go with Patricio Ortega, who will present flow characteristics of rectangular free-falling jets.
Okay, hello, can you hear me?
Yes, Patricio, we can.
Okay. I'm sharing. Can you see the poster?
It's coming. Not yet.
Okay. Perfect. Good afternoon to everyone. My name is Patricio Ortega Lara. I am a student at the Universidad Politécnica de Cartagena in Spain. I am going to talk about a measurement of void fractions and velocity profiles in rectangular free-falling jets. This experimental study presents an analysis of some air-water properties in rectangular jets. Dams are essential hydraulic structures whose design must guarantee hydraulic safety operations in different loading scenarios. Air entrainment generates energy dissipation in turbulent free-falling jet, and turbulence is the principal mechanism of air entrainment. Turbulence fluctuations affect the jet spread, the deformation of the free surface, and the inner jet core disintegration. Measurements were carried out in a large-scale experimental device. This experimental setup has a mobile inlet, a channel of 4 meters length and 1 meters of width that ends in a rectangular weir. The weir crest is located at the vertical falling distance seen of 2 meters from the bottom of the plunge pool, and total head in a sharp crested weir h greater than 0.045 meters. The experimental conditions were selected to avoid possible scale effects. A single tip conductivity phase detection probe was designed and built at the Universidad Politécnica de Cartagena. The probe tip was made of platinum wire with a diameter of 0.25 millimeters. Each measurement was sampled at 20 kilohertz for 45 seconds. The conductivity probe was used to measure the local void fraction distributions and bubble frequency at different points of the cross sections. And a pitot pran with a backflushing system was used to analyze the local velocity. For this study, the dimensionless parameter C divided by H has been used to classify data in a non-dimensional way. These values are between 5 and 16.5. We analyzed 2 specific flows, and the cross sections were measured with a special air solution of 1 millimeter. In results, we have that during the rectangular free-falling jet, the amount of air that enters into the jet tends to increase. It modifies the cross-section profile and the jet thickness, and to reduce the inner jet core. Figure number 3 shows the void fraction distribution, and figure number 4, the velocity profiles for both specific flows. And B90 is the jet thickness with void fraction equals 0.9. For falling distance radius less than -11, the inner jet core show no aerated water, void fraction equals 0. And for falling distance greater than -11, the air entrainment reach the center of the jet. Minimum void fractions between 0.08 and 0.25. The maximum velocities are similar to their correspondent gravitational velocities. However, the velocity tends to reduce outside of the non-aerated core, although the falling distance is relatively small, up to 1.2 meters. A slight velocity reduction effect has been observed during the fall in the jet's core. Finally, the results show the evolution of the inner jet core with a slight difference in the upper and lower nape, the aeration increment, and a small reduction of the velocity field during the fall. That will be all, and thank you very much for your attention.
Thank you very much, Patricio. interesting presentation. So we have 2 more presentations. Let's go to Mr. Andreas Miller, who will present on influence of length of microgroins on bed morphology in a straight channel. Andreas, please. I think you are on mute, Andreas. Andreas, I think you're on mute.
Thank you. I have some internet connection problems, so there was a short delay, but I hope it will get fine on now. Then thank you for the. Okay, then thank you for the introduction. My name is Andreas Müller. I'm a research associate and PhD student at Karlsruhe Institute of Technology in the Institute for Water and River Basin Management. And today I want to give you my short presentation on the influence of the length of microgroins on the bed morphology in the straight channel. Microgroins are an alternative bank protection method in which the flow is identified as the reason for erosion, and therefore it's modified by inducing secondary flow with small submerged installations called microchannels. These microgroins, they offer some benefits in contrast to traditional bank hardening structures like river rematments. For example, they are more cost effective, and they also offer ecological benefits, for example, a better cross-linking between water and bank habitats. However, until now, there's only a few studies on this case, especially there are nearly no morphologic studies. Therefore, we designed physical model experiments with movable bed in the scale 1 to 15, and these experiments were based on the conditions of one of our field projects in the Lowland River. We used a 100-year flood as a testing condition. And in figure 1, you can see the design parameters. So we used groins with an angle of 60 degrees, a certain width and height of only 1/10 of the water level. Then we made a reference experiment without groins, and then we tested 5 different lengths of groins of 1/4 to 3/4 of the length of the width of the channel. The mat morphology was then measured for the 3rd groin because previous studies show that the bank protective effect only comes into place after a certain serial effects. So during the experiments, we observed different states because of the fine plastic granulate we used to represent the coarse sand in the field project. We had dunes moving, so we had an unlimited amount of possible states to measure. We concentrated on the 2 most extreme states. State 1 is erosion at the groin's root, and state 2, deposition around the groin's root. And then at the end, we made statistical averages from these 2 states. Always keep in mind, all states in between exist as well. In the reference experiment shown in figure 1 up, you can see that the bed morphology is very homogeneous, and it's mainly influenced by the dunes which are moving through the channel. After the installation of the groins, we see some effects. The first effect is that the reduced bank near flow velocity leads to deposition along the bank, which you can see for the projected length of 1/3 and 2/3, and you see this effect is increasing with the length of the groin. At the same time, you see that the bed variety is increasing as well. This can also be seen in figure 3, where you can see by showing the standard deviation that with an increasing length of the groin, the standard deviation increases by about 30%. In addition to that, scores can be found around half of the flume width downstream of the groin's head. And this finding approves the outcome, which also had Mövs and Koll, who did the other experiments on microgroins in a gravel bed. They also observed the same deposition and scores. However, in our study, we could show that there is also an additional score which develops upstream of the groin's root. You can see in figure 2. And this forms roughly an equilateral triangle. And this area will need to be properly protected to ensure, 1, the structural integrity of the structure, and 2, to ensure the bank protection. In order to conclude my short presentation, we could see that microgroins have a strong effect on the bed morphology. We saw that the position along the bank needs to improvements of bank protection. However, at the same time, we found out that there's a second effect, the erosion upstream of the groins root, which counteracts to the desired bank protective effect. So to put it in a nutshell, we will have to do more experiments because we have a high variety on the bed morphology, and there are so many different input parameters we will have to analyze in further studies. Thank you for your attention.
Thank you very much, Andreas. Very interesting research work. Let's go with the next one, which is will be given by Tommaso Attili, and the name of the presentation is Numerical Modeling of Impulse Waves, Wave Forces on Dams. So Tommaso, please.
Yeah. Okay.
Go ahead.
Can you see my screen?
Yes, we can. I can barely hear you. Maybe you're.
Okay. Better.
No, it's a very low, very low. I don't know if you can.
Okay, I will try to speak louder.
Speak loud, yeah, please. Thank you.
Hello, everybody. I'm Tommaso from the University of Nottingham. I'm a PhD student with under the supervision of Valentin Eller and Savas Cantafiello. Today, I'm gonna talk about the numerical modeling of impulse wave forces on dams. This work is a part of my PhD project. Impulse waves are generated in reservoirs by landslides or iceberg calving. These processes may result in extreme waves, and several catastrophic events have been documented in the recent past. Among these, probably the most destructive one has been the disaster of Bayonne Reservoir in 1963, where an impulse wave overtopped the dam and caused thousands of casualties. These waves interacting with dams may generate significant forces on them. These forces, as you can imagine, are of primary interest for the design of the dam and for the wave hazard assessment of the reservoir. So we are really interested in a reliable prediction method for them. Available prediction methods are based on an empirical equation from Eller et al. 2009. This empirical equation has been derived from the interpolation of some experimental data from Ramsden 1996. Despite this equation is pretty useful, actually, it relies on a very limited number of experiments. So this work mainly aims to extend and validate this existing prediction method on a wider range of conditions and wave types. This aim has been achieved through the numerical modeling. The numerical modeling was performed with the open source toolbox Solids for Foam, developed by Cardiff et al. 2018. This toolbox is based in the open foam environment and allows to solve fluid-solid interaction problems in a finite volume method discretization. The numerical model was validated first with experimental data and an analytical model for the case of linear waves impacting a wall. And the numerical results, as shown in figure 2, have been compared with the experimental data and the analytical models for 2 selected experiments, showing great agreement. Then the numerical model was applied to simulate an hypothetical but realistic case whose numerical setup is shown here. So an impulse wave particular a solitary wave of about approximately 10 meters of amplitude impact a 50 meters high dam. The impulse wave forces on the dam evaluated from the simulation highlighted once again the relevance of these forces, and in addition, this force was compared with the prediction from the existing empirical equation from Heller et al. 2009, showing a great agreement with a difference of only about 3.6%. So in the future, detailed numerical investigation of impulse wave impacting dams will be conducted, including several conditions and different wave types. And in addition, other impulse wave effect on dams, such as, for example, the run-up and the wave overtopping, will be investigated. All these effects are of primary interest for the wave hazard assessment of in reservoirs, and this numerical study may provide a very useful tool for it. Thank you for listening, and my presentation is concluded here.
Thank you, Tommaso. Very interesting. Appreciate the work, your work, and from all the presenters. So I think there is only one missing presentation, but the presenter didn't show up. So I will hand it over now to Stefan Felder. Stefan, you can present yourself, please. And he will run the questions and answer or the coffee break session for the next half an hour or so. So, Stefan.
Yeah, hello everyone. I'm Stefan Felder. I'm a senior lecturer in hydraulic engineering and applied fluid mechanics at UNSW Sydney in Australia. So here it's at the moment 1:48 a.m. in the morning. I'm leading the hydraulic engineering research group at the UNSW Water Research Laboratory, and within IHR, I'm a member of the leadership team of the IHR Hydraulic Structures Committee. And it's my great pleasure to chair now the coffee break session, and I really encourage everybody to discuss and contribute and ask questions. Questions from the audience, from participants, from the young participants are always encouraged, and I believe we should wait for questions from you first. But before doing so, I would like just to add a few comments in regards to the various presentations. So I was very impressed by you all. I'm very glad to know that there's a new generation of PhD students coming along who are all doing very good work, very, very interesting work. So I would like to congratulate you. I was also very impressed by the presentations itself, how you presented, how your posters were done, about the clarity of your presentations and so on. Yeah, so first of all, well done. Before jumping into the questions, I would like to pass the microphone briefly to Arturo Macano, who's also one of the mentors today, very experienced mentor, and I would like to ask him to introduce himself, and maybe he wants to add a few comments in regards to the presentations.
Okay, thanks, Stefan. You get me there? Thanks for your presentation. I'm very happy to share with you the space, listening to all the papers, very interesting, and I think I congratulate the authors to present them in such a short time. So we have very little time to write questions, but we have time to discuss and to ask about some aspects of that. So I'm coming from Venezuela. I am a professor of hydraulic engineering and be involved with hydraulic structure since the very beginning, hydraulic structure committee. I've been working for quite a few years with large hydraulic structures, so it'd be very nice for me to share this time with all of you. Thank you, Steph.
Thank you, Arturo. Okay, so we've got, we had a lot of presentations, and I believe everybody has a lot of questions. So I'm happy to go step by step, follow from the first author to subsequent authors, but I'm also willing, if there are questions from the young attendees and participants, if there are any particular questions you would like to raise, I'm also willing to, yes, to skip the particular order and then come back to others. Are there any burning questions you wanted to raise immediately because this is something that excited you?
I wanted to ask something to Alberto. So if you can talk a bit more about the experimental setup, in particular, like approximately what is the scale referring to a typical real case, and if you considered somehow the any scale effect when the results are extended to the full scale, to the nature.
Okay, thank you for your question. Well, to be honest, we were not studying something real, so we just cared about a small experiment, and so our model it was not something related to a real work. So it was just to see if our recalibrated empirical formulae worked better than the existing ones, and we could be that even talking about small dikes and without necessarily into a real scale work. So we used a basin where we built our cross section, and we just use that and change the revetment every time, and that's it. Thank you.
Any other questions for Alberto or comments? So I've got a question to follow up on this. So I had also in mind, like, how do you scale this? And my other question is, if you say like it was more like a scientific study to improve your coefficients, how does your study compare to other studies? Why would you say like people should then use your study compared to existing formulas that might exist in the literature?
Okay, well, existing formula works quite well for general case. I mean, I'm referring, for example, to dike slopes with a one revetment for all the slopes, like rocks all along the slopes or concrete blocks all along the slopes. We focused more on varying roughness along the slopes. It's a more specific field. It's something even more rare in the reality. So I hope that our work will be useful for engineers when thinking about this kind of this specific kind of hydraulic works. And yeah, so the answer is we focused on something very specific. I mean, varying roughness along the slopes. Generally, you can find the same roughness on the slopes. So we were thinking about improving and optimize the revetment. So existing formulae don't work very well when dealing with this specific case.
Okay, thank you. Are there any other questions or comments, Arturo?
Oh, just one question. Of course, I am a design engineer. We are very much interested in the size of these blocks, the arrangement of these blocks, whether it's loose. You use it a lot in coastal structures. Sometimes you use it very rough. Sometimes you need it a little bit smooth. In the case of rough, how would you say react the sizes of the different sizes you use in your small model with the prototype? And also, if you can address the topic of energy dissipation for every of these arrangements, just make a comment on that. Thank you.
Okay, we thought about energy dissipation. I mean, the main reason to put rocks or blocks or other kind of roughness elements is to create more dissipation than a smooth slope. And so this is the idea behind the project, our idea. And well, but we didn't measure, I mean, the effective dissipation. We just see that putting rocks or blocks or something rough increase the dissipation. And what was the other question? Sorry.
Yes, you could make. Yeah, sorry. You could make some comparison, some projection of this kind of material with prototype materials.
Yeah, when we build something real, a real dike, we need to assess the stability of rocks. So there are in literature formulae that provide the optimal size that guarantee the stability of the element, and so that is the reference to how choosing a size for the roughness elements, for example, or at least it is one of the aspects of the problem.
Thank you. I suggest we go to the next presenter and see if there are any specific questions to Gabor. Gabor presented on scouring under pressurized conditions. Are there any questions from the attendees, please? Yes, Arturo.
That's me again. Thank you, Gabo, for your nice presentation. You tested pressure flow. You talked about pressure flow. I've seen bridges being pushed and lifted, during a flood. But this has been in concrete structures. So talking about your topic of scour, how would you consider, how would you think about the difference of having pressure flow against free flow in the erosion process by the pier or by what is taking place at the bottom of the river? That's could you say a word about this?
Well, if I understand the question correctly, so I believe in case of such flow conditions where the bridge ducts become inundated, there's a more intense bed shear stress and flow velocities occur because of this, because not only the bridge pier contracts the area of the cross section, but also the deck of the bridge as well, which means that the same discharge goes through an even smaller, so has to go past an even higher obstacle, which is, I'd say, more intense scarring. So from the studies I've seen, I usually see that this can make really much of a difference. So in most of the cases where the bridge deck becomes submerged or partially submerged, the scarring gets more and more intense. There's a lot of laboratory experiments regarding this issue. However, and this was the point of this research, the numerical modeling part is not yet investigated in this manner. But it is also important to note, I think, that this issue is, I believe it's mostly restricted to smaller rivers and smaller bridges, because our bigger bridges in large rivers are usually designed for much higher flows. So nowadays with the global climate change, we have more and more frequently, we have these flash floods. And this is, I think, the area where this research has its relevance, when very big discharges come in usually smaller rivers.
Yeah, you mentioned something really important there. So that's a comment that I believe is valid for quite a few of you, to really link this to real world. So what is the impact of your research in the real world? We are engineers, so whatever we do needs to have an impact on the real life of people, and your example of a flood is definitely something people can relate to and has got social impacts. Yeah, we do something good for society. I've got one question to you, because you're using a rather complicated system with pressurized flow underneath bridge piers, and then that linking in with scour. Mm-hmm. So you may have presented or mentioned it, but have you validated your numerical model outside of the scour itself? So for the jet that you have, your pressures that you have, etc., the flow depths you have as a first step to make sure that this is all scaled correctly or validated correctly before you go to the more complicated part of scour.
Mm-hmm. So you mean the basic hydrodynamics?
Yes.
Yeah, well, in this study, which I used, there fortunately were no velocity measurements. The only thing that could be used for is the backwatering effect. So the difference between upstream and downstream water levels, which was rather well estimated by the model. However, I've been using this model for a long time now, and so I'm quite confident that this flow condition, which is quite complex, but not that complex, can be well represented, because I've been doing simulations with much more complex geometries where I had accurate validation data, velocity, and water level profiles. So I'm quite confident about the hydrodynamic performance of the model. Unfortunately, in this case, there was no very good way to validate the model this way. So yeah, the question was how the morphodynamic module works or performs.
Thank you. I mean, keep that in mind. Any numerical model that you use, you need to validate and make sure that it operates before going to more complicated cases.
Yes.
Are there any other comments, questions from the audience?
Thank you, Stefan. Yes, a quick question. You talked about climate change, and we started to think that all our works of our engineering works are going to be designed or adapted to new flows and sediment, whatever. Then thinking of your problem of the scar of a bridge, What about if you have flow over the bridge, over the deck? What kind of change will you see in the process you are dealing, and how do you tackle with your numerical model? Are you thought about this? Yes, thank you.
Yes, actually I've been using other laboratory experiments for the validation of my model. This was not presented in this study, but there were cases where the bridge deck is fully submerged. And in this case, there's this underwater hydraulic jump occurs over the bridge deck, which makes the whole problem more complex. But the numerical model, from a hydrodynamic point of view, can tackle this problem as well. But as far as I've seen, this well, in case the water level above the bridge deck is not way higher than the water below it, so it's still like so the conditions are not that distracted. Then the general flow problem under the bridge deck and the scar, it's quite similar. So this is what I've found so far, and this is more or less confirmed by the literature as well.
Okay, thank you, Gabor. Yeah, let's move to the next presenter. Carolina presented on effluent flows from dam flows, the effluent from dam flows. Are there any questions from the audience? Any comments? Yeah, in particular attendees. Anybody wants to mention, ask anything? Okay, so I might start. So Carolina, you presented very detailed overview of yeah, many different methods to compare effluent flows. So you then compared data, you ran the model, a HECRAS model, and you compared these empirical formulas with these various models. I was mostly interested in how did you select those empirical based models? There are probably many in the literature, as you mentioned, but which one, or could you exclude some of these before even? Because some might be based on very small experiments, might be based on, yeah, which could be affected by scale effects. Others may not have been conducted very thoroughly. Did you consider all, or did you pre-filter your models?
Okay, yeah, I filter. When I was looking for the formulas, there were a lot, so I had to limit to the more recently. Also, I found another parameters to search the formation time of the bridge, parameters of the bridge, exactly. So I can give like a recommendation for future works. I think that could be a study then. Another thing that I see that it is that most of works are doing like investigations in that effluent. So, but no, there's no research in comparing the big research. There are a lot of data, but I see that there are no works who compared all the authors who can give that. That is my I don't know how do you say, sorry, but that is the objective of my work, to compare it and to search what can I add to that. Another filter that I used was the dam bridge, the dam, that there were, I used data from Brazil. So I limit that from Brazilian dams. and I put 21st century because I did it now, it's recently. Yeah, I used the software. Another context that I used could be okay. Yeah, I look for that. Okay, yeah, there were I found dams that are of different material. So in the Heki High software, I had to put the material to this function. So, and I noticed that depending on the material, the results how do you say this, are different. Yeah, I don't know if I respond enough.
Okay, thank you. Are there any other comments? Yeah, Arturo.
Well, if just looking at the time, if I taking so much, making so many questions, you can, you can tell me, Stefan, please. Yes, Carolina, very interesting your investigation. I was thinking when you have so many data, so many formulas, when you have a result, you say, okay, how do you say it's the best? How do you say the best formula for a given case study? And secondly, as a researcher, you have so many data that you say, okay, can I do a dimension analysis or something where can I group my variables in groups, or trying to set up say a procedure to main non-dimensional data, all that. Have you thought of that? My last question is about the prototype that you mentioned. You used some prototype data from Brazil, I think. Yeah. Can you say what kind of information do you use? How will you characterize that data in your study?
Okay, where the data were given by how do you say this, with laboratory of the USP. They were investigations, and they helped me with the data, and then the other question were sorry, could you repeat the first question, please?
Which is how will you select a good formula for a given project? And,
okay, yeah. How I select the precise, what formula is best. Okay, so I did, as you see the formulas, I classify them. The cases I put, like 4 cases I put in one group because they had the same results, and then another one, and I put the same results. I classified, and then I look for the most repetitive. What of them are repetitive? So then I put that the most precise are the more repeated.
Okay,
yeah.
Thank you.
Because
considering I have to look a bit at the time, so we've got 16 minutes left, and I would like to get also to the other speakers. So thank you, Carolina. Let's move to Ali, who presented on Gabion Vias. Are there any questions to Ali? Any comments? I may have a question. So you presented your energy dissipation, and you measured downstream, upstream, and fit a formula to your Gabion vias. Basically, two questions. One is, have you compared it against available data in the literature? And the second one is, did you consider to use a discharge coefficient, which is commonly used in weirs, rather than looking at energy dissipation between upstream and downstream?
Sir, I have not compared. We have not collected the data from the literature. I have also provided the coefficient discharge equation in other papers, which is already submitted in the journal. We also preparing to drive a mathematical equation for energy dissipation for the Gabion via. We have a data, many data related to the flow condition, submerged flow condition, and transition flow condition, and free flow condition. We plan for driving mathematical equation for the energy dissipation for the Gabion.
Okay. A really important thing is, if you do experimental research, to do a thorough experimental literature review, and then really compare your data with available data from the literature, to just make sure that your experimental setup works as expected, I would say. Okay.
I have a data related to the coefficient discharge from the literature, but I have not collected the data related to the energy dissipation. Only one study have been conducted related to the energy dissipation for the Gabion well, which was done by the Fatima Okadam et al. 2018 only, which is numerically based, not experimentally.
Okay. Thank you.
Thank you.
Are there other comments, questions? Okay, so then let's move to the next speaker. It was Christine, who presented on fish, not on fish, on scour holes and the potential use for fish. Is Christine still here? She was here before, she disappeared. Maybe we move to the next presenter, and then we may come back afterwards. So that was Patrizio, who presented on air entrainment in jets. Are there any questions for Patrizio?
Sure.
Look, I've got plenty of questions because it's an area I'm particularly interested in, but are there any other questions from the audience?
Go. Go. If you have something left, please. I can. No, just I know you have many questions. I just wanted to say if you can give a brief idea of how these results will help design this kind of investigations. It's very interesting, Patricio, and you are in a small flume, 1.2 meters head, if I recall, and then you go from that trying to get information with to be applied in the design of a pool or to characterize some problems. So how do you see this? How are you motivated to say that it's going to be a very interesting, application?
Okay, thank you. The motivation is energy dissipation. How amount of energy dissipation we have in the free-falling jets. We can't extrapolate the data real structures, but we need understand very well the air entrainment process in free-falling jets. previous results, we can extrapolate the results, but only velocities or object thickness, but air water properties, for example, bubble chord length or southern diameter, we cannot extrapolate it because air water flow is more complex for the phenomenon is complex. And the motivation is that energy dissipation, how amount the energy dissipation is possible during the fall.
Thank you. So to follow up on this, so you're scaling at laboratory scale, and we know that air water flows are not scaling to the prototype scale. Are you planning then to do like scaled studies where you change your scaling at the laboratory to identify potential scale effects, or how significant your scale effects might be?
We study significant scale effects when, for example, head overweight, the, how do you say, the total head overweight greater than 0.045 meters, no less. And other parameters, the Reynolds number. It's common works when a greater Reynolds number for depreciate in viscosity forces and superficial. But the model is with criteria the crude similitude.
Yeah, just as a final comment, maybe always keep in mind that certain properties may not scale, and if you make major findings in terms of energy dissipation, as you set out to do,
absolutely,
you need to make sure that this can be scaled to the real world.
Yeah.
Okay, so I see that the previous speaker, Christine, is now with us. Maybe if there are any comments to Christine. She presented on scour holes for fish. Anybody, any questions to Christine? Okay, my question actually, when I read the title there, Christine, are you there?
Yeah, I'm here.
Yeah, my question was, when I read the title first, I thought like, oh, you may need to be in the eco-hydraulic session on the other side, but then I figured out you were actually presenting on the scour. So my question is more like, if you do this research all for fish, how do you consider the fish in your experiments and in your field study? How do you know if these scour holes are suitable for fish?
So we are in close cooperation with the state authorities that are responsible for the fish habitats here in the state of Baden-Württemberg. So together we figured out like optimum form of the score, like for example defining flow velocities inside the score, how deep it should be, and there are some biological related issues that we have to consider. That's true. And there's also a new study that's based in the state where for specific fish types there are defined different habitat structures, and the score is one of these habitat structures that we will look at now.
You're relying on, so you're not planning to use fish yourself. You're relying on the fish biologists providing data.
Yes, we will rely on the expertise of the fish biologists, and also the study that we're basing on is getting a strict cut between the hydraulic and geomorphic issues and the biologic issues, because there's like the interdisciplinary point where we meet with different types of how we think about problems. Like engineers are mostly focusing on, we want some numbers, like for certain flow velocities, for depth, we want to define values, but fish biologists tend to say, okay, we are in a natural environment, so natural environment does not work with certain numbers. Maybe there are like thresholds, but not defined numbers that we can use. So it was quite a challenge to define the just the geometric properties of the score.
Very interesting. Very interesting. Considering the time, I might move to your, I believe it's a colleague. It's Andreas from the same institute, yes, who presented on microgroins in channels. Any comments, questions for Andreas?
I have, if anybody wants, I make some comment. Andrea, thank you for your presentation. It's, I was thinking, I don't know the size of the river you are dealing with. Sorry about, I don't know much about this topic in Germany. And you talk about 100 years return period. This is a very large flow for any river. And also, for this kind of situation, even more flows that may come, do you consider to make overtopped the groin? These only groins acted as say non-overtopping structures. This is the kind of suggestion or question I have with your research. What do you have in plans?
Yeah. Thank you for your question. Interesting one. So in general, this concept of microgroins goes back to practical guidelines which people in the field developed. So not on the engineer basis, but on the technician basis. They applied these, they published, let's say, technical papers, but no scientific research has been done so far, only some minor experiments. And I really want to stick with this submerged installation. So they are derived for always being submerged, even in low water conditions. So we're talking about heights of, for example, in the river where I'm working, it's about 15 meters wide. At the 100-year flood, we have a flow depth of around 3.70 meters, and the groins are like 35 centimeters. So they're really, really low. And this is a trait I want to keep in all my investigations. So it's not only laboratory experiments I'm doing. So it's a mixture of field experiments and laboratory tests. And I use one method for validating and calibrating the other. So for example, the different erosion and deposition areas I showed, I was also observe them in the field. So especially this score at the groins head, it was easily to distinguish in the field. The deposition, it depended in the area. And the score upstream the groins route, it was also to be found in some of the groins, not all of them, because in the natural river as well in the lab, we have the dunes moving due to the fine sediment. Yeah, if this answers your question.
Thank you.
Welcome.
Okay, thank you, Andreas. So Tommaso, you last but not least, are there any questions for Tommaso on his numerical model, the modeling study of waves? So I've got one question here. So you mentioned you are using numerical modeling and you used like old experimented, not old, relatively new experimented data from Hella previously. Are you planning to also validate your results further against large scale and prototype scale data that might become available?
Yeah, of course. I mean, if there will be available, I will use them. I mean, honestly, I'm planning to do some experimental tests myself, which due to the actual situation have been suspended. They will be conducted at small scale due to the facilities available at my lab. However, we are planning to investigate and hopefully give a method to avoid and understand scale effect. So that also if we do experiment at small scale, they will still be reliable and they can be used for validation of numerical models.
Are there any other comments, questions to Tommaso, or any other comments more generally to the session that we just had? Okay, so it's 1 minute past I'm saying 2:30 a.m. in Australia, so it's somewhere in the afternoon where most of you are. I thank everybody for attending this session. I had great fun. It was nice to meet you all. I learned a lot, and I trust that the next generation of researchers it's doing really good work and will proceed in their career. Thank you very much, everybody.
Thank you.
Thank you.
Okay, thank you very much, Stefan and Jose and Arturo, for sharing this very nice session. I think it was a nice session followed by a very interesting discussion. So now it's time to move to the next session. But before that, maybe I would like to make sure that the other session in parallel is already over, the one on eco-hydraulics. Maybe from IAHR Secretariat, maybe Elsa, can you confirm if they have finished already in eco-hydraulics?
No, they haven't finished. They are still discussing.
Okay, so maybe we should wait a couple of minutes because as the next one, it's a plenary session. It's a pity if some of the guys in eco-hydraulics are missing this session.
Okay, I will remind them.
Okay, great, thank you.
The microphone.
Claudia, I see you are already connected as panelist.
Can you hear me?
Are you there?
Yes, can you hear me?
Yes, but very low. Your voice is very low.
I try to connect in a different way.
Okay.
Now can you hear me better?
Yeah, much better. Thank you.
Okay.
And maybe if you can switch on your video,
Yes.
we can make sure that the virtual background and these kind of things. Okay, okay, it's working properly. So I can see you and I can hear you.
Yeah.
Perfect.
Okay.
And also in the case of Ronald and Daniel, if you can switch on your camera.
Yep.
Hi, great, thanks.
Hi. Nice to meet you. Hi, Ronald, Claudia.
Hi.
Hi.
Hi, Daniel. Hi, Claudia.
Hi, Daniel. Hi, Ronald.
Nice to meet you.
Yeah.
Nice to
Claudia.
meet you.
Nice to meet you.
Nice to meet you.
So let's wait 1 minute and see if Elsa can confirm that in eco-hydraulics they have finished. I see that the numbers of attendees, they are stable, so it means they are still there, I guess.
Yeah.
David, I just spoke with Jose Maria, the host of the other session, and he explained they are about to finish and they're asking the people to attend this session, but I think you should already start.
Okay, then we start because it's true. If we delay it much more, then of course we will delay the closure, and it's better if we start. Okay, so yeah, welcome to the final technical session of the first IAHR YPN Congress. And so this is a plenary session on the topic of fluid dynamics, fluid mechanics, which is one of the core themes of IAHR. The chairs are Claudia Duce, Daniel Horna, and Ronald Gutierrez. Claudia will be the leading moderator in this case. And additionally, let me mention that she is the current holder of the IPEN Award, which is the most prestigious prize issued by IAHR to mid-career or even senior researchers. So I'm leaving now you with Claudia, and remember to use also the Q&A from the very beginning. You don't need to wait until the coffee break session because your questions will be written, recorded in the Q&A, and then we can go through them after the presentations part is over. So Claudia, the session is yours. You can go ahead.
Thank you, David, for your kind presentation. And welcome to the session of fluid mechanics within this first IAHR Young Professional Congress. And I would like to briefly introduce the Fluid Mechanics Committee, which is one of the classical technical committee of IAHR. And the main focus area of the Fluid Mechanics Committee include several complex flows as stratified flows, shallow flows, flow and turbulence structures over rough boundaries and porous media, and also two-phase flows and interface problem. And these flows are investigated with state-of-the-art experimental techniques like particle image velocimetry, particle tracking velocimetry, and also numerical simulations, very advanced as direct numerical simulations and large AD simulations. The Fluid Mechanics Committee organizes several events as the YERCA Summer School on Environmental Fluid Mechanics, and several symposium has the Symposium on Environmental Hydraulics and Stratified Flows, Shallow Flows, and the Conference on Hydrodynamics. Then I hope that you will join all these events, and I hope to meet you all during the next meeting of the Fluid Mechanics Committee that will be held during the IAHR World Congress in 2022, right? That has been moved. Now we can start with the session on fluid mechanics with the first presenter, that is Pablo Solán Fustero. And he will talk about a well-balanced DG scheme for the resolution of the shallow water equation. And please, Pablo, you can start to present your poster.
Hello, can you hear me?
Yes.
Can you hear me? Okay, okay.
Yeah.
So I'm sharing my
screen. Yeah.
My screen. So can you see my screen?
Yeah, perfectly.
Okay, thank you very much. It's a pleasure to be here. My name is Pablo Solán Fustero. I'm a PhD student in the Computational Hydraulics group at University of Zaragoza, Spain. And the work I'm now presenting was done in collaboration with Adrián Navas Montilla, Javier Murillo, and Pilar García Navarro, all of them members of the same group. Okay, in this work, we present a novel framework for the construction of discontinuous Galerkin schemes using augmented Riemann solvers for the resolution of shallow water equations. The 1D X-split shallow water equations we use, which are shown in the introduction section, represent the projection of the 2D shallow water equations onto the x-axis. So they include the transverse momentum. To solve this system, we use DG schemes, discontinuous Galerkin schemes, which are based on the approximation of the solution as a linear combination of both basis functions and degrees of freedom, so that the updating scheme can be expressed in terms of these degrees of freedom and basis functions, as you can see in section 2 numerical method. The augmented Riemann solvers are applied to numerical fluxes at the interfaces and satisfy exactly the Rankine-Hugoniot condition. These conditions ensures the preservation of equilibrium solutions, also named as the well-balanced property in shallow water equations. So we have tried 3 cases to test this augmented solver with DG schemes. In the first case, we have obtained successful convergences rates of the well-balanced third-order DG scheme with smooth topography. Also, the prescribed orders of accuracy are achieved, as you can see in Table 1. Case 2 is designed as a dam break, and it is plotted in Figure 1. The intermediate states are accurately predicted, as well as the location of the shock wave and the rarefaction wave. You can see in the detail box where the black solid line is the exact solution, the purple line is the DG scheme solution, and the green line is the first order scheme solution. And finally, case 3 represents a contact wave, plotted in Figure 2. From these results, it can be seen that the third order scheme, the purple line, reproduces the sharper transition much better than the first order version of the augmented Riemann solver, which is the green dashed line, and it is even more dissipative. So to sum up, the main conclusion is that the DG schemes are automatically well balanced when using augmented solvers without requiring extra correction of the numerical fluxes. In this regard, the following 2 conditions must be met. First, the use of an exact quadrature rule for the surface and volume integrals in the updating scheme. And second, the discrete equilibrium must be satisfied by the reconstructed data. So the proposed scheme achieves the prescribed convergence rates and preserves the equilibrium states of relevance with machine accuracy. As future work, we would like to implement the limitation of shock oscillations, solve correctly wet-dry fronts, and also parallelize the 2D scheme using CUDA OpenACC to solve it in the GPU. And that's all for me. Thank you very much for your attention.
Thank you for your presentation. Now we can move to the next presentation.
I guess that would be me. So
yes, the next presenter is Leonard Stefan.
Can you turn off your screen sharing, Pablo?
Yes.
I'm trying. I don't know how.
All right.
Sorry.
No problems.
Don't know how.
Let me see whether I can just override it anyway. That'll make it easier. This one. Sorry. No problem.
Yeah. Okay.
Can you all see?
Yeah, we can see your screen, Leonard. And Leonard Stefan will talk about performance improvements and dynamic load balancing for shallow water flow simulations.
Yeah, so welcome everybody to my presentation about concepts for performance improvements of shallow water flow simulations in particular, but also actually relating to 2D finite volume solvers in general. My name is Leonard Stefan, and I'm working on that topic within the framework of my PhD at the Chair of Water Resource Management and Modeling of Hydrosystems at the TU Berlin. Over more than a decade, a robust solver for the depth average shallow water equations has been developed at our chair. A funny coincidence that also seems to be what my previous presenter is doing, like at least the shallow water equations. Anyway, this solver called HMS, which is short for Hydroinformatics Modeling System, is written in Java, so it doesn't lend itself particularly well to some forms of optimizations. That's why I wrote a CPP framework for 2D FVM solvers and implemented the already well-tested solver logic from HMS in this new framework. I dubbed the whole thing HMS++, and once it is mostly feature complete, it will be publicly available under a GPL license. So if any of you want to write a 2D FVM solver, hit me up. My code may already be a good basis. you can reach me via the email address on the poster. So HMS++ is built upon an open source numerics library called Eigen, and it currently features the framework for different mesh types, field variables, boundary conditions, and so on, a mesh and field redistribution module for MPI, currently only for structured meshes, but we will extend that in the future, an import module for the mesh generator Gmesh, an interface for ParaView for visualization, and probably some smaller parts that I'm forgetting right now, and of course, the shallow water equation solver, which is used to investigate possible performance improvements. The first candidate for performance improvements were cell-based computations, by which I mean computations that only operate on data for single cells and are independent of other data. These are pretty easy to speed up because you can write them in a way that makes use of single instruction, multiple data, or short SIMD operations. And on the poster, you can find all that under vectorization. Vectorization is just a form of SIMD. So here in the methods, results, and conclusions. This is especially easy for single cell-based data with the numerics library Eigen that was used here. However, once that was done, the hard part began, which is the flux calculations. These access both edge and cell-based data, and typically not in an optimal order. You can see this here in the middle of this figure here. Ideally, you'd want the accesses to cell data to be right after one another, so that they would form like a column with no gaps here. Because then the data only has to be loaded into the cache once, and loading and storing data from main memory is comparatively slow. So the main idea for optimizing the flux calculations is to reorder them. For example, by traversing the edges row by row. So here on the left, you see the example mesh that these correspond to. So instead of going like index by index, which is this here, right? So 0, 1, 2, 3, 4, 5, and then later the vertical ones, we just go row by row. So 8, 0, 9, 1, 10, and therefore we access the cells in a different way, and this is shown here. So here you can see the cells that are accessed, and here you can see the order in which they're accessed. So instead of this huge gap here in the middle, where very likely data is evicted from the cache, you only have this very thin line here that also scales much better for larger meshes. And so you have much better data locality. Yeah, but then once we did that, and we also tried a blockwise access pattern, which is even a bit better, we found that the atomic write accesses to storing the flux calculation results was the new bottleneck, and that's typical for working on performance improvements. That like once you remove one bottleneck, you just find the next one. So yeah, that's just the typical workflow there. So currently, we're looking into a traversal order that completely eliminates concurrent data access, so that all the threads just work on their local data. There's no possible overlap through interface edges, and then the interface edges are treated later on. Yeah, but yeah, we're still working on that. And another area, like the third one here. So right now I was talking about the reordering of flux calculations, and the last thing here, that area is like when we are talking about shallow water flow specifically, there's a load difference that is caused when you have wet cells versus dry cells. So dry cells typically cause lower computational loads than wet cells, and so you can get a load imbalance. And if you employ dynamic load balancing, you can turn that into an advantage, because then the idle threads, or in this case, much more likely idle processor nodes, can take over work from other nodes, and therefore even it out and reduce the overall time required for your computation. But yeah, what we're doing for that is like a whole different topic. It's also pretty long, and so I won't go into more detail here. The abstract has a couple more like the extended abstract has a couple more details on that. Instead, I thank you for your attention, and I'd be happy to answer any questions you have then in the coffee break, I guess.
Thank you, Leonard. Now we move to the third presentation. The presenter is Maria Chiara De Falco, and she will talk about bottom gravity currents and stratified exchange flows in a rotating channel.
Okay, can you hear me?
Yes, can you share the screen?
Yes, of course. You are looking at my screen now. Okay. So thank you for your introduction.
We are not.
And,
I'm not.
So I will present today.
Oh, now.
No?
Now we can see the. Yeah. Okay. We can see the
Okay.
screen. Your screen.
Very good. Okay, so I will present large-scale experimental study which was funded by European Community under another Laplace project on bottom gravity currents and stratified exchange flows. These are flows that develop when two adjacent water bodies have pressure gradients or density differences. And this, for example, can happen in sea straits or estuaries, where we could have these two water masses with very different properties in terms of density, for example, which are connected by a submerged channel. So depending on the scale of the phenomena and the latitude, Earth rotation can affect the flow dynamics by introducing a geostrophic adjustment of the counterflowing water masses. Starting from this geophysical application, we developed an experimental study, and we conducted the experiments at the Léger Coriolis rotating platform, which is a unique facility to investigate these geophysical flows because it consists of a 13 meters diameter circular tank, which can be rotated in anti-clockwise direction with a constant angular speed to reproduce the Coriolis force experienced in the northern hemisphere. Inside this channel, this circular tank, a channel was built in plexiglass. It was 6 meters long, and it has a trapezoidal cross section where we reproduced these exchange flows. So we constant volume flux of saline mixture was fed at the bottom of the channel from basin A, which we can consider the marine basin, to reproduce the bottom gravity current, while two pumps were employed in basin B, which we can call a river basin, to generate a pressure gradient and induce a fresh flow rate in the upper part of the channel, and then to reproduce the exchange flows. We were able to obtain high resolution velocity fields through the particle image velocimetry, which I will call a PIV, in several sections across the trapezoidal channel, 11 sections. Each section has a domain of 1 meter in the x direction. And so through many PIV plans, we were able to reconstruct a 3D view of the distribution of the velocity fields across the channel. So the main parameter varied were then the relative magnitude between the fresh water and the saline water volume fluxes, Q star, and the Coriolis parameter, which was varied by increasing the angular velocity omega of the circular tank. So 4 parameters were considered, including 0, which is the non-rotating case. And the results suggest that both the increase of these two parametric conditions can affect the dynamics of these flows and the velocity distribution across the channel. In particular, if we focus on the increase of the upper fresh water flow, we see that it causes the reduction of the lower layer thickness, which can be defined as the zero velocity interface, while the increase of the angular velocity omega causes an increase of the inclination between the two counter-flowing water masses, which are in a geostrophic balance.
thus the combination of these two parametric conditions, thus the relative magnitude between the two volume fluxes and the Coriolis parameter, is able to, they combine to provide the most effective condition for the deviation of the saline layer in one side of the channel. So for the highest rotation rate and fresh flow rate, we have the complete deflection of the saline outflow in one side of the channel. Moreover, we were able to characterize these flows through an adimensional number, which is the Burger number, which also in literature has been seen to control and govern this phenomena. And the Burger number is defined as the Rossby radius of deformation divided by the channel width. And we saw that for Burger number less than 0.5, the exchange flows reach an unstable condition with time and space variability in the velocity fields, as you can see from this contour plot, which are taken in different time. And this corresponds to a baroclinic instability with the formation of meanders inside the channel. So I finished my presentation. Thank you all for your attention. Thank you, Maricara. And now we'll move to the fourth presentation, and the presenter, the speaker, is Maria Rita Maggi, and she will talk about interaction of gravity currents with slopes and overhangs.
Good evening, everyone. Thank you for introducing me. It's a pleasure to be a part of this event. As like the speaker before me, I would like to speak about the gravity current. As we know all by now, the gravity current is a flow driven by density gradient between two fluids due to temperature or salinity gradient. So those kind of flow widely occur in natural environment or in man-made situation, and they usually develop over a complex topography. So indeed, the aim of my study is to investigate how a complex topography can affect the dynamic of the gravity current. To reach my goal, I performed several laboratory experiments in a perplex tank that allow to reproduce bidimensional gravity current. As we can see in figure 1, thanks to a fixed gate, I was able to divide the tank into regions. The first one was filled with a salty water and a no quantity of dye, while the rest of the tank was filled with an ambient fluid. The density gradient was kept constant, so the run starts when the sliding gate is suddenly removed and ending when the reverse flow reaches the opening of the fixing gate. So moreover, thank you to an imaging analysis performed, pixel-based, it was possible to obtain the instantaneous width average density field, and thanks to them to study the experimental front position of the current and the reflected current position. So to detect the front position of the current was adopted an isodensity contour R2%, while to define the position of the outgoing bore was adopted an isodensity contour of 50%. As we can see in figure 3, the position versus time for all the experiments are defined. In the panel A, we have the upslope cases, while in the panel B, we have the overhang cases. So in the upslope cases, the current is characterized by a constant front speed until it reaches the slope. In that moment, the dense flow starts to decelerate as it flows up, while a portion of the dense flow is reflected back upstream. Moreover, we can see that the initial bore reflecting point seems to be related to the inclination of the slope, precisely a negative correlation with the inclination of the slope. While in the panel B, we have the overhang cases. In this figure, we can see how the initial position of the current seems to decelerate before to approach the barrier itself, and the reflected bore starts in a close range of time for all the experiment, and this change of behavior can be due to the presence of the barrier itself. So in conclusion, despite the initial development of the current seems to be similar for all the cases studied under investigation, we have a completely different dynamic behavior of the dense flow when it starts to interact with a barrier. Thank you.
Thank you for the presentation, Margarita. And then we move to the fifth presentation. The speaker is Jorge Santamaria, and he will talk about applicability of Telemac 3D for fine-scale hydraulics.
Hello, everyone. Can you hear me?
Yes.
Okay.
Can you share the screen?
Yep.
Thank you.
Okay. Can you view the screen?
Yes.
Okay. Okay. Hi, everyone. Thank you very much for this opportunity. My name is Jorge Santamaria. I'm graduated for Grenoble INP NCQ, and I'm going to talk about my master final project that was applicability of Telemac 3D for fine-scale hydraulics, and it is the result of my internship at Artelia. Let's get started. Telemac 3D is an open source software created by EDF and applied for computational fluid dynamics in the area of hydraulics. It is commonly to use Telemac for analyze large-scale phenomena. But at the moment, Artelia is interested in employing this software for simulating a screw. And the first step is to study the fine-scale hydraulic phenomena. Therefore, this work focuses on analyze Telemac 3D for fine-scale hydraulics based on two cases. The first one's called flatbed channel, and the second one called flow around the pipe. Both had been analyzed and compared with other experimental studies. Regarding the methods, and regarding the first case, the flatbed channel. The flatbed channel results are compared with vertical velocity profiles obtained in an open channel with smooth surface by Tachi. For the simulations, horizontal element size is about 5 centimeters for meshes MA and MA3, but it's different regarding the vertical element size because MA elements has a constant size, while MA3 elements grow from the bottom to the water surface. In addition, each mesh has been simulated with two turbulence models, K epsilon and K omega. The objective of this first case is to explore how turbulence model and mesh influence the dimensionless wall distance Y+. Regarding the second case, flow around the pipe, these cases use the rigid bed configurations showed in Roland and Nagel studies respectively for the comparison. Regarding this case, the horizontal element size varies from 0.2 meters to 3 millimeters. And for vertical element size is 1 centimeter. And K epsilon has been chosen due to its practicality. Regarding the results, as you see, there are two figures in the Upper part is the figure 1, and it's about the flatbed channel, and the figure 2 is about the flow around the pipe. Regarding the flat bed channel, as expected, inside the viscous sublayer, a higher mesh resolution better approximates physical measurements. The simulation MT4, which is with the mesh MH3 and K-omega model, presents the most acceptable behavior. This be in accord with the fact that K-omega model works well as long as the first element is ubicated on the viscous sublayer. In contrast, as you can see in the same figure, inside the logarithmic sublayer MT2, the simulation MT2 that has the MH3 mesh and K-epsilon model presents the furthest behavior from the measurement. This would suggest that K-epsilon needs the first element to be found in the logarithmic sublayer. Regarding flow around the pipe, velocity at the step equal to 20 centimeter, there is a good agreement with the other student. For vertical velocities W, Telemac 3D is closer to Roland numerical model. In general, none of the numerical models perfectly approximates the phenomena, but there is an acceptable concordance in order of magnitude. As you can see in the figure, in the two figures, as it's stated in the paper, the MT4 is which represents better the physical measurements, and the MT2 that is K-epsilon is the fastest behavior. And in conclusion, the flatbed channel is a suitable example for analyzing a wall function behavior. Results confirm that a wall function only transmits the viscosity effect to the main flow, but without simulating it. For obtaining the element, for obtaining the direct representation of the viscosity, it would require elements smaller than the thickness of the viscous sublayer. And from the two cases with the respective comparison, it can be seen that Telemac 3D is certainly capable of representing phenomena close to the boundary layer in order of magnitude, as well as vertical velocities. I'm sure that deeper code change would allow for better results. Thank you very much.
Thank you for your presentation. And now we move to the sixth presentation. The speaker is Minja Eli. And the title of this presentation is Numerical Study of Meandering Effects on Confluence Channel Flow by Open Form.
Okay, can you hear me?
Yes. Can you share the screen?
Sorry. Okay.
Okay, I will start on my presentation, and thank you for having this opportunity. My name is Minjeri, PhD student in Coastal Engineering Lab, Seoul National University. From now on, I will have the presentation for my study. The research objective is that an investigation of geometry and discharge ratio effects on meandering confluence channel flow. And then I introduce my research motivation. I looked around the geometric characteristics for river confluence in South Korea using the Google map like this. And it is found that nearly half of the confluence channel are located meandering channel. And the tributary channel joins a various degree of cross-section in meandering channel. In this picture, the tributary channel joins at this point, and this figure shows the tributary channel joins at this point. And also, the confluence angle has the various range from 30 to 19, as we know. And from this result, I confirmed that it is essential to understand the flow in meandering confluence channel. So I ran the several numerical simulations and using the open form, and I adopt the areas as a turbulence model. And then I made the full computation domain as shown in figure 2, and The difference between the cases is that the location of the tributary channel, like this, and the last one is the tributary channel joins the inner bank of the curved channel. That's the difference. And I determined the domain size based on the experiment conducted at Seoul National University in 2012. However, the experiment was conducted using the straight downstream, so I artificially changed the downstream channel shape from straight to curve with curvature 1.3. Then I applied the two discharge ratio condition. One is the 0.125 and another is 0.3. Next, I will talk about the result. These pictures shows streamwise velocity in each case. It can be seen that the velocity distribution is disturbed by the flow from the branch channel like this. I think you can see the distribution is disturbed. And in addition, the separation zone and shear layer are occurred over the certain section, and these are the basic feature of the confluence channel flow. However, the length of the separation zone and shear layer varied depending on the location of the tributary channel. The detailed value is written in this box, and I thought that it is because the high velocity is moved from inner bank to outer bank in meandering channel. These are the meandering channel flow characteristics. So it is inferred that these characteristics are affected by confluence channel flow and curved channel flow simultaneously. However, like the case B and D, when the discharge ratio increases, the meandering flow characteristics has weakened. The velocity gradient is very almost disappeared. And next, I also see the hydrodynamics along the shear layer using the vorticity field. These results show that the vorticity occurs strongly along the shear layer like this when the discharge ratio is increased. And that's the conclusion. I examined the flow characteristics in meandering confluence channel using the numerical simulation. Specifically, the effect of tributary channel location along the curved channel and discharge ratio are investigated. And that's finished on my presentation. Thank you for listening.
Thank you for your presentation. Now we move to the next speaker, Irei Bilgili.
Yeah, that's me. Can you hear me?
Yes, and
okay.
And your talk deals with the influence of a grid structure on hydraulic river modeling of schematized river meanders.
Yeah, I will share my screen.
Yes, please.
Okay, can everybody see this?
Yes.
Okay. So, okay. Hi everyone, my name is Edda. I'm from the Netherlands. I recently graduated from the University of Twente, where I followed the master track water engineering and management. The last piece of work I had to do involved a research into the influence of a grid structure, also known as meshes, on hydraulic river modeling outcomes. As many of you know, to evaluate the efficacy and impact of river interventions, a detailed insight and flow pattern in rivers is essential. A common approach to do this is by making use of hydrodynamic simulations, which solve the depth average shallow water equations. in these models, fully curvilinear as well as fully triangular grids can be used by the modeler, but it's also possible to apply a hybrid grid, which is a combination of a curvilinear and triangular grids. For illustration purposes, I included one here in my poster, here in figure 3, in which the main channel is discretized with curvilinear grid cells, and the floodplains are discretized with triangular grid cells. In previous studies, it has been shown that the accuracy and computation time of depth average models are substantially influenced by grid shape and also by the grid resolution, so the size of the grid cells. Nonetheless, in those previous studies, numerical effects, such as which are induced by, for instance, the numerical scheme which is adopted, or the orientation of grid lines in comparison to the flow direction, those numerical effects are interrelated with how well the bathymetry of the river is captured. So in order to isolate the effects, for a part of my master thesis, I set up schematized river meanders with a flat bed in the transverse flow direction. I set up 4 schematized river meanders, and those can be differentiated by a mild and a sharp bend, and the presence or absence of floodplains. As you can see in figure 1, a top view is given with a mild and a sharp bend, and both of them with floodplains, and a cross section is given in which floodplains are present and floodplains are absent. In the cases without floodplains, so only the main channel, I used curvilinear and triangular grid cells, and those can be differentiated in 3 different grid resolutions: a high, medium, and low grid resolution. For the curvilinear grids, I used 20, 10, and 5 curvilinear grid cells across the width of the main channel, so for the high, medium, and low resolution. With respect to the triangular grids, I used 8, 4, and 3 triangular grid cells across the width. For the cases with floodplains, I also included a hybrid grid, so triangular grid cells in the floodplains with curvilinear grid cells in the main channel, and I only looked at a high and medium grid resolution, so I skipped the low resolution part. In terms of the results, in general, it was found that coarser grids simulated lower depth averaged flow velocities, which at the end resulted in higher water depths. In the cases with only the main channel, it was found that larger differences were simulated between the grids in the case of the sharper bends, which is probably a result of rapid flow changes. When larger discharges were imposed, which led to higher flow velocities, larger differences were also obtained, whereas less numerical effects were obtained with curvilinear grids in comparison to triangular grids. When floodplains are included, negligible differences were obtained between the water levels, and which is probably a result of relatively less deviations in depth average flow velocities due to the involvement of floodplains, which at the end resulted in a damping of the numerical effects. So in terms of the conclusion, numerical effects become higher at higher discharges and therefore higher flow velocities. Numerical effects become also larger when rapid flow changes occur, for instance, in sharper river beds, and numerical effects are proportional to the discharge per unit width. So, for instance, for a case in which we only consider a main channel, numerical effects can be much larger in comparison to a case in which we have large floodplains. So if you found this topic interesting, I'm happy to answer your questions in the Q&A. And yeah, that was it.
Thank you.
Okay, let's start.
Now we move to the next speaker, Mika Weissman. And are you,
Yes.
Yes, are you here with us? And He will talk about turbulent flow structure upstream of an isolated boulder, implications for sediment deposition.
Yes, hello everyone. Let's see. I believe we should be good to go. Can everyone see? Okay, I think we're good. Yeah, hello, my name is Micah Wisman. I'm from the University of Tennessee in the USA. So from my end, hello, good late morning to you all. We've got all the different time change. My talk today is focused on my dissertation research, which is on really at the intersection of turbulent structure and sediment transport in mountain rivers. And in mountainous rivers, a key feature is the very common occurrence of natural boulders that occur atop the riverbed, which present obstruction to the flow, create flow acceleration, deceleration in their vicinity. So I'm performing laboratory experiments at the Hydraulics and Sedimentation Lab here. And so my talk today is presenting some preliminary results from my measurements here in a laboratory flume. I'm using volumetric particle image velocimetry system here, and a photo is down at the left. It's a 4-camera system, and I'm in the middle of performing experiments as part of my PhD, really trying to look at what flow structure looks like at the upstream region, upstream of a individual isolated boulder, looking at really the role of submergence, which varies for different flow conditions in a natural mountainous river. So what you see in the photo is a fully submerged boulder experiment. And so some of the results that I'm presenting here today are in the center pane, which are the mean streamwise and mean vertical velocity profiles. So the top pane presents the mean streamwise profiles, and what we see is the flow deceleration upstream of the boulder, which is a spherical boulder in this case. And the flow deceleration is well documented for different geometries and expected, with basically the largest deceleration of the flow at the height of the stagnation point, the basically mid-height of the boulder, which is at the upstream most point of the sphere. Another important thing to note about the mean streamwise velocity profiles is the lack of a flow recirculation region or a flow separation region in a mean velocity sense. This is evidenced by the still positive velocities near the bed. So this is a little bit different than what's commonly reported for, say, a cylinder case on a smooth bed, which is a classic configuration studied in many aerodynamics scenarios. So no mean flow separation is observed for these conditions. Also, the mean vertical velocity profiles show an inflection point right around the height of stagnation point as well, with upward directed velocities above that as the flow rises over top, and downward directed flow. And another important and interesting note is the significant negative velocities near the bed, just upstream of the boulder, which seems to suggest, as some others have suggested from PIV measurements in a rough bed flow around a cylinder as well, that there may be significant mass intrusion, flow intrusion into the porous bed, which is a topic that's been suggested, but hasn't been well quantified, is an important and interesting thing. So really, to conclude and kind of put some context, these measurements that I'm performing, really the goal is to understand turbulent flow structure as well as vortex structure upstream of boulders for different submergence conditions, and really trying to understand how those turbulent characteristics may play into sediment deposition and mobilization and development of unique bed morphological features around boulders. And that's really a part of one of the cited works that I'm a co-author, where there were some sediment transport experiments for a very similar setup to what I'm showing here. And so with that, I thank you and take questions in the coffee break.
Thank you for your presentation. And now we move to the last presentation. The speaker is Pietro Rastelli, and he will talk about optimization of the transfer velocity for ALSPH scheme.
Yes.
Yes.
Can you see?
Now we can see your screen.
Yeah. Okay. So hello everyone, and thanks to all the audience for being connected until the end. I'm Pietro Rastelli, a PhD student from University of Parma, and today I'm going to present a work called Optimization of Transport Velocity for ALE-SPH schemes. Smoothed particle hydrodynamics is a numerical method widely used in CFD, especially to simulate fluid with highly dynamic flow and fragmented free surfaces. The objective of this work is the optimization of a numerical scheme used, for example, in Pelton turbine simulation, in which, as we know, there is an highly dynamic flow. The water jet impacting the bucket in motion produce a very fragmented fluid. SPH scheme is well suited to simulate model this kind of problems. A brief recall of SPH method. They are Lagrangian meshless method. That means that there is no grid, no computational grid, but it uses fluid particle as a calculation point to compute all the field quantities. The particle distribution in the domain has a key role in the simulation quality. For example, hole or cluster affect in a negative way the quality of the SPH interpolation. So it is necessary to keep the distribution homogeneous to obtain a good result. For this reason, a different SPH formulation called ALE-SPH was originally introduced by Villa in 1999. This is not a Lagrangian approach because the particle position is not updated using the fluid velocity, but he introduced transport velocity that can be defined arbitrarily. The aim of this work is to define the transport velocity in a way to maintain the particle well distributed to guarantee accuracy of the SPH interpolation. So it has been introduced a correction term in the transport velocity, as we can see in equation 1, to maintain a regular spatial distribution, avoiding the creation of hole or a cluster in particle distribution. The correction in the reference formulation that we can see in equation 2 is scaled with the reference speed of sound, I value of C0 correspond to I value of particle shifting. C0, as we know, has a key role in the time step that must be used in the simulation. If we increase the particle shifting, we increase also the computational cost. So the choice between choice of the reference speed of sound is a balancing between the computational cost and the quality of simulation. In this work, we introduce an innovative formulation for the correction term that can be seen in equation 3 and 4 that aim to increase the particle shifting while keeping the reference speed of sound low. We tested this new formulation against the inviscid Taylor-Green vortex, and we compare it with the formulation in equation 2. In figure 1, we can see the trend of the error close box that is a tool to measure the particle concentration and the quality of the particle spatial distribution. Low value of ECB means good quality in the particle distribution. In figure 1, the orange line is the result using the new formulation, and the blue line is the result using the reference formulation, results are very similar, but we use a reference speed of sound 10 times lower. And we reduce the computational effort almost 10 times as expected. The computational costs are reported in table 1. And in figure 2, we can see the spatial particle distribution for different test cases. We use the reference formulation on the left and the new formulation on the right. But in this case, we use the same reference speed of sound. The distribution is really different. On the left, we have whole on and cluster of particle, and on the right, we have an homogeneous distribution. So to conclude, the proposed formulation preserve a constant particle concentration, as we can see in figure 2 on the left, that is necessary to guarantee the accuracy of the SPH interpolation, and without introducing any significant computational overheads. So thank you for your attention.
Thank you, Pietro, for your presentation. Now we are at the end of the presentations of the posters, and we can start our discussion with all the presenters and all the chairs of the session. And I would like to ask first if there are questions from the co-chairs for the participants to this session.
Hi, Claudia. Yes, I don't know, Ronald, if you have any questions. I'd like to also mention that there were several questions in the Q&A, and I see that most of them have been answered. And once we, Micah, I think there's a question for you. So we might get to that one a bit later. But starting from the very beginning with the well-balanced DG scheme, there was a question that was sort of answering in the Q&A, which was the oscillations in the transition. So can you explain a bit more of maybe how you can solve these oscillations in the transitions? It seems like there's a bit of numerical dispersion there. And I had another question regarding the dam break. So I'd like to know a bit more about what's the fruit number that you observe in the dam break, since close to square root of 2, which should be, and also how your results compare or would change if you put complexity downstream of the dam break, if you include meandering channels or sharp bends. And that's for Pablo. So then I don't know if Pablo is here or, yeah, he's not. Okay. I think he left. Okay, that's fine. And then
Pablo left the room. Then if we have question for Pablo, he's not here to answer to our question.
Yeah.
We can move. I don't know if anybody in the room has question to the second presenter, Leonard, so we can. Because I have one question, if you have other question, otherwise Leonard is here with us.
There's also another unanswered question in the Q&A that I could answer otherwise.
Okay.
So from David Ferraz, it's about like the difference between open foam and the code I'm writing, and about like operating on structured data versus basically arbitrary meshes that where the adjacency, if I understand this correctly, where the adjacency matrix has been reordered to like with a bandwidth reducing algorithm to create a more or less sparse matrix. Yeah, and the question is, what is the actual difference then in performance? And the answer is, I don't know. I haven't tested it yet. I will definitely do that, because especially the comparison to open foam is a really useful and valid one. I think because of the overhead that MPI has in comparison to OpenMP, for example, I think because of that, it's not even a fair comparison. Like if you have a program that can only do multi-threading via MPI and another that uses MPI and OpenMP, I think the one that uses OpenMP will always win. But I don't know. So that's definitely still on my bucket list, and I will, yeah. I don't know. Maybe if you leave me your email here, I will just forward to you as soon as I know.
Hi, over there, Leonard. I have a question for you.
Yeah.
Thanks for your presentation. I really enjoyed it. It's very interesting. Huh? And I have this question. If I'm not missing something, you mentioned that you are working on a kind of collaborative approach to work on the coding you are working on, right? The C++ coding.
Yeah. I mean, there are several people working on it. There's a master student working on it with me, but otherwise it's still mostly me.
Okay.
It's just that, okay, maybe I understand the confusion. There was another project developed over, I think over a decade now, written in Java that I referenced, where the whole solver logic was already established. And I am definitely like using that existing logic, and I implemented that into my new framework.
Okay. Thank you.
Oh, was that the question already? All right, sorry.
Yeah, but I mean, how do you expect, because this will be some kind of a given iteration of the code, right? So I was wondering how you are planning for the next iteration of the code, in which the code will be improved, if there's something to improve, I mean.
Yeah, so the overall idea is like why I even started this, and why also the professor at the chair said that this would be a good idea, is because the old code, because it was written in Java, could not be used for distributed memory calculations. So you can only run it on a local machine, and you cannot run it, for example, on like a supercomputer or something. So one of the things that that I started with is to create an MPI, like to make it work with MPI, so that like mesh distribution and all those things would work. That currently is only implemented for structured meshes. So one next step would definitely be to also add unstructured mesh support. Unstructured meshes are supported, but just currently only for local and like shared memory calculations. And because of the trend of using like GPUs in supercomputers, if there's still time, I definitely want to look into using not CUDA, but rather OpenCL to use accelerator cards to make it faster.
And just for curiosity, do you plan to organize some kind of workshops to share the code with some interested people that might be interested in?
I had no plans, but if you're interested, and given that I've already heard a bit of interest in the group, yeah, maybe, sure.
Okay.
It's definitely, I definitely will publish it. It's currently on GitLab already. So yeah, I want that code to be used by other people and like improved by like, so that people can give feedback and tell me like where I screwed up, so that overall it can get improved.
Yeah, open science, right?
Exactly.
Thank you. Let's see here. There is a question. I know there is also an answer for Jorge. Okay, and I have a question for Jorge. Since are you here?
Yes.
Okay. Yeah. Okay. And the aim is to investigate scour with your model, right?
Well, Artelia plans to investigate the score at the second step, but in my work, it limits to analyze the hydrodynamics of the phenomena. So, which I do is to try to know how it works at boundary layer for the first case, because in that part is well all the transport phenomena occurs. And in the second case is only as an example, because in that two research that is Roland and Nagel, the both investigates the score, but at the first place, both of them works with a rigid bed. It means only the hydrodynamics of the phenomenon. So with that, I compare my results with the hydrodynamics for Roland and Nagel tests.
But do you have an idea on in which way the scarring will be investigated in the future?
I'm not totally sure, but I think Telemac works like you can couple different models. So I'm sure that, well, the work that I have done, they're going to try to couple the model that simulates the sediment transport. But in the first case, they want to sure about how the phenomena is and how if the phenomena is well reproduced at fine scale, because then if there is happen, maybe there's probably that when the model is coupled, it works well hydrodynamically speaking. But when I was doing my internship, there's another friend that has doing his internship regarding totally about I don't know how to say, but it's like a sediment transport with telemetry. So they do like an experiment, that physical and numerical model, and for what I remember, they obtain a good results for that.
Okay, thank you. I don't know if any of the co-chair or the participants has any question for Jorge.
Jorge, I was wondering if you have kind of explanation why K epsilon and K omega yield different results. You have, have you worked on that?
Why there's the different results with the both of the model?
Yeah.
Yes, well, I think because it's in Telemac, the code is written like I think for K epsilon is the common K epsilon model, and also for K omega model is not K omega, is the basic Wilcox foundation, I think. So in that case, as I think as stated by bibliography, K epsilon model supposed to work better for the main flow. It means that the flow that is out of the boundary layer, while the K omega model works better for represent the flow that is close to the boundary layer. So when I did the research, it was like it was a good, well, it's not new, but it was sort of like it go of course with the bibliography. When in Telemac, for example, I try with the K epsilon, I try the two meshes, a finer mesh at the close for the boundary layer and a coarser, and also with K omega model. And for that, the result was just that with the K epsilon model, the better result was for the outer layer, in the low layer, but with more coarser mesh. And but with K omega model, it gets a better results close to the boundary layer with a more finer mesh. And also in the Telemac user manual, in one part it states that if we want to use K epsilon model, they recommend that we should stay the first element more than y plus more than 30, I think. That is the recommendation from the Telemac for K epsilon model, but they don't say too much for the K omega model in the user Telemac. Okay. if I answered your question.
Yeah, but maybe the answer is also related to the degree of vorticity you may have in your domain, I would say.
Okay. Okay, but regarding the vorticity around the file, no, around in the flatbed channel.
I mean, local vorticities that you might have in the domain.
Ah, okay.
That might explain why one is working better than the other one.
Okay. Yes, I think yes, because it's really that vorticity produces that, I think, just in the boundary layer. So it's supposed that COML represents better that behavior. So it can be explained like you say.
Yeah, maybe you might need to so play with some kind of by controlling some parameters, and such a way you might find a kind of answer for that for one getting an explanation for that kind of difference.
Okay, and what parameters do you can recommend me for taking into account?
Flow separation and vorticity, they are the ones that define if it's appropriate to use the K epsilon or the K omega. Maybe that's the general answer.
Okay, thank you very much.
Yeah, no problem.
Don't know if there is any question for Maria Chiara De Falco from.
Yeah, I had a question. I was interested with the experiment, since you have water with salinity and fresh water. Is there any influence of basically index of refraction changes? Do you know about that, or have you quantified or are you below any threshold that would affect, or do you? I'm wondering if you have uncertainty. I can't hear you.
Yeah, Maria, we can hear you.
Now, can you hear me?
Yes.
Yes.
Okay. So I was saying that I did not mention that we had a density difference of 10 kilogram per meter cubic. So I think that this density difference is not an issue for the problem that you are saying. So the reflective index.
Yeah, that makes sense. Sounds good. I was just curious.
Yes, it was a low density difference, and so we studied these. Actually, we did PAV combined with LIF, but we analyzed all the PAV data and in terms of velocity distribution, and yes, that's all.
Yeah, thanks.
I have a question for you, Maria, but I had problems hearing you. Maybe you might, yeah. So you have presented a very interesting work as well.
Thank you.
I really enjoyed it, and just to let you know, we are working on modeling the Magdalena River. Okay. That's the main river in Colombia. So we are modeling the mouth of the Magdalena River and which discharges at the Atlantic Ocean. So something that we have observed in at this point is just numerical modeling. Yes. But what we have observed is that the models they poorly represent the flocculation effect of salinity.
Okay.
So I was wondering if you have considered that kind of effect in your or maybe observed that kind of effect in your experiments.
Well, no, actually, we did not observe this kind of effect. We did measured density through conductivity probes, and we are trying to analyze also these the effect of some mixing processes between the two counterflowing water masses. And yes.
Okay, thank you.
Claudia, I don't think we can hear you, Claudia.
Sorry, I forgot to open my microphone. I was asking if there is any question for the other presentation from Maria Rita Maggi on gravity currents. No? Okay. And then we have Mangiali.
Yes.
Yes, I have a question for you. Which kind of Smagorinsky model did you use in your simulation? Is it a dynamical Smagorinsky or it's a static one?
No, I just adapted the classical Smagorinsky subgrid model because it's the early study of the meandering conference channel flow. So I just tested the simulation with just a classical model.
And another, you mentioned that there are Kelvin-Helmholtz billows developing. Did you check it? That are exactly Kelvin-Helmholtz or? How did you classify this kind of instability?
You mean the Kelvin-Helmholtz instability?
Yes.
Yeah. So, please tell me your question again.
And are you sure that are Kelvin-Helmholtz billows or something different? Did you check it by evaluating any quantity related to it, or just by visualization of the vorticity, you decided that these are Kelvin-Helmholtz billows?
Unfortunately, I didn't check this phenomenon through some values. I just decide this phenomenon through just visually. So I will check these things.
I have a question, Minjay, which is regarding the treatment of the free surface. Did you consider a rigid lid on top, or was it volume of fluid? How do you consider the free surface?
In this study, I assumed I adopted the rigid lid assumption.
Okay, maybe it's worthwhile to try also like a deformable free surface, especially when you have 90 degrees confluence, then you see a dip when they join right at the apex, and that can affect the flow right in the confluence. So maybe you can try something like that for in the future.
You're right. The confluence channel flow and meandering channel flow should be considered a free surface variation because the pressure gradient. So I will try to adopt the Voyeur method or other things.
Okay, and also I have a question regarding the figures that you were presenting. They were, I'm assuming that they were averaged over a certain amount of period of time.
Yes, in figure 3, the result is the time averaging result, and I calculate the vorticity using the instantaneous velocity, definitely.
Sure, and for how long did you average the solutions?
I averaged in 30 seconds.
Okay,
30 seconds because
no, please go ahead.
I saw that the one cycle flowing one cycle through the channel is about 10 to 20 about. So, and that's why I averaging in 30 seconds in this study.
Okay, maybe a little, which is great. If I'm being fair, but maybe something that you can try is check the time scale of the vortices that are of importance to you, and over that time scale, try to define, I don't know, 50 solutions, and then times 4, maybe you have like 200 solutions that you can average, and they'll probably going to give a more average figure of what you want to observe. But thank you.
Okay. Thank you for your advice.
I have a question for you, Minjay. We know that the conferences, I mean the behavior of conferences are highly dependent on the degree of discordance between the tributary and the main channel. It means the location of the main channel bottom respect to the tributary channel bottom.
Yes.
How have you represented that?
I already said that I adapted the domain size based on our experiment, and this flow has the discordance of adjusted discordance depth 10 to 20 centimeters. So in this study, I applied the discordance about 10 centimeters, and total water depth in the downstream is the 30 centimeters. But I would like to test more discordance case, but until now, the simulation time is very long, even if I use the high performance computing. So I only apply the 10 centimeters for the discordance.
Okay. Okay. So some years ago, I have published a paper in Meandering Rivers conferences. So maybe it might give you some additional, maybe ideas to discuss on your future publication. So it might be helpful for you, I would say.
Okay, thank you.
Yeah.
Nope, there is any other question, because I think we are just 2 minutes till the end of this round table. Any other question for any other participant?
Claudia, I'm sorry. Are you following the list of presenters, or can just?
Now I skip it. I try to follow it, but now we have only 2 minutes. Then, if you have a question for anybody, you can ask it.
I was hoping I could be here for the entire conference, but I could not. I had another meeting, and I missed most of the presentations here. But I did have a question to Lennart Stefan, because I did read the abstract, and then I read it better, and maybe my question is not so practical anymore. But you say that you take about 80% of computation time in solving fluxes, basically.
Yeah, that's correct.
In your abstract, and I was wondering, how do you sweep the space, the computational space, by cells or by edges? Because we find some differences in both. And in fact, what we miss in our model right now is a good balancing, load balancing that you have now. But we did find major improvements when you switch to cells.
You found improvements when you switched from traversing edges to cells?
Yeah.
Really? Because we did it the other way around and also found improvements.
Oh, really?
So the old model does it, like the one that this is based on, it does it by cells, but therefore it has to do every flux calculation twice, right? Because the flux that goes over one edge, you know, like it's the same flux for either side of the edge, right? But when you go by cells, then you have to calculate it once to go out and for the other cell to go in. So overall, like the amount of like the naive idea would be you'd have twice as many calculations if you traverse cells rather than edges. But yeah, actually, we're trying that out right now. There's a master thesis that I'm supervising, and that a part of that one is to look into like how the performance difference, like how the performance differs when it's traversed by cells rather than edges. But the whole framework is designed to traverse edges.
Right. I'll send you the paper in which we published that, and maybe we can discuss the what is different in both approaches.
That would be very nice.
Thank you. Once is GPU, and the GPU can do a lot of calculations, not really an overhead. But yeah, well, we'll keep in touch then. Thank you very much for the opportunity.
Sure.
Claudia. Yeah.
Thank you. Well, I think that we are at the end of the roundtable, because now there will be the closing ceremony of this first Web Young Congress. I wish to thank you, all the participants, for your presentation. I was impressed on the quality of your work. And I wish to thank the co-chairs for your participation in this special session on fluid mechanics. And well, I hope to meet you soon in presence. And I think that we can close this session now. Thank you all.
Well, thank you so much, all of you.
Thank you all. Have a nice day.
Bye.
Bye-bye.
So now that all of the sessions of this YPN Congress are finished, we come to the final part after quite a journey of months of planning and now 2 days of intense talks and discussions. And let me just share a few thoughts and a few ideas around that. So let me see. I'm just going to share my screen. So a couple of numbers and observations from this Congress. We did receive nearly 1,000 registrations, and we had 70% from non-members, which is a great number, but I would say maybe we should call them not yet members. So you're highly invited, really cordially invited to join IAHR and Young Professionals Network. We had 145 abstracts, and from that we had 12 really exciting sessions in the presentations by the young professionals, and from what I've seen in the past 2 days, really fruitful discussions in the coffee break sessions. And I would also like to thank the senior researchers who mentored these discussions so skillfully. We had a wonderful keynote by Angelos Vindikakis. And just to show the importance of YPs and this Congress was opened by our President Joseph Lee and will be closed by our Vice President Silke Wiebrecht. And such a Congress is just not possible without people organizing it. So we had an organizing committee with only 4 members, but we were really well supported by the International Scientific Committee with over 50 members and a lot of great support by the IAHR office. So you might be wondering after this event, maybe this was your very first IAHR event, or maybe you're an old timer and have been to lots of these events. But if you're a new young professional and you've just joined this, I would highly recommend you join our webinar series for young professionals. I also highly recommend that you participate in the Young Professionals Challenge. Maybe write a paper for an IAHR journal and participate in the IAHR World Congress and in the events that are happening in the next year online. And I would even more recommend to join a local young professionals network in your region. And if there isn't any yet, start your own. From my own experience, I can say this is a very valuable experience and a good way to get into IHR and into the professional life in hydro environment. But just a reminder about the challenge. So go to the website and register. And as you can see with all of this that happened today, there is not much that needs to happen to close this Young Professional Congress. We only have 2 more points on the agenda, and I think 2 really important points. So we have the winner of the 2019 Kennedy Award, Camila Timana Mendoza, who is also the president of the UTC WER Young Professionals Network, who will be sharing her views now. Over to you, Camila.
Thank you. I'm going to share my screen. Can you confirm that you can see my screen?
Yes.
Yes. Thank you. Well, thank you for the introduction. Good evening, everybody. Morning and afternoon for some of us. Thank you for the invitation. My name is Camila Timana Mendoza. I am an environmental engineer student at the University of Technology and Engineering, UTEC. I'm president of the YPN UTEC Water and Environmental Research at Lima, Peru. Today, I really appreciate being here in the first IAHR Young Professional Congress, participating as a speaker, attending, and author of 2 works. I would like to talk as a young professional about our network in Peru. In February 2018, where YPN was created with environmental engineering students, since that moment, we have grown as an organization and as a team, which makes all of us proud. We are organized in 4 sub-departments inside the organization, one dedicated to academic activities, recreational activities, the other one's about research department named Water Science, and a sustainable department. It wasn't so easy, but one thing that we consider very important and a key factor for growth is sharing knowledge from one peer to another, sharing some experiences from one member to another member, which contributes to the personal development and development of the team. Another thing that is important to mention is that we have common interests, a main goal we all want to chase, We hear all the opinions of our members and impulse their ideas. That keeps us, makes us keep working. Even in this pandemic with permanent virtual meetings and integrations, as you can see in the pictures, because some of us didn't know each other personally, the new members we know. So in this way, we have developed 2 new directions within the chapter, one dedicated purely to participatory research in a dynamic way with university students, which unfortunately was interrupted due to the sanitary pandemic and the limitations we're affronting nowadays in Peru. But we're already reactivating it with a project about endangered wetlands located in my community where I live. As we can see in the figures, these wetlands have reduced its area and it has many problems of sanification, so we want to contribute a little bit with our work. The second one we want to promote is the Department of Citizen Science, where we aim to share knowledge not only to our classmates or university students, but also to the population in general, starting with children in schools. By a monitoring program of the river near them, near their schools, we want to find schools which are located near the river, so we can make this program and strengthen water resource education in them in order to find solutions from them and for them. If someone here is from Peru, we know that we have many issues here about the Rimac River or the Surco River. Additionally, as I mentioned before, we presented 2 works in this Congress, one of them about microplastics pollution on the Peruvian coast, and the second one about river floor monitoring based on citizen science for the Rimac River, one of the most important rivers in Lima, Peru. Also, one of our members is participating in a project evaluating the risk of changing mountain glaciers. All these steps make us know that we are on the correct path, but we're still on the journey. We need and we want to grow much more. In 2019, I received the YPN Kennedy Award with Siddharth Seshan, who is in both pictures too. This was a great opportunity, not only for me and my professional development, but also for the YPN community. It gave me perspective and inspired me to continue in this field. This experience, accompanied by other ones, made me realize that research is an area that should be further developed in Peru and in general in Latin America. For me, it's very important to talk about Latin America at this time. Perhaps some of you know, or perhaps not, that in Peru we're experiencing a very big political crisis, Pacific manifestations all over the country. I cannot talk about Peru without remembering the life of 2 young students who died for defending democracy in these manifestations the last Saturday night that resulted in more than 100 injured people caused by police repression. It's very inspiring to see all young people making their voices heard for a better world, for a better country, and for clean politics, which we have also seen in many other countries like Chile. In our region, Latin America, we can find many difficulties in various aspects, from the political and educational sphere, the lack of gender equality, the poor environmental management in a region so favored in terms of biodiversity and natural resources that seems impossible for some of us to think that almost nobody seems to care. And we have to question as young professionals why environmental conservation, why science is not a priority for us and for our authorities. However, I am very optimistic. As I said, we also see young professionals, young people wanting to make a difference, wanting to contribute with their work, and being able to share and communicate. Passionate young people. I've been told many times in my life that I am very intense or very passionate about what I do. I don't know if they say it as something wrong or something bad, but I consider that it's the best they can tell me. because we need intensity, we need passion, we need vocation service, because we have a reason that really matters for us, that we truly believe and feel. I know that this intensity exists and passion exists in some of you young professionals. I've been watching your work, maybe not because of personal recognition or personal interests, but because of what is behind this desire to share work, to help others, of course, our environments, and improve science, to share knowledge for better decisions in our authorities, for making progress in the political management of our resources, which is a big issue here in Latin America, for a change of concept in the community, and most importantly for me, for spreading this passion. We are passionate people, we see the problems and we want to do something about that. As here in Peru's people is saying, we are a new generation. For that, I consider that our role as young professionals is very important. Not in the future, it's very important now. We cannot go back, we cannot be indifferent of what is happening. Personally, I think that we cannot research, we cannot study, we cannot even work without knowing the reality of your country, of your community, of what's happening around you. It's very, very important. And for that, today, I want to invite my young peers to wake up and remember that we want to do this for others, and also encourage you to raise your voices, communicate, and always do what you do for a reason, but for a bigger reason, one that matters for you, one that you really truly believe, that you feel, that you think that is a correct thing. So just to make it clear, we have to know the reality of our community, know what's happening, look for the problems, and do something for it. It's really important. And of course, do it with passion. Thank you very much. Gracias.
Thank you, Camila. So I would now like to invite our Executive Director, Tom Su, to just say a couple of words.
Sure. Thank you, Eva. Thank you, Camila. Thank you, David. Thank you, Elsa from the Secretariat. Thank you to all of the participants at this, our first Young Professional Network Congress. I hope you have all enjoyed it. I've been connected in the background and listening and watching with pleasure over the last few days. And I must say that I am inspired and enthusiastic to see the keenness, the motivation of all of the participants. I hope you've enjoyed the last few days. I think the words that Camila just left us with were very inspiring, so I don't think I need to add more to it. I can only agree with you 100%. And also from Siddhartha, who also our Kennedy Award winner, who gave some opening words. I will probably just end my short note, thanking everybody, inviting all of the members who joined us, as well as the non-members, to consider joining us in future events, which will be coming soon. So in 1 month's time, in December, there will be the 85th anniversary of IAHR, and we'll be hosting another online event, and you'll be more than welcome to join and participate in that one. Next year, there will be the online forum in probably beginning of July next year, which will be an event inviting not just the young professionals, but also all of the professionals in our sector to work together. And then, of course, in 2022, the IAHR World Congress. So you're more than welcome to participate in these, plus all of the other events that are organized with our technical committees. With that, I'll finish my short note. I hope you've had a great time, and I look forward to welcoming you to other activities with IAHR in the future. And I look forward to working with our teams to seeing if we can do another one of these events in the future, because I think it was very successful. Thank you, Eva.
Thank you very much, Tom, for your note and your comments on this event. So now I would like to invite Professor Silke Wiebrecht, our Vice President, to close this Young Professionals Congress.
Yeah, thank you, Eva, for giving me the opportunity to give some last words. So my name is Silke Wiebrecht. I'm full professor in Stuttgart University of the Institute of Modeling Environmental and Hydraulic Systems. And I'm also vice president of IHR. So while planning the event, I was asked to give some closing words, and I also got a little list of keywords, what I should say, something about the past of the YPN and how is the development, the history, and also future plans, and how it fits in the strategic plan of IHR. And then during the sessions, I realized, okay, Sid said something about the IHR, the YPN, and David and Eva. Why should I repeat that? Yeah. And then Joseph said something about YPN and the strategic plan. I don't think that it makes sense to repeat this as well. So I thought, okay, I have to change my plans. I have to do something different. Yeah. So the question is then, what should it be about, these closing words? And yes, for sure, first of all, I want to thank everybody. But this also Tom already did. Nevertheless, I just want to repeat, because I want to give a big thank you to David, Eva, Jose, because you initiated everything. It was your idea, and I think it was a really great event, and we never had this before, and I hope that we will have a lot of them after that. But I think, first of all, a big thank you to the three of you, because you had the idea and made it happen. Then also a great thank you to the Madrid office. So I know Elsa, Victor, you did a great job in organizing everything. And Tom, you opened the field that this could happen. And this was really amazing. So a big thank you to the Madrid office as well. For sure, a thank you also to the mentors and chairs of all the sessions, because you made the work ahead with reviewing all the papers and selecting the speakers, making the sessions vivid, and also working during the discussion and keeping that alive. So this was really great. A thank you to all of you. And finally, for sure, to all of the presenters. So Joseph, who gave the opening speech, and Angelos Fendikakis, who made the keynote lecture, and for sure to all of you who presented your posters, your research, and your work that you did during the last years. So, but what makes a good closing remark? It's not only giving thank you, I think it should also have a kind of take-home message. But what could be the good take-home message? So the question, maybe the key question these days is what is really important? And I think what is really important is maybe health and happiness. So I'm not a medical doctor, so I can't help with health. This is something what you have to do in a different place. I have no experience and no expertise in this field. You might wonder what she's talking about, happiness. Maybe I also have no expertise in this field, but I want to refer to a presentation that I heard, and this impressed me a lot. Yeah. So what makes you happy in the end? Yeah? So is it material goods? A lot of people think like, okay, if I have a big bank account, then I'm happy. Yeah? So the material goods, yeah, you can go for shopping, get a pair of shoes, makes you happy for maybe a day or two. But are you sure that you can recall this kind of happiness 2 years later? I don't think so. Yeah? Okay, maybe you have to go for bigger things. Maybe you want to buy a big sports car, like a Porsche or Mercedes or Ferrari or so. Yeah, makes you happy, maybe a month or two or a year. But are you sure that you can recall this feeling of being happy for the rest of your life? I'm wondering whether this would happen. Yeah? But the essence of this presentation that I heard was, in principle, it's two things what makes you happen. One thing is working hard and achieving something. Yeah. So, and this is exactly what you are doing, all your young professionals or the professionals at all. You are struggling with your models, you're working day and night, you are struggling with instruments which don't work, a model which has a kind of a own will because it presents results which is totally strange, what you didn't expect, and you don't know what happens there. And then in the end, you get the result and you see what a good result and think, yes, that's it, yeah? So this was working hard and achieving something. And this is a feeling what you always will be able to remember. So first conclusion, working hard makes you happy. Second thing what makes you happy is connections, friends. I think each of you can remind or remember a nice party, an evening with good friends, having good talks, just enjoying your time and being together with other people. And this is where exactly YPN comes in the game. So this is an opportunity for networking with young people who have the same feeling, the same approaches, the same interests. So use this opportunity to network, to make friends. Yeah, these days, everything has to happen online. But I'm sure when you come to the next Congress in Granada, for example, this is the best area, the best stage to find friends, to have nice evenings, to enjoy the company with other people. And this is what you will never forget. So my take-home message to cut this short is, on the one hand, go on with your scientific work, work hard, and make yourself happy and join IHR. So I hand over to you, Eva. This was the part of the advertisement. So, and I wish all of you for sure good health and always fun with your work.
Thank you very much for your closing remarks. So with this, I would also like to thank everyone yet again for attending, for being part of this. And I hope to see each and every one of you at one of the next IAHR events. Thank you all for participating.